Yes, good morning guys to all of you. I welcome you all on this wonderful platform that is BYJU'S exam prep. So guys, as you remember now common subjects, strength of material, fluid mechanics are over. So from today onward we are having the marathons for other subjects like we are having production today. So guys, when we are talking about production, you know production is a very vast subject, the highest weighted subject. Whenever we are talking about production, the very important thing is last time 23 marks were given to the production. And guys, when we are talking about it is a very big subject: casting, welding, metal forming, sheet metal operations. Then we have metal cutting, then we have metrology inspection, then we have computer integrated manufacturing, then we have material science. Yes, Ravan King, good morning. So jaldi se session ko share kar dijiye, like kar dijiye, so that we can start the session. Other student can also join. Okay, I am also once again sharing it क्योंकि काफी लोगों की नींद नहीं खुली होगी आज सुबह 10 बजे, है ना. So let me share it. Okay, so guys, be ready. Today this is going to be a session which you will never forget, and we are going to do the production in such a way that theory would be there, numerical would be there, both the things would be there, and also I am telling you each and everything I would be covering in such a way that you are going to get the complete package today. Okay, you are going to get the complete package today. So are we ready guys? Are we ready? Yes, fine guys. Yes, good morning Rutvik, good morning Aniket, Overload, good morning Lakshmi, good morning, very good. So guys, when we are talking about today's session, what is the agenda for today? Today we are going to cover metal casting, welding, and also the sheet metal operations. If you ask me the weightage of these three parts, I would like to tell you guys approximately 6 marks, 5 to 6 marks you can expect from today's session. Okay, and guys, likewise we would be having one more part where we will be discussing the other topics, that is metal cutting, metrology, computer integrated manufacturing, and then we will be having material science and metal forming. Likewise we are going to cover, yes, Anupam, good morning, Prashant, good morning. So we are moving further guys. This is some detail about me, those who are watching me for the first time, and you know that today's subject is related to the production technology. You know the highest weighted subject, 23 marks were the weightage last time, and generally also it is coming out to be more than 15 marks. 15 to 17 marks is the average weightage, but last year it was increased to 23 marks, but this year also we can expect more than 17-18 marks. So guys, you know from 9th January we started this, and this is the schedule once again I am showing. So today we are here at third marathon, that is casting, welding, metal forming. Then we would be having basic thermodynamics, then TOM and MD. So this weekend once again we will be meeting for TOM and MD. It is going to be a wonderful weekend this time. Abhishek, Jai Hind bhai. Sandy, good morning. Yes. Definitely Abhishek, if you want to revise with me. Abhi Patel, good morning. And guys, next we are moving further. On 14th of January, you can appear for the scholarship test to get up to 90% of the scholarship in the GATE preparation programs. And guys, this is the mega mock challenge plan. Those who are watching for free full mock length test, free full length mock test, I would like to tell you now, on 13th of January and 27th of January, 2 mega mock challenges are still left. They are going to be for full syllabus on the GATE pattern only. So be ready if you have not done yet. And below this link, you can see there is a link available where you can fill the Google form. And when you will be filling the Google form, you will get a chance to have a personal counseling, one-to-one counseling from our counselors. Okay. Hard here, because if you remember yesterday night we were having a midnight session, but no issues guys, we are habitual of these things in the marathon days. Definitely Rahul, questions bhi honge. So we are starting the session. So guys, whenever we are talking about no Rutvik, don't worry that some changes would be made, don't worry. Okay, we will try to avoid the clash. Okay, fine. So guys, as I told you, like in the strength of material also, when we were teaching you, we have taught you from very starting, from very basic till last. Means everything was starting like that. If a new student is also in the class, he would be learning something. The same procedure we will be following in this production part also. So when we are talking about production, the very first question comes that what is the difference between production and manufacturing? So guys, this question you must have faced many times before also. Yes, Vishal, good morning. So when we are talking about production and manufacturing, guys, whenever we are talking about mechanical engineering point of view or engineering point of view, then my dear, we are talking about manufacturing and production. They are going to be same thing. There is no difference between them. Many student feels that production is used for the modern technology and manufacturing is used for the old technology. There is nothing like that. I would like to tell you that whenever we are talking about production and manufacturing, they are same with respect to mechanical engineering. But yes, production is something general. And from this production, you can say manufacturing is a small part of this. Why I am saying that? Whenever you watch a movie, in the star cast, at the end they show the star cast. It is always written produced by. Have you ever seen manufactured by? No. My dear, when you were studying biology, you were studying reproduction. Have you ever studied remanufactured? No. So we are production of our parents. We are not manufactured by our parents. So the point is, production is something very big, out of which manufacturing is a small part. Yes, production is very highly scoring subject. If I am saying if production is coming out of, let us say 18 marks, then from 18, 12 to 13 marks, any student can very easily get, even if he is not 100% prepared. Okay, yes, you can get 100 out of 18 also. But I am telling you this much, and every student can also score in production. That is the advantage of production. So guys, yes, it is highly scoring. So now we are moving. So if someone will be asking you production and manufacturing, you will be saying production is more general, manufacturing is a part of it. With reference to mechanical engineering, both production and manufacturing are same. Manufacturing, why I am saying is a part of production, because production can be used for anywhere. Like whenever you see a painting, they are also written produced by. They don't write manufactured by. So production is a generalized word. Now, my dear, whenever we are talking about the production, what are the topics I already told you? And today's topic we are going to study as in this sequence. First, we will be going for the welding. Then we will be going for the casting. And then we will be going for the sheet metal operations. Now, my dear, as you know, it is not a design subject. Like when you were studying the strength of material, there were interesting formulas and also numerical part type of things were there. But whenever we are talking about production, as it is theoretical, but still GATE is asking wonderful numerical from that. And if GATE is asking wonderful numerical from that, our concentration would such that with the topics we will be solving some good questions, so that you get an idea what kind of questions are coming in GATE. So it is not going to be a total theory session. It is going to be theory with wonderful question practice. Is it clear for everyone? So we are going to have a wonderful combination of theory as well as question. Yes, Falendra, Akash, good morning dear. How are you? So do like and share the session. Then we are starting the welding. So my dear, whenever we are talking about the welding, you must be remembering the day when you entered into your college. Because in the first year, you must have seen there were some laboratories of production where you were having some welding lab, you were having some foundry lab, you were having some carpentry lab, you were having some machining lab, you were having some metrology lab. Everybody remember that? And if you remember, when you were going to the welding lab, majority of the students were having a fear कि it is not a process which is very easy to do, it is not a white collar job. And whenever you are going for mechanical, you are definitely ready for this thing, because this is a core part of mechanical. So whenever we are talking about welding, this type of welding you have seen in your college in the very first year. Even computer science student, even civil students, even EC students, even EE students have to go through this. And you know what we are going to do that? We are actually having the two plates. Then we are having this electrode, and you know this electrode is going to get melt out and making a layer over that. So this is the very basic type of welding we are talking about. So I was just showing you for which process we are going to start with. I will be telling you each and everything related to principle and everything. So don't worry about that. Just let us enter into the welding, what it is. So my dear, as you can see here, two plates are going to be joined. So welding is generally said to be a process of joining. That's why it is nothing but a joining process. And my dear, whenever we are talking about joining process, it is a joining process where two metals generally we are going to join with or without the help of heat, with or without the help of pressure. So my dear, welding is a process of joining two metals with or without the help of heat or pressure or both, with or without the help of filler material. What is that? Everything we are going to see. Okay, so my dear, this is the definition of welding process, what we have just said. And before we enter into the welding, I would like to tell you about the weld bead geometry. So this is the figure which is shown to represent a weld bead geometry, and you have just seen the welding to be performed. So you would be knowing this is the part which is going to be the result of the welding majorly. And my dear, this yellow part, we are calling it as weld bead. Just listen to me properly. And I am telling you guys, I would also be sharing you wonderful handwritten notes for production. Even they are already shared on my Telegram channel. If you want, you can open them along with the class. That will also give you one thing, that everything is written, because production is theoretical subject. So you need everything written, and that is there. So when we are talking about this, this is said to be the weld bead. And my dear, when welding is going to happen, majority time we are using the heat. So definitely because of that, the nearby region of the welding, whenever we have some nearby region of the welding, this nearby region of the welding is going to be affected by heat. So that is why we call this part as heat affected zone. And my dear, which part which is near, that is going to be affected by heat, but the part which is far away from the welding area, that is not going to be affected by the heat. So that we call it as unaffected zone. So if you see, there are three parts in the weld bead geometry. Number one part is weld bead. Number two is heat affected zone. Number three is unaffected zone. And my dear, whenever, very good Aniket, Zakhmi Atma. So whenever we are talking about the weld bead is divided into two parts. You can see one part is inside the plates, other part is external. So this inside part is said to be penetration, like it is written, and this outside part we are calling it as reinforcement. So I am showing it with green color. Green color is for reinforcement, and rest you can see is the penetration. And a majority part of the reinforcement is going to be removed after the welding process. Okay, it is not going to be the part of plates. Good morning, Kunal, how are you, dear? So this is how the weld bead geometry is going to be performed. I'm going to tell you each and everything. Here you have seen there are three things. Number one is weld bead. Number two is heat affected zone. Number three is unaffected zone. So my dear, whenever we are talking about these three things, I would like to tell you, when you will see the strength wise, then weld bead is found to be the strongest part. Unaffected zone is found to be the in-between, and heat affected zone is found to be the weakest part. You may be thinking, sir, what is the reason behind that? So I am giving you the reason. So my dear, first of all, I would like to tell you, like whenever you are going to weld two plates like this, just imagine you are going to have a welding process and you are going to weld these two plates like that. So whenever you are going to have an electrode, because of the higher voltage, some you can say spark is getting produced, so heat is getting produced. So my dear, whenever you are going to do welding, then my dear, what is going to happen? This electrode is going to get melt into the groove. So when that electrode is having some flux coating, what is flux coating? If you see, there is a wire electrode on which some special coating is available, and that coating we are calling it as flux coating. And this flux coating is having material different than the plate material. So that is why when this will be melting and going into the groove, then my dear, what is going to happen? This wire is made up of the same metal for which you are going to do welding. This flux is made up of different material. When two components are going to melt and meet with each other, they are going to form alloy. So that is why you would be getting alloy part in the weld bead. And as weld bead part is consisting of alloy, alloys are considered to be having better properties than the pure metal. That is why you will be always finding that weld bead is going to be the strongest part. Then my dear, whenever we are talking about the heat affected zone, as while welding you are going to have some heat also is going to be produced. So during welding, some heating is going to happen, some temperature is going to be achieved, and after the welding is over, cooling will also be happening because of atmosphere. So guys, when you study heat treatment, what we do? You heat to make austenite, to go up to austenitic range. You hold up to that temperature, then you are going to cool down. And whatever the heating rate and cooling rate you are going to have, based on that you get some kind of structure. Based on that you get some type of properties. So my dear, here whenever we are talking about heat affected zone, the same is happening with this heat affected zone. It is getting heated, hold it at that temperature, then getting cooled. But we are not having any control over that. Why? Because our purpose is not to improve the properties, but our purpose is to do the welding. So when we are not having the controlled heat treatment, like whenever you take medicine, if you take in the desired amount, it will definitely help you to save your body from the disease. But if you are going to take in uncontrolled manner, the same medicine can make you die also. So the same thing, my dear, whenever we are doing the heat treatment purposely, it is improving the property. But here heat treatment we are not doing, it is happening automatically. So because of that, this heat treatment is not going to be controlled and it is uncontrolled, so it is going to harm the properties. So that is why heat affected zone is said to be the weakest part of the weld bead geometry, and unaffected zone comes in between. So my dear, if someone will ask you, you will be saying that weld bead is having the highest strength. Why? Because of alloy content. Because of alloy content. And when someone will be asking you that why heat affected zone is the weakest one, because of uncontrolled heat treatment. Because of uncontrolled heat treatment. Because of uncontrolled heat treatment. And unaffected zone is going to be normal. From here, one theory question, the very first theory question is going to be formed. That question is, my dear, that if I am going to increase the welding speed, what will happen to heat affected zone? Yes, Ajay, yes, Sandy, yes, Zakhmi Atma, yes, Neeraj, yes, Kunal, Aniket, Fanendra, Curiosity, Vishal, what will happen? Can you tell me what will happen for that? Yes, if welding speed will be increasing, you are going to hold the electrode with the workpiece for lesser time. Because of that, you would be having, my dear, a decrease in heat affected zone. Why I am telling you this point in the starting? Now in the upcoming welding processes, whenever I will say welding speed is very, very high, you automatically understand that heat affected zone is going to be very, very less. Is it clear for everyone? Yes. So you automatically get that heat affected zone is going to be very, very less. So this is the story. Then, my dear, whenever we are talking about these three things, you have already seen the weld bead geometry. I would like to tell you here one more thing, that if you are going to make a tangent, here, then, my dear, this angle is said to be angle of convexity. This theta is said to be angle of convexity. And I will be completing with one last thing. Then we are going to enter into the one by one welding process. I will tell you with the historical point of view. Yes, very good, Dheeraj. So whenever we are talking about this, this is angle of convexity. Here there is a term defined which is said to be percentage dilution. I already told you we try to remove the reinforcement part after welding in general. So that is why percentage dilution is defined as the area of penetration, but a area of penetration plus area of reinforcement. So guys, percentage dilution is defined as the ratio of area of penetration to the area of penetration plus area of reinforcement. And area of penetration to area of reinforcement is nothing but the area of weld bead. Is it clear for everyone? So this is said to be the area of weld bead. So area of penetration, but a penetration plus reinforcement is said to be percentage of dilution. I feel everybody is clear for this. Moving further, guys. Moving further, guys. So this we have already seen. Now, my dear, we are going for the very first welding process, and I would like to tell you the very first process we are going to study as shielded metal arc welding process. And whenever we are talking about shielded metal arc welding process, it is a type of arc welding. And when we will be talking about a particular type of welding process like arc welding, resistance welding, I would like to tell you, okay, no issue, TPM. So whenever we are talking about arc welding, it is going to have same principle. So whatever the types of arc welding we will see, the principle is not going to change. Okay. So my dear, whenever we are talking about arc welding, what is the principle we will try to understand? Let us say we are having this as workpiece. Okay. We are having this as workpiece and we are having this as electrode. This as electrode. You know, in the electrode we have a wire and this is the flux coating. This is the flux coating and this is the electrode holder where you are going to have it, and there is the power source and here we are going to connect them like this. You know, whenever you are going to connect with the power source, there will be some DC, some AC, that kind of power. Let us assume it is DC power. So it would be having some positive, some negative. Very good, dear. So you would be having some positive, some negative. As workpiece plate is thicker, let us assume we are going to have positive here and negative here. So we are going to provide positive to the workpiece, negative to the electrode. So my dear, you know, whenever we have electrode and workpiece, in between the gap, air is there. So whenever you are going to have power source here, the circuit is not complete. So because circuit is not complete, because there is a gap, and in this gap we are going to have air. In this gap, in this gap, in this gap, we are going to have air. And my dear, because of this air is not a good conductor of electricity. Air is a bad conductor. Air is the insulator. So my dear, when air is not a good conductor of electricity, it will not allow the electron to flow over the circuit. So that is why, my dear, here some resistance is coming. And whenever we have electrode and workpiece, the gap will be more, resistance will be more. And my dear, whenever we are going to take the electrode towards the workpiece, the gap between them will start decreasing. And when the gap will start decreasing, the resistance between the gap will also start decreasing. And there would be an instant when the resistance of this gap would be that much lesser that the potential difference you are providing here, that will be enough to threshold, and that will be enough to provide the flow of electrons in this region, which I am calling it as arc gap. So my dear, what will be happening in that case when I am saying that that potential drop will become enough for the pass of electrons in between this gap? Then what is going to happen, I would be showing you with the next diagram. Just try to understand. I am saying that, let us assume you are having this to be the electrode and this to be the workpiece. And my dear, in between there is a gap, and let us say this is that gap for which that voltage or potential difference is enough to ionize the air between the gap present. When air will get ionized, which was a resistance, my dear, it will be breaking into electron and ions. You would be having some negatively charged electron, 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 negatively charged electron. Yes or no? Yes or no? At the same time, you would be having some ions. At the same time, you would be having some ions. At the same time, you would be having some ions. And my dear, when these electrons and ions are produced within the air because of ionization of air, then my dear, these electrons will be attracted towards workpiece. Ions will be attracted towards electrode, because electrode is negatively charged, workpiece is positively charged. So when they are going to each other, in between the arc gap, whenever these electrons and ions are going to go there, they are going to collide with each other. Because of their collision, ultraviolet rays would be produced, and temperature between the gap will reach more than 6000 degrees Celsius. Whatever I am saying, everything would be written in the notes, so don't worry. You can very easily revise from that 34 pages notes I will provide you. Okay, don't worry about that. And my dear, whenever I am saying this is electrode, this is workpiece, when electrons and ion going towards each other, they will be colliding. Because of that, ultraviolet rays will be produced and temperature will be reaching 6000 degrees Celsius between that arc gap. Yes, Ajay. So my dear, because of that ultraviolet rays which are harmful to the eyes, that is produced in the arc welding, that is always suggested that while doing arc welding, you should always have the safety glasses. That's why in the college also you have seen, you were provided a safety glass. Maybe that safety glass was that much clogged that you were not able to see from that. But it was provided to you for your safety of eyes. And if you are going to do the welding with your naked eyes for some days, for some time, for some number of hours, for 2 to 3 nights, you will be unable to sleep. That kind of effect you will have in your eyes. So that's why it is suggested. And when I'm saying 6000 degrees Celsius temperature will be reached, and my dear, then yes, it is obvious that that collision is going to happen, but at the same time, some ions would be reaching to the electrode, some electrons would be reaching to the workpiece. And when they will be reaching with some kinetic energy based on their velocity, that is half mv square. It has been seen that kinetic energy of electron is always more than the kinetic energy of ions because of their high velocities. And that is why That is why when electrons reaches to workpiece, they give their kinetic energy to workpiece. Ions give their kinetic energy to electrode. So it have been seen that workpiece to electrode energy proportion is 2:1. So if 100 joule of energy is spent, it is been observed that 67 joule is there with the workpiece and 33 joule is there with the electrode. And whenever it is coming, whenever this energy is coming, from that energy, first of all, we are going to have this electrode wire. So whenever we are going to have this electrode wire, so you can see this diagram I have made. First of all, whenever we are going to have this electrode wire and we are going to have flux coating around it. Okay. So I would like to tell you, my dear, here flux is chosen in such a way that the melting point temperature of flux is going to be more than the electrode wire. So it is the electrode wire which is going to start melt first. So after some time you will see that this electrode will look like this, because wire is melted too much. And why we are doing that? We are going to provide electrode wire to melt first and flux will be melting last, because in that way you are going to have this concave type of shape, and because of that the arc will be getting a direction. If by chance electrode wire would be having high melting point temperature, like I have shown in my diagram, like this, then you would be having convex type of structure. And in that case, my dear, you will see the spark or arc or flame will be having divergence, and that will not be able to do the welding properly. So here you get the first function of the flux coating, that flux coating are helping us to give the direction to the flame or spark. It is going to help us in giving the direction to the flame or spark. Is it clear or not? So it is going to give the direction to the flame or spark. So we are providing the flux material in such a way that its melting point temperature will be more than the electrode wire. Thanks, Dheeraj. So whenever we are talking about this, yes. So guys, whenever we are talking about this, now the electrode wire is melting. Electrode wire is made up of the same material as that of workpiece. So that melted electrode wire, first of all, after some time flux will also be start melting. That mixture of electrode wire and flux will start going into the groove. And when it will be going into the groove, then only we are going to have the weld to be produced. So this is how the welding is going to happen. This was the principle of arc welding. Please tell me, everybody understood the principle of arc welding or not? Yes, Vineet, good morning. Yes, I was expecting that because in the night we had the practice session. So there is no problem. Let us, I feel now everybody can see and we can continue. First of all, tell me whatever we have discussed till now, the principle of arc welding. Everybody understood or not? The principle of arc welding, everybody understood or not? Please tell me that. The principle of arc welding, everybody understood or not? Okay, fine, Sachin. So we are going to have the same way till evening to complete each and every topic. So don't worry about that. Very good, guys. Very good. So this was about the principle. Now we will see the process in detail. So when this welding was happening, I would like to show you now some things. This is about the safety glasses I told you. Now I am going to show you something like this. You can see this is the molten weld pool, like it is shown like with the orange color. And welding is going to happen. So I am showing this with this color. So I am here talking about the function of flux coating, why we are going to provide the flux coating. So my dear, let us say this is the groove filled up with the molten metal. That molten metal is actually nothing but the mixture of electrode wire plus flux. So now I will tell you what are the various functions of the flux coating. Is it clear? No issue, Dheeraj. Everything we will be making strong. So don't worry about that. So you just need to be with me from 10 to 5. Rest I will take care. Okay? 10 to 5 we will cover all the 3 topics. So guys, whenever we are talking about this, first of all, I would like to tell you, like flux was having higher melting point temperature than the electrode wire metal. Now I would like to add one more thing, that flux is always made in such a way that some elements are going to be lighter than that of the electrode wire. So what will happen because of that lightness, my dear? Actually, some molten flux particle which were lighter, They will try to come up as they are lighter. So when they will be come up, they would be making a layer upward like this. When they will be coming up, they will be making a layer upward. And my dear, when they will be making a layer upward, they will be removing the interaction of molten metal with the atmosphere air. You may be saying, but sir, why that is required? Because my dear, everybody have some weakness. Like my weakness is tea. If someone offer me tea, I cannot deny. You would also be having some weaknesses during the college days. Some people have cigarette. So every person have their own weakness. My weakness is tea. Like yesterday, 5 times I have taken tea just because some faculty came, sir, le lo, I have taken. So likewise, metal have a weakness that whenever they are in the heated state, my dear, they cannot stop themselves when they see oxygen. Like when I see tea, I cannot stop myself to take that. Similarly, when metal see oxygen in the heated state, it cannot save himself to react with the oxygen. And my dear, that is why they are going to make the oxide layers. And whenever those oxide layers are formed, oxide layers are found to be brittle in nature. And those brittle layers, my dear, are not friendly for the welding process. So those brittle material are acting like glass, and we don't want that to be produced. So that is why, my dear, we want this, ki the flux coating is going to come at top and save the oxidation. So this is going to be the major function, protect from the atmosphere gases. That is the major function for the flux coating. What is the second major function? We have already discussed, to provide the alloy content. That's why weld bead is going to be the strongest part. That's why welded joints are only joints in this universe whenever we are studying about the joints which are giving efficiency more than 100%. Like if you are going to weld 2 plates, weld part is that much strong that plate can fail, weld will not. But yes, in some cases when we want that plate should not fail, if failure happen, it should happen in the weld. Then we are using the electrode of that material, of that type, so that the joint should fail first. But yes, welding has that capability that it can make a joint stronger than the parent metal. So that is why if you see reverted joint efficiency 65 to 70%, but welding joints is only where you can say efficiency is 100%, we can even go more than 100%. Okay, so my dear, whenever we are talking about the third, we have already seen the direction of the flame. So all these 3 are the major functions for the flux coating. That is why flux coating is provided. Yes, Dheeraj, there are many other things also. We will see one by one. So right now we have discussed about the flux coating. Everything is discussed. Okay. Now, my dear, whenever we are talking about this flux coating, there is an interesting fact comes. Like I told you that we are having this molten weld pool. And I told you that whenever we are having the molten flux present here, molten flux plus electrode wire is present here. And I was saying that I wanted that all the flux coating was reaching to the top so that it can avoid the oxidation. But my dear, if by chance, how it is happening actually? As they are lighter, so they are going up. But my dear, they will take some time to go up. And let us say, if the temperature of this molten weld pool is going to be slightly lesser, then my dear, it may get solidification at that time when some of the particles of flux would be inside, and let us say the solidification will happen like this. So solidification happen before every flux particle will go up. So my dear, in that case, what will happen? This slag, why we call slag? Actually, after solidification, we call this layer as slag coating. So my dear, some of the slag would remain inside the molten pool. So whatever those slag particles which are remaining inside because of solidification, they did not get time to reach to the top. So my dear, that will be causing a defect in the welding, because we don't want those lighter particle inside the weld bead. We want that only at the top, because after welding will be over, we would be chip off this. We would be removing that layer. So if that particle is remaining inside, this will be acting like an impurity, and that defect is said to be slag inclusion. So if someone will be asking you what is the slag inclusion, it is the defect when the impurities are remaining inside because of the solidification happening before the flux particles or the slag coating is going to perform at the top. If any of the flux particle is not going to the top and before that solidification happen, then my dear, this kind of defect will be coming into the picture. And when we are saying why it is happening, because of the low temperature. And why the temperature will be low? If the heat transfer is not going to be the proper, because you are going to provide I square RT. This is the heat generation which is provided for the welding purpose. So if, my dear, your current settings are not proper, if your current settings are not proper, then, my dear, obviously the heat generation will not be proper. And if heat generation will not be proper, slag inclusion will happen. So we always want that heat generation should be proper. We always want current settings to be proper. And my dear, I would like to tell you that whenever we are going for the graphs, let us say first graph between voltage and length, I already told you, whenever you have electrode and workpiece, whenever you are taking electrode towards the workpiece, then, my dear, whenever the gap between them is getting reduced, the resistance is getting reduced, and then the potential difference you are providing is become capable of ionizing the air. So if that is the story, my dear, if the gap will be more voltage would be required. That is why whenever you make a graph between voltage and arc length, it is coming like this. And we write the equation as V is equals to A plus BL. And my dear, that is why whenever you are going to have the movement of electrode towards the workpiece or away from the workpiece, that is going to affect the voltage. And everybody know power is V into I. If voltage will be affected, current will be affected. So whenever we are going to perform the welding, there are two types of movement happening. Like I am having this as the one workpiece, this as the other workpiece which is going to be welded. And let us say I am showing it in 3 dimension like this. And I am going to have an electrode with a different color. Just try to see the explanation I am going to give. This is the electrode, let us say. So whenever you are using this electrode, you know that electrode is moving towards the workpiece also, along the workpiece also. I am showing you, like, let us say this is my workpiece. Electrode is moving towards the workpiece also, along the workpiece also. So you know that when we are going to have towards the workpiece, other we have along the workpiece. Along the workpiece to cover the entire length, because we are joining these two plates along the length, na? So to cover the entire length, I need to have this movement of electrode. At the same time, I need to have this movement of electrode. Why this movement is required? Because electrode is getting melted. So when electrode is getting melted, I have to give the feed to the electrode in the downward direction. And you know, if downward direction feed is becoming important, because if the gap will be changing, the voltage will be changing. If voltage will be changing, the current will be changing, because power is coming at the same rate. So whenever you are getting the power, voltage will be changing, current will be changing. And you have just seen, if current will change, heat will change, slag inclusion will happen. So what we understood till now from that, there are two types of movement of electrode with the workpiece. One is towards the workpiece, other is along the workpiece. Along the workpiece is just to cover the length. Towards the workpiece is because electrode is getting consumed with the time. If I ask you, out of both the movement, which movement is more important? Towards the workpiece, along the workpiece. Always I would like to tell you that towards the workpiece is going to be important, because if towards the workpiece you are not going to maintain at a constant rate, the welding will be defective. And we don't want the defective welding. So my dear, that is why the first movement is important, to have the defect-free casting. This is the second movement. Second is required just to cover the length. Covering length is secondary if you are doing the welding with the complete length coverage, but the welding is poor. You need to once again re-weld. So towards the workpiece is the important movement. So my dear, if towards the workpiece is the important movement, I am telling you, when both these movements are done with the help of machine, we call it as automatic welding. When the important one is done by machine, second is done manually, we call it as semi-automatic welding. And if both the movements are done manually, we call it as manual metal arc welding process. So the problem is, whenever we are going to do this with the machine, we are happy because this is the critical movement. So we are going to do this with the machine in automatic welding also, in semi-automatic welding also. All these things are written in details in the notes. So don't worry about the revisions. So automatic and semi-automatic have this movement to be done by the machine. So there is no problem in these two type of welding. But whenever we have both the movements manually, then the process is said to be manual metal arc welding process. And in that process, there are high chances of slag inclusion. Let us say I don't have much money to have the semi-automatic or automatic welding. So I'm going for manual metal arc welding only. And then someone asked me, sir, can you give some idea that we can avoid the slag inclusion? Abhishek, it is available on my Telegram channel. You can open with you. There is no problem. You can see welding notes are available. Okay, if you want, once again, I am sharing. Those who are not on my Telegram channel, join the Telegram channel Mechanical by Dheeraj Sardana. And I am sharing the notes. Okay. And you can download the notes along with the class if you want to have. Okay. So I am sharing. Don't worry. If you want, I am sharing that. Don't worry. I am sharing. Okay, guys. Everybody got it? Just watch it. Mechanical by Dheeraj Sardana is the Telegram channel. I'm sharing two files. One is both are from my classes only. Okay, you can use any of them. Dheeraj, don't worry. I'm telling you for that. Don't worry about that. Okay. So I'm sharing the notes on the Telegram channel Mechanical by Dheeraj Sardana. You can see from there. Okay, guys. Everybody got it? Please tell me. Everybody got it? Please tell me. There are two files available. You can see any of them. Whatever handwriting you feel it better. Okay, you can use it. Fine, guys. If you would be having that with you, that will also help you for revision purpose after this session also. Okay, fine. Let us move. So I was saying that whenever you are having both the movements manually, then there are chances of defect. Whenever we are having both the movements manually, we are having the chances of defects. And for that, if I don't have money of having this semi-automatic or automatic type of welding, I'm saying I will be going with manual welding only, and I don't want slag inclusion. So for that, my dear, a special type of transformer was given. What was that special type of transformer? That is said to be drooper. Drooper is a special type of transformer which is also said to be constant current transformer. Constant current transformer. Constant current transformer. So my dear, if you are going to see, this is the VI characteristic for that transformer, and I am showing you something. You have just seen that between voltage and arc length, this curve is coming as V is equals to A plus BL. You have just seen that. So I would like to tell you one thing. When you have this voltage arc length equation, V is equals to A plus BL, you know that as the arc length will be more, voltage required would be more. So with the change of this movement, as if the movement is not proper, the gap will be varying. The gap will be varying, voltage requirement would be varying. And you can see this. Let us say you are having at some instant, this is the voltage V1 and this is the current I1. And you can see at some other location, you are going to have voltage V2 and you are going to have current I2. So can you see here, voltage changes this much, but current changes this much. Can you see the change of voltage is very high and change of current is very less. So as for very large change of voltage, change of current is small. We are calling this as constant current transformer. Some of you may be having doubt, sir, we have studied Ohm's law where voltage is directly proportional to current. Here it is not showing. So guys, transformers are not meant to follow the Ohm's law. Actually, transformers are built up to give some other types of curves only. Transformers are made only to get some different characteristic, not the same characteristic which we are going to have. And whenever we are talking about the Ohm's law, every element is not following. Those elements which follows Ohm's law are said to be active, which do not follow Ohm's law, they are said to be passive. But we need not to study those things are for electrical peoples. But yes, this would be the Druper characteristic curve. But don't worry, they will never be asking you numerical from that. I am telling you from where the numerical will be coming now. This was the conceptual explanation about the manual metal arc welding process. Now I am sharing you from where the numerical will be coming from the arc welding. And they would be asking you about the semi-automatic or automatic welding. And when we are talking about semi-automatic or automatic welding, for that voltage and current characteristic are coming linear. And when we are talking about those linear characteristics, they are going to be like this. And this linear characteristic, this is said to be the open circuit voltage, and this is said to be the short circuit current. And if you are going to say the equation x by a, y by b is equals to 1, this is a straight line equation. If you are going to write in the same way, you can write I by is plus V by V naught is equals to 1. From here you can write V by V naught, 1 minus I by is. From here a wonderful equation is coming. Voltage is V naught into 1 minus I by is. And if you are going to write this equation in other format, you can write it as V barabar V naught minus I upon is into V naught. And my dear, this is said to be the VI characteristic which are linear for semi-automatic we are generally using, or automatically we are generally using. So this is said to be VI characteristic, and you can see here V naught is the open circuit voltage, is is the short circuit current. Now, my dear, if you remember when you were going for the welding for the first time in your college, whenever you were taking your electrode towards the workpiece, sometime you have seen welding was not happening. Because when the gap is more, at that time welding will not happen because your potential drop, your potential difference is not capable of creating the ionization in the air. And at that condition, whatever the voltage we are providing is said to be open circuit voltage, or EMF, you are saying electromotive force. And there was some condition when this electrode was sticking to the workpiece. That condition also welding was not happening. That was the circuit was becoming complete and there was no chances of welding, and that thing is said to be short circuit. So guys, whenever you are going to have open circuit voltage, this is that value, maximum value of voltage for which there is no current in the circuit. And this is the maximum value of current for which the potential difference is 0. So open circuit voltage is the highest voltage, is is the highest current. I feel everybody understood this, yes or no? Badri, it is not like that. Actually, Druper is just going to help you for the fluctuation, not for the less or more gap. Fluctuations will be avoided. Okay, whatever fluctuations previously were there, now it will be lesser. So that will help us. Yes, Dheeraj, you got it. Kunal, you got it. Sachin, you got it. Vishal, you got it. And this is wonderful thing. Now, my dear, this is the voltage, open circuit voltage minus I by is into V naught. And whenever we are talking about here, they are asking some questions related to power optimization. For that, what you need to do, you know that power is given as V into I. And you know that we have just derived V is nothing but V naught minus I by is into V naught. This is into I. You can see here, as I have kept the value of voltage in terms of current, now it becomes power versus current. If they ask you the optimum power, you just go for dP by di to be equals to 0. And when you will be going for dP by di to be equals to 0, you will be getting the I value, which is I optimum, as equals to short circuit current divided by 2. So always remember the optimum current will be coming out to be short circuit current by 2. And similarly, when you would be going for putting this IS by 2 in the equation, like you have V is equals to V naught minus I upon IS into V naught. When you will be putting this value of I optimum here, then you would be getting the V optimum. And V optimum will be coming out to be V naught minus I optimum is IS by 2. IS will get cancelled out. It is V naught by 2. Answer will be V naught by 2. So guys, this is going to be the optimum voltage. That is going to be the optimum current. If they ask you optimum arc length, you will be putting V as A plus BL. When you will be putting V as V naught, you will be getting the optimum arc length. And this is the area from where questions are coming, and we are going to solve some questions. Then we will go to the next process, because this is the formula from which 75% of the questions of welding are coming. So we have just completed one process, but 75% of the numerical we can do right now. Okay, is it clear? Shovik, actually you need not to remember that length, but yes, optimum whenever they will be asking, you need to go with that. बिल्कुल 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 अजीत करवा रहे हैं, वही तो करने हैं, वही तो करने हैं. We will be going for the next process. Before that, let us see some questions. We will see other processes. Let us see some question to get an idea what kind of questions are coming. Let me show some question on this. This is the question for that. This is the very first question on that. This is from PYQ of GATE. A DC welding power source has the linear voltage current characteristic. Open circuit voltage 80 volt, short circuit current 300 ampere. For maximum arc power, the current should be. Maximum, whenever they say take it optimum. For optimum arc power, what should be? What should be? What should be this value? They're asking you the optimum current. Now you can answer it very quickly, although in the books they are not using that formula. They are always going for that derivation which I have done. You will not be going for the derivation. You will directly say, yes, as we know, for optimum voltage is open circuit voltage by 2. Optimum current is short circuit current by 2. So answer for this is going to be 150 amperes. Clear for everybody? Clear for everybody? Clear for everybody? Clear for everybody? Yes, yes. Next question. Okay, this is on the efficiency, I feel. So don't worry, we are going to have these questions also. First, let us move to the second process, and don't worry, we have a large number of questions after that. Okay, one question we will do with the process, then we have 5-10 questions together also. Now we are having the submerged arc welding process. So my dear, कुछ तो कमियां रही होंगी, ऐसे ही कोई यूं ही कोई बेवफा नहीं होता है ना. सुना होगा ये डायलॉग आपने. So if we are going for the second process, there must be some problems with the first process. There were some problem. There were some problem with the shielded metal arc welding process, because of which we move towards the second process, which is nothing but the submerged arc welding process. And in short, it is said to be SAW. And my dear, there were some problem with the shielded metal arc welding process. What were those problems? The very first problem I will identify that the size of electrode. Let us say you have a 9 inches or 12 inches electrode. So when that electrode will be over, you would be requiring the second electrode. Let us say you are going to weld a LPG cylinder. Everybody have seen LPG cylinder in their house. You know LPG cylinder is having a decent length and you want to weld that. And you know those cylinders are having very thick plate. So when you are going to weld them, obviously a large number of electrodes would be required. So let us say you are going to perform that operation with the electrode. First electrode is going to be melted here. Then you will stop the process. You will go for the second electrode. Second electrode will be over. Then you will stop the process. You will go for the third electrode. So likewise, electrode by electrode, when you will be going for this process will be a discontinuous process. Okay, no problem with the discontinuity. The problem is whenever you will be stopping the process and once again start, the chances are there you would be having the joint obviously there, and at the joint there are chances of leakages. And if LPG gas is going to leak, my dear, it is going to result into a very big accident which we don't want to happen. Similarly, whenever you are going to see ships, in the ship like big plates are welded like this. And if you're going to weld them like with this process, shielded metal arc welding process, there also some joints will be there. Wherever joints will be there, there are chances of leakage, water will get inside. And there also you would be getting the blaster. Whatever persons are there in the ship, their life will be in danger. So where we don't want those kind of leakages, where we don't want the discontinuity in the processes, we cannot use shielded metal arc welding process. So as an improvement, we wanted to have a continuous process. And yes, Dhanesh, good morning. And for that, we wanted a continuous electrode. So to have that, what was suggested? Previously, you were taking an electrode. Now it was replaced by an electrode wire. And when you are taking this wire, you can say the wire is very long. It is going to be on the wire spool. Like whenever you fly the kite, you have a spool of thread. This is a spool of wire. You have electrode wire wound around. Is it clear? Dheeraj, you can go with the derivation also, but that whatever derivation I have done, that is standard one. So whatever questions you will do, you will always find the same. Okay? Always, you can see that. Students are going, I also at my time was going with the derivations only. But whenever you go with the derivations, you will get the same answer. You can try that. Okay? So my dear, then what we have done, when we have taken the electrode in the continuous wire format, there was a good thing. Now the wire is coming continuously and we can make any big joint without any discontinuity. And as continuity is there, this time we can go for the mass production, which is one more advantage of submerged arc welding. Those students who have appeared for BARC this time, the technical officer exam was there. Those students who appeared for HPCL exams, BEL exam, they have found some of the questions like that, where they were giving a data that this much welding part are produced, which was showing big in number, which process is useful. So whenever you see the mass production is there, for the mass production, we go for submerged arc welding process. Why? Because of the continuity of the process. And second thing, one problem we understood. Second problem was the manual metal arc welding process. That slag inclusion possibility was there. If we are using drooper, yes, we can avoid it. But better we go for the semi-automatic type of welding. If we are going to give this movement with the help of machine, then a constant gap will be produced between the electrode and wire. So for that, we have provided a servo mechanism. This servo mechanism was having two wheels like that. And from this, the wire was going at a constant rate. So as the wire was going at a constant rate, the gap produced was constant between them. And that is why here there is no problem of slag inclusion. So in submerged arc welding, the very first thing is continuity. So leakages chances are avoided. Second is continuity, mass production is there. Is it clear or not? Yes. Yes, Surjit, very good. So whenever we are talking about this, a constant gap is maintained between electrode and workpiece with the help of this servo mechanism. So my dear, this is a servo mechanism. Okay, so when we are going to have both these things, now what we can say about this process, and the process is having continuity, the velocity of welding is high. If velocity of welding is high, yes, it is a semi-automatic type of welding process. I already told you, na, this servo mechanism means only it is semi-automatic. Okay, semi-automatic means only the movement of electrode towards the workpiece will be provided with the help of machine, and other movements along the length will be manual. So I am telling you, my dear, whenever we are talking about this, first thing what we got, continuity, mass production. Second thing what we got, I am saying that constant gap, there is no slag inclusion. And because of continuity, welding speed is high. If welding speed is high, what will happen? Can you tell me about heat affected zone? If welding speed is more, what will happen to heat affected zone? If welding speed is more, what will happen to heat affected zone? If welding speed is more, what will happen to heat affected zone? Yes, heat affected zone will be lesser. So my dear, as the welding speed will be increasing, heat affected zone will be decreasing. Yes or no? Yes. So that is one more advantage here. Very good, Shreyas. Bahut badhiya. And guys, now I am moving to one more interesting point here. Very good, Fanendra. Bahut badhiya. Now I am going to one more interesting point here, guys. Ki whenever you are going for the wire, now we cannot provide the flux coating. If you remember, flux was performing three very important things. One, it was providing the alloy content. It was also helping us. It was also helping us to give the direction to the flame. It was also helping us to avoid the oxidation. Very good, Ronaldo. So when these much benefits were there, we cannot go without the flux. But why we cannot provide flux coating? Actually, whenever the wire spool is there, when wire will be coming and unwounded from the spool, if the flux coating will be there, with the friction, that flux coating will be removed from the wire. So that is why we are going to provide in the molten format. So this is the molten flux provided, and it is provided in the welding area. And when it is going, always the molten weld pool, always the molten flux pool is going to prevent the arc from the atmosphere. So that is how this flux is going to perform its function. But my dear, as you are providing the liquid flux, the rate of movement of flux is more. That's why, my dear, there are limitations that if you are having a plate of thickness more than 75 mm, that we do not weld with this process. Beyond 75 mm thickness, we are going with electroslag welding, which is the modification over this. So generally, what are the application of this process? That is LPG cylinder, shipbuilding. Okay, so generally whenever we are talking about these two applications are majorly for which it is known, and out of these two also, LPG is generally preferred by this, and shipbuilding is preferred by electrogas or electroslag welding. But if electroslag welding is not in the option, then you can go with the submerged arc welding also. Okay, so this was the application. I feel everybody understood. Shall we move on to the next process? Second process is clear to everyone. One by one we will be going like that. Diagrams I have, so time will not be required much, and that's why I kept 3 topics, because I cannot skip the things. Like you have seen in the deflection also, it was not possible for me to complete it in 30 minutes. I cannot skip the things. I am telling you each and everything. Submerged arc welding is over. Okay, these are the 3 important facts I told you. Moving to the next process, guys. Next is TIG MIG process. Okay. ठीक है यार, तुम कह रहे हो तो मैं ले लेता हूँ. Okay, so we are going to move the third process, that is TIG MIG process. Okay, guys. Whenever we are talking about TIG MIG process, everybody would be knowing about the full form. TIG is tungsten inert gas. Tungsten inert gas and metal inert gas. Tungsten inert gas and metal inert gas. So when we are talking about tungsten inert gas and metal inert gas welding, first of all, tell me, is it a arc welding process or gas welding process? First of all, tell me, is it a arc welding process or gas welding process? Arc welding process or gas welding process? Yes, generally students have doubt over that, because they see the gas, they call generally gas welding process. So I would like to tell you, this is arc welding. So tungsten inert gas or metal inert gas, arc welding it is. And whenever we are talking about this process, so it will follow the same principle. But TIG, whenever we call, here we are going to use a tungsten electrode. Tungsten electrode, which is going to be non-consumable. And whenever we are talking about MIG, we are going to use metal electrode, which is consumable. So tungsten electrode is non-consumable. Yes, Hari Sandhu, good morning, dear. So tungsten electrode is going to be non-consumable, and metal electrode is going to be consumable. Is it clear? So my dear, now the point is why this process came. When submerged arc welding was a perfect process, we got continuity, we got avoiding of slag inclusion. Then why we are entering into this third process? So my dear, the answer for that is, there were some problems, like there are some metals which are very highly reactive. Like whenever we are talking about aluminium, magnesium and their alloys. Aluminium, magnesium and their alloys, they are having a problem. Like I was having a problem by looking at T, I was not able to resist that T. I was taking that T. I was not counting the numbers in T, how many times I have taken. Okay, so my dear, likewise, metal was having a problem with having an attachment with the oxygen. Whenever metal is heat, it see oxygen, it react with oxygen, make metal oxides. But it was happening with the hot metal. But my dear, aluminium, magnesium and their alloys are so much reactive that they even don't need the heat for that. There are some people, they even don't need that someone offer them tea. They are just going and taking any number of times tea. Okay, so likewise, aluminium, magnesium and their alloys, whenever we are talking about, they are always going to react even at the room temperature. They don't want heat even for that. So at the room temperature, they are react with oxygen. That's why whenever you will see aluminium, it will always be having a layer of aluminium oxide onto that. And this aluminium oxide layer is going to be very, very hard and brittle because they are a kind of ceramics. So they are going to be hard and brittle. And this is very, very difficult to weld. This is very, very difficult to weld. So that is why submerged arc welding, shielded metal arc welding, those processes got failed in welding of this type of metal, this type of material. So for that, we wanted something new. For that, we wanted something new, and for that, TIG process first came into picture. And when we are talking about TIG process, what is that? I will show you a diagram for that. Here we are going to use a tungsten electrode, which is non-consumable. Why tungsten electrode is taken non-consumable? Because tungsten material is once again brittle in nature, and if tungsten is going to melt, the same problem will be there. Brittle weld will be produced. Brittle will be like glass. Like whenever you will be having that workpiece which is welded and tungsten is there inside, it is brittle. If it is going thrown from you, it will be breaking into parts. That kind of welded joint we never want. So my dear, that is why the tungsten should not be melted. That is why we call it as non-consumable electrode. Now you may be thinking, sir, when that is the problem, why we are taking the tungsten only? Some students have already written that reason. We are taking tungsten because of its high melting point temperature, which is more than 3400 degrees Celsius. Because what we are going to do different in this type of welding, till date we were going for workpiece to be positive and electrode to be negative, and this type of polarity is said to be direct current straight polarity. This time we are going to do reverse of that. We would be having the workpiece to be negative and electrode to be positive. We would be calling it as direct current reverse polarity. Now you may be thinking, sir, what is the problem with that? The problem is that where the positive is there, 67% of the energy is going there, and to the negative 33% energy is going there. So I would like to say here that in direct current reverse polarity, which we are going to use now, the electrodes are going to get 67% of total energy. So of the total energy, 67% of the energy is going to be to the electrode. So that is why we want an electrode which would be having very high melting point temperature, so that it should, and we don't want tungsten to melt. Okay, so both the things are required. Shan Vicky, my Telegram channel is Mechanical by Dheeraj Sardana. You search on the Telegram Mechanical by Dheeraj Sardana, my photo will come on that. Okay, just click that. I have shared the notes just for the welding. You can have those notes also with you. Okay, so my dear, that is why we use non-consumable electrode. Now I would like to tell you that as we are using this electrode which is non-consumable, but you know, when welding, electrode was melting in the previous two processes. So for that purpose, we are going to use the separate filler rod. We are going to use the separate filler rod. We are going to use the separate filler rod. It is going to be of the same metal as that of workpiece. It is going to be of the same metal as that of workpiece. Is it clear for everyone? Now, my dear, I would like to tell you one more thing here. There is one problem. Like you know that this time you are going to provide, this is DC, this time this is going to be negative, this is going to be positive. But when we are going to provide tungsten to be positive, workpiece to be negative, what is the logic behind that? Arey bhai, you know, if workpiece is negative, you already know there was a oxide layer present over the surface, and which was non-weldable. This oxide layer was not weldable, and if you want to make it weldable, you need to remove this oxide layer. So my dear, when you are making workpiece to be negative, electrons from this surface will be going out, and when they will be going out, they will be breaking this layer. They will peel off this layer. So like when they will peel off this layer, fresh aluminium will be coming, and that is going to get welded. And whenever we are going to do that, we are going to clean this surface by making it cathode. Cathode means negative. So this process is said to be cathodic cleaning. This process is said to be cathodic cleaning, because you are cleaning the workpiece by making it cathode. You are cleaning this workpiece by making it cathode. Is it clear? Everybody, Shan, Vicky, Ajay, Dheeraj, Badri, Overload, Ashray. So guys, do like and share the session. If you want that till 20th we cover all the subjects like that, just be there with us. I feel we are trying to give you maximum whatever is possible. Okay, so guys, this is going to be the cathodic cleaning. Now whenever, and I feel I am teaching in a way like if any student have already made their mind that they are going to leave the welding and they are looking it for the first time, they will also be learning. Yes or no? Yes. So guys, whenever we are talking about this cathodic cleaning is the process happening. But you should be knowing that tungsten is getting more energy because it is becoming positive. So we never want at any cost tungsten to melt. So for that purpose, what we do, we are going to increase the surface area of tungsten. So in place of this shape, we are going to provide this shape to the tungsten. Tungsten electrode is provide this shape. Means if normal diameter for tungsten is D, we are going to provide this diameter to be 1.2 to 1.5 times of D. So we are increasing the diameter of surface by 20 to 50% because more surface area would be requiring more heat to melt. So that is going to give us safety towards melting of tungsten. And that process is known as electrode preparation. That process is known as electrode preparation. That is said to be electrode preparation. So my dear, whenever we are seeing this process, now you must be having one doubt in your mind. Sir, where is flux? Where is flux? So my dear, in the function of flux, if you want, major function was to avoid the oxidation. Because oxidation will harm the surface and here the problem with the oxidation only. So that is why we are going to provide the inert gas. That inert gas environment will not allow any kind of oxidation to happen. And that inert gas can be helium, can be neon, can be argon. Generally, argon is used as an inert gas. So that is why the process is tungsten inert gas arc welding. So here inert gas is performing the function of flux. Inert gas is performing the function of flux. Yes, Dheeraj, I am coming on to that point. But my dear, nowadays this process is not used in industries. This process was having an advantage over that it can weld very easily the aluminium plates. But it was capable of welding only 5, 8, 10 mm thick aluminium plates. The reason was less heat at the workpiece. So guys, then we have improved upon and we went for the next process, that is MIG arc welding process. So when we are talking about the MIG arc welding process, here tungsten electrode was replaced by the metal electrode. And as you are using metal, it is going to be consumable. And as it is consumable, to make the process continuous, I am using the wire spool like in the submerged arc welding. To avoid the problems happening like slag inclusion, we are going to provide the servo mechanism. And guys, inert gas was as it is in place of what? In place of flux. And guys, when you are performing this process, we are going to have the name as metal inert gas arc welding. But I would like to tell you, whenever we are talking about TIG process, MIG process, tungsten inert gas or metal inert gas arc welding, I would like to tell you one thing, that whenever we are talking about TIG, MIG process, here in the industry, we have done one more improvement over MIG process. What is that improvement? We have replaced the inert gas and we are using the CO2 in place of inert gas. CO2 is not an inert gas. CO2 is not an inert gas. So my dear, it is an active gas. So when you are going to use CO2 with MIG, means inert gas is replaced by CO2. We call this process as active gas metal arc welding process. And in industry nowadays, you will find this process only, active gas metal arc welding process. What is the benefit? You know that CO2 is going to be the cheap gas. It is not costly as the inert gases. Is it clear? So we are going to use this. Now one more thing I would like to tell you guys, whenever we are talking about TIG, MIG processes, that's fine. We have talked about aluminium, magnesium, which are difficult to weld, we are going for TIG, MIG welding processes. And my dear, here a term comes that is weldability. Here a term comes that is weldability. Guys, within 10 minutes, we are going to have 4 or 5 wonderful questions. Okay, some theory part is remaining, then we are going to have some wonderful questions. So guys, whenever we are talking about the weldability, it is the ease towards welding. What do you mean by ease towards welding? That whether it is easy to weld the workpiece or not. If it is easy to weld the workpiece, we will say weldability is excellent. And it is found that weldability is inversely proportional to the carbon content. So if carbon percentage will increase, then weldability will decrease. If carbon percentage will increase, weldability will decrease. So that is why low carbon steel will be having excellent, then medium carbon steel, then high carbon steel. This is the trend for weldability, guys. This is the trend for weldability, guys. So guys, this was about TIG, MIG arc welding. I would like to add one thing here in the submerged arc welding also. Like in the previous process, shielded metal arc welding, you talked about slag inclusion. Here I would talk about one more defect that is said to be spatter. So guys, scattering of molten metal. Spatter is nothing but scattering of molten metal. Scattering of molten metal. Scattering of molten metal. What is that? Like we have this electrode wire. If by chance this electrode wire is getting diverged by something, then my dear, in place of welding area, molten metal may get split over some other areas. And that defect is said to be scattering of molten metal, which is said to be spatter. And when you have studied the submerged arc welding, there was an advantage that this flux was covering the entire electrode wire. So there you can see the arc was safe under the molten flux. So here tendency of spatter was minimum. Tendency of spatter was minimum in submerged arc welding. So quality of weld was sound. With this, we have completed all the 3-4 processes. Okay, now we are moving further. Yes, very good, guys. So we are moving further now to a wonderful thing, that is the types of heat generated and types of efficiencies, after which we will have 3 to 4 questions and then we will go to the other processes. I am telling you the major time would be spent on arc welding and resistance welding. After that, much time is not required because numericals are coming only from these 2 processes. So we would be completing welding by 1:30, I feel. Then casting will require 3 hours, then 1 to 1.5 hours would be required for sheet metal operation. So by 5-6 p.m. we would be completing today's session. It is not going to be up to 10. Don't worry about that. Okay. So let us move further. Actually, when we are talking about SOM and FM, they are bigger subjects. So they require more time. Is it clear for everyone? भाई समझ पा रहे कि नहीं? सभी को आ रहा है समझ? Everybody is clear. Everybody is clear. Everybody is clear whatever we have discussed till now. So guys, do like and share the session. Do like and share the session. Then we are moving further. Okay. So do like and share the session. Then we are moving further, guys. So let us move further, guys. Wonderful. So guys, now we are talking about the types of heats and types of efficiencies. So I would like to tell you there will be 3 types of heats in the welding process. Out of the 3 types of heats, the very first type of heat is said to be heat generated, about which you have studied Hg as equals to I square RT. So guys, when you do the practice, when you do the revision by yourself, generally always fear is coming into the mind. When you are going to revise with us, you would be feeling very good, energetic, and that is the advantage of marathon. Doing self-revision is going to be boring and fear wala काम. Okay, we always feel कुछ छूट तो नहीं जाएगा. When teacher is teaching, he is taking care of everything. So when we are talking about this heat generation, it is I square RT. We have already seen that. This is the heat generated for the welding process. Now, my dear, we have heat required. Let us say you are having a workpiece. We are having a workpiece which is having some mass of M, specific heat of Cp, and some temperature of T. Okay, let us say atmosphere temperature, it is T infinity outside. So you know this workpiece is having a melting point temperature of Tm. So my dear, whenever you will be heating this for the welding purpose, first of all, you need to provide some specific heat to increase its temperature from room temperature to melting point temperature. Then after that, you will be melting it. So you will be providing some latent heat. And we are generally going for some extra temperature for safety. Okay. So that is going to be the final temperature up to which we are going to heat. So we are going for heat requirement. Heat requirement can have three components. One is MCP, Tm minus Tr. This is the sensible heat. Then we would be having M into latent heat in kilojoule per kg. That is at melting point temperature. Then once again, we are having the sensible heat MCP, that is T final minus T melting. So when you will see these three components which are coming under the heat requirement, every time these three will not be required in the question. In reality, they are required. Practically, they are required. But in question, generally, I have observed, and you can also observe, that examiner generally is talking only up to these two things. He will never be talking about this third component. And even in these two components, sometimes he is neglecting this component. So depending on the data, you can find out the heat requirement. So if he is not giving CP, you forget this, you will take only this. Theoretically, they can do anything, but practically it is required for sure. विनीत शाह, इस तरह की बातें आप मशीन डिजाइन में पूछोगे तो अच्छा रहेगा. या हम कंपैरिजन थोड़ी कर रहे हैं डिफरेंट प्रोसेसेस का. ठीक है, पहले आप गेट पॉइंट ऑफ व्यू से सोचो पहले. ठीक है, पहली बात. और दूसरी बात, आपको ये पूछना भी है तो ये मशीन डिजाइन में पूछना बनता है. वेल्डिंग चल रही है ना अभी, सारे ज्वाइंट्स थोड़ी पढ़ा रहा हूं आज मैं. ठीक है, तो देर आर मेनी थिंग्स. वी आर व्हेनेवर वी आर टॉकिंग अबाउट, एवरी टाइम वन थिंग इज नॉट थॉट. देर आर मेनी थिंग्स. राइट नाउ we cannot talk about revert, bolt, everything we cannot discuss at the same time. Okay, so at that time we will discuss about this point. I have noted down, don't worry. So whenever we are talking about the heat requirement, this is how you can find out. The third component is, और अभी आप पहले ESC मेंस की तैयारी कर रहे हो कि गेट की कर रहे हो? आप ESC प्रीलिम्स निकालो, ESC मेंस बैच हमारा फ्री चलता है, वहां पर आना, आपको ये सारी चीजें पढ़ाई जाएंगी. These all things are the part of ESC mains. Yes. So after ESC prelims, we have free batches for ESC mains. Just qualify ESC prelims for that. Okay. So for right now, let us talk about gate, and especially for the welding. So when we are talking about heat supply, actually, whenever this heat is getting generated and we are going to have this much requirement of heat is for the welding purpose. So whatever the heat is generated, when you will be supplying this, actually during that heat transfer, as you know, atmosphere is kind of sink. So whenever welding is going to happen, at the same time heat will be lost to the surroundings. So that is why whatever the heat we are going to generate, that is going to be always more than the heat required. And even whenever we have this much heat generation, you would be providing some heat, and out of that also requirement would be less. Let us say 2000 joules we are going to produce. And for welding purpose, let us say we require only 700 joule. So maybe 2000 joule is produced, out of which 1400 joule is supplied to the welding area, and 700 was required. Rest 700 will be going to the surrounding. So if you see overall, this was the produced, this was the requirement. If someone will ask you what is heat lost to the surrounding, so you would be saying heat generated minus heat required. That is going to be the heat loss to the surrounding. Is it clear for everyone? Is it clear for the everyone? Yes, very good Ajit. यार इन सब डिस्कशंस में मैं नहीं पढ़ो, ये मैं भी बता सकता था, but I am saying कि this is not required right now. This session is not like an interview session. Okay, this is a revision session, revision marathon. Okay, so take it like that. Okay. So this is up to the three types of heat. Now we are moving further to three types of efficiencies. So when we are talking about three types of efficiency, the first type of efficiency is said to be heat transfer efficiency. So when we are talking about heat transfer efficiency, it is defined as the ratio of heat supply to the heat generated, or we can say the rate of heat supply to the rate of heat generated. Then whenever we are talking about thermal efficiency, we also call it as melting efficiency. And it is defined as, guys, the heat required but a heat supply, or the rate of heat required, rate of heat supply. Overall efficiency, my dear, you know, overall two heats are important. One is heat required, one is heat generated. So you can also write heat required by heat supply by heat generated, which is the product of melting efficiency and heat transfer efficiency. Is it clear for everyone? Is it clear for everyone? That is correct. The value wise, it should be 1300. No, it is not 1300, bhai. 1400 is correct. It is not like 1400 plus 700. No, this is produced. Whatever is produced during the production, 600 joule is lost. So the very first loss to the surrounding is 600 joules. So 2000 become 1400. Then 1400 to 700, there is another loss of 700 joule. It is going to be like that. Okay, Vineet. आगे ध्यान रखना. Is it clear? Yes, units you have to check all the times. Units you have to check all the times. So guys, now we are going for 2-3 questions. After that, we will come back to the table. We have completed 4 processes of arc welding. Rest within next 10 minutes, arc welding will be over. Next 30 minutes, resistance welding will be over. By 1 to 1:30, welding will be over. Now we have a gas tungsten arc welding operation is performed using a current of 250 ampere, voltage of 20 volt at a welding speed of 5 mm per second, assuming that the efficiency is 70%, the net heat input per unit length. So guys, whenever you see this type of question, how you will be solving? Just look at it. Vishal, heat supplied is nothing. There is no formula for that. In this question, you will get an idea. I said they are asking you about the heat generation rate. That is nothing but the power. Because heat generation is I square RT. Generation is in joules. Okay? But when we have joules per second, it is going to be power. So dear, for Badri, I am repeating once again. Actually, there are 3 types of heat. One is the heat generated, which I have told you. Heat supply and heat required. These two have the formulas. Why heat supply and heat generated are different? Because during heat generation, also some heat losses will happen. Like heat is generated at the tip of electrode and workpiece. At that time also loss is happening. So whatever is supplied for welding process is not going to be equal to generated. It is going to be lesser than that. That's why I said some loss is happening during this process. And then some loss will be happening during the welding. So total heat loss is heat generation minus heat required. I feel now Badri would be okay with this. Now I am going back to the question, and that is the question. Actually, they are saying that a gas tungsten arc welding operation is performed using 250 ampere and 20 volt. Power is going to be V into I. And you know that this will be in joule per second. That's why I am calling it as the rate of heat generation. Yes, so you can see first of all 250 into 20 volt, you will find out whatever. Now they are saying assuming that the arc efficiency is 70%. Arc efficiency means it is heat supply efficiency. So they have given the efficiency of heat transfer as 0.7. And they are saying that find out the net heat input. Heat input is heat supplied. So if they would be asking you heat supply, you can write the rate of heat supply but a rate of heat generated as equals to heat transfer efficiency. But the problem is they are not asking you this. They are asking in the units of kilojoule per mm. And whenever they are asking in the units of kilojoule per mm, here whatever the heat supply you would be getting efficiency times heat generation ka rate. So you can write it as efficiency time power actually. So whatever you are going to get here, that you would be getting in joules per second, or let us say kilojoule per second. But they are asking you to have kilojoule per mm. So if you want the heat supply in kilojoule per mm, if I divide this by velocity, so what will be the formula? Heat transfer efficiency into voltage into current divided by welding speed. This is the formula if you want in kilojoule per mm. There is no such formula standardly. I am deriving it just for the sake of, because many questions have been directly come from this type of area. So if you would be remembering this, you can very easily answer. Otherwise, from the units you have to do. From the units it is kilojoule per second. If I divide with mm per second, I will get kilojoule per mm. Always these kind of thing will be calculated with the units, because there is no such standard formula derived. Yes, what would be the answer? Every student is giving different answer. 0.175, 0.7, 0.14. थोड़ा सा सही से calculate करिए. When we are talking about this heat transfer efficiency, it is 0.7. Okay, I am putting the formula here. Okay, so I would be saying 0.7. V into I is 250 into 20. This is giving the answer in joule per second. Then I am going to divide it with the welding speed 5 mm per second. This will give the answer in joule per mm. So you can see 250 into 20 is going to be 5,000. 5,000 into 0.7 is 35. I feel somewhere. Yes, what is the answer, guys? It would be 3,500 joule by 5 mm. I feel 700 joule per mm, so it would be 0.7 kilojoule per mm. 0.7 is the right answer. Very good Vinay, very good Abhishek, very good Sumit, very good Dheeraj, very good Abhi, Overload, Sachin, Ajay, Panindra. Very good, guys. So guys, do like and share the session. We are reaching to the next question. Next question. So here they are saying a welding operation is being performed with voltage 30 volt, current 100 ampere. So once again, power will be V into I. The cross-sectional area of the weld is 20 mm square. The workpiece and filler are of titanium, for which specific energy of melting. Okay, melting energy is given as 14 joule per mm cube. Then they are saying assume a thermal efficiency of 70%. The welding speed is 70% is the efficiency. What is going to be the welding speed? This is a different type of question. Let me tell you how to do. Here you can see power is rate of heat generation. And don't worry, these are the types of questions we are doing in the class. So rate of heat generation is power, you know that. V into I, you will get this. And there is some efficiency given, welding efficiency, they are saying it. And you know, we can say the heat supply rate but a heat generation rate. That is given as 0.7. From here you would be getting the rate of heat supply. 0.7 times of power. You would be getting this value in the joule per second. Okay, and guys, what they are saying, just look at it, what they are saying. They are saying that 14 joule per mm cube of energy is required. Means if we are going to multiply this with the volume, we would be getting the total energy required. Actually, this is not energy supply. Heat supply and heat required are same. Okay, if you are going to consider it like that. So you can also write it as the rate of heat required but a rate of heat generated, that is going to be 0.7, and you can get the heat required is 0.7 times of power. So this will be 0.7 into V into I. What is V into I? 100 into 30. So it is 3000. This is going to be 2100. 2100 joule per second. First of all, tell me everybody is clear up to this or not? Okay, many of you have already answered it. That's really great. Okay. So when we are getting this heat required, but here we have the heat required rate as 14 joule per mm cube. So if we want to solve it, okay, I'm solving it here. We are having 2100 joule per second. And on the other side, we have 14 joule per mm cube. So if I am going to multiply it with area and welding speed, area is going to be mm square. Welding speed is going to be mm per second. I would be getting the answer in joule per second. So my dear, area is known to you. You can very easily find out welding speed. All these things have to be done like that with the units. It is the game of units actually. So everybody have done it. Please tell me any doubt I can take. So you just need to equate this 2100 with 14 into area is 20 into welding speed. So welding speed will be coming out to be 7.5 mm per second. If anybody have any doubt, they can ask. This is the highest level of questions which can come in GATE. Okay, simple questions will be related to voltage and current. Difficult question would be like that. Anybody have any doubt till this point? Please do ask me, guys. Yes, Vineet. Yes, Vinay. Yes, Shreyas. Yes, Sumit. Abhi, Ajay, Dheeraj, Overload, Ravan, Ronaldo. Everybody. Okay, moving further. Moving further. Now let us see this question. This is the last question for this topic. Then we will move to the next. Very good, Farindra. Very good, Ashray. Ashray, actually they have given welding efficiency. So welding efficiency can be heat transfer efficiency also. It can be overall efficiency also. It can be heat transfer efficiency also. So if one efficiency is given, other is not given, we consider the other to be 100%. Yes or no? If you consider that heat transfer, then what will be the melting efficiency? 100%. Or if you consider it overall efficiency, then there is no role of heat supplied. So choice is yours. Is it clear? Yes. After this, we will go to the resistance welding. First, let us complete in arc welding of a butt joint. They have said arc welding of the butt joint. Okay. The welding speed is to be selected such that highest cooling rate is achieved. The melting efficiency and heat transfer efficiency are 0.5, 0.7. Area of weld is 5 mm square. Unit energy required is 10 joule per mm cube. If welding power is 2 kilowatt, find out the welding speed. This is a very good question. Yes, yes, yes. Many of you started answering. Very good, Vineet. So how to do this? This is the same way we will be going. Like we have this to be the welding plates. So this will be the area of weld bead, and you know they will be going till the entire length like this. So this will be the speed of welding, and this is the area of weld. So when you are talking about the efficiency that are given, so what would be the heat required ka rate? It would be heat transfer efficiency into melting efficiency into power, because you know the product of these two is the overall efficiency. So this will give you the heat required but a heat generated. Power is nothing but the heat generation ka rate. Power is nothing but the rate of heat generation. So you know that power is nothing but the rate of heat generation. That is 2 kilowatts. 2000 joule per second. So my dear, when I will be multiplying it with 0.5 and 0.7, I would be getting the heat required ka rate. Heat required ka rate, I will be getting 0.7 into 0.5. When you will be doing this, you will be getting 700. And that is equals to the unit energy required, which is in 10 joule per mm cube into area of weld into velocity of welding. And they are asking you the velocity of welding. So what is specific energy? 10. What is area? 5. You need to find out welding speed. 14 mm per second would be the answer. I feel everybody have got that. Guys, if anybody have any doubt in that, don't hesitate to ask me, okay? Because these are just the simple calculations which you have used till 12th class also. Everybody know power is rate of heat. Okay? Dheeraj, the reason behind that is overall efficiency is heat required by heat generated. We can write it as heat required by heat supplied into heat supply by heat generated. This is melting, this is heat transfer. So overall efficiency is the product of melting and heat transfer efficiency. Sumit, power is the rate of heat generation. So Hg dot is the power. Okay, Sumit. Anybody have any doubt, guys? Don't hesitate. I will answer you. आज डांटूंगा भी नहीं. Yes. If efficiency is not given, consider it as 100% beneath. Moving further. Plasma arc welding. Now, my dear, we are going for the last two processes of arc welding. Then resistance welding will come. Resistance welding will not take time. Don't worry. Only this process is taking time. So, guys, now we are reaching further to the plasma arc welding. It is also a type of arc welding, my dear. It is also a type of arc welding, my dear. So, whenever we are talking about the plasma arc welding, here the word coming is plasma. So, my dear, plasma, whenever we are talking about, is the fourth state of matter. It is the fourth state of matter. What are three? Solid, liquid, gas. Fourth is plasma. And plasma is the name of ionized gas. Ionized gas. And there is a term known as plasma gas. Plasma gas generally we are using as N2, nitrogen. So my dear, here what we are going to do, I am showing you a separate diagram. Let us say we are having a tungsten electrode once again. Why? Because very high temperature is going to be produced. So wherever high temperatures are going on, we are going to use tungsten. So we are using the tungsten, and here we are going to provide the plasma gases. What is plasma gas? Nitrogen. And my dear, here we are going to provide the power source between the workpiece and the electrode. And because of the power source between workpiece and electrode, here the arc will be getting produced. And as the arc will be getting produced, when the plasma gases are reacting, when the plasma gases are passing, by taking the heat from the arc, they get ionized. And when they get ionized, their temperature reaches from 8,000 degrees Celsius to 55,000 degrees Celsius. This is the temperature ranges which we can go for the plasma. But for the welding purpose, we are restricting it to 20,000 degrees Celsius. For when you will be going for plasma arc machining, then we will be going up to 55,000 degrees Celsius. You may be saying, sir, when 20,000 degrees Celsius also is a very big temperature, it will melt tungsten. I would like to say, guys, this temperature is there with that gas. Like the next festival is coming on 13th and 14th January, which in Haryana we call it as Lohdi. In that, what we are going to have, we are having a fire and we are sitting near to that. And it is always assumed that after that, the winter days are getting reduced. Winter is getting reduced and we are having some good weather. So whenever people are sitting around that, the air which is there with the fire, it is taking the heat from there and coming to us. The temperature of air is quite high. It may be more than a temperature at which our skin may melt. Because if you will be sitting onto the fire, you will melt. But my dear, when that you will burn, I will say, not melt, you will burn. So whenever that air is coming from that fire, we are having that air on our face. We are not getting burned. Why? Because I will not be getting burned by the temperature. I will be getting burned by the heat. Because my body has some heat absorption capacity. So whatever that heat air is having, if that will be giving to me, that heat is not enough to melt, or you can say burn me. So that is why I was sitting very comfortably and I was enjoying. You are also going to enjoy on 13th. Okay. So when we are talking about the welding, the same thing is happening. This temperature of 8,000 to 20,000 degrees Celsius is not going to be for the workpiece or electrode. It is the temperature of that plasma gas, which is converting into plasma. Because when plasma gas is becoming ionized gas, it becomes plasma. So when, my dear, we are having this plasma, that plasma is whenever going to hit to the workpiece, it would be going through, and this kind of hole will be produced. Means this type of welding will be produced. Is it clear? And you know, after today's subject also, you will be having a quiz on the BYJU'S exam prep app for this topic. So just share this, guys. So whenever we are talking about this process is going on, when those plasmas would be going to interact with the workpiece, welding will be getting performed. Welding will be getting performed. Is it clear, guys? Is it clear, guys? Yes. Is it clear, guys? Everybody understood this? Yes. I am telling you, just wait. Just wait, guys. Okay, guys. Very good, Sujit. Okay, so my dear, whenever we are talking about this, the welding is going to be produced. So this is said to be the plasma arc welding. And my dear, you may be thinking, sir, what about the electrode? Is it the tungsten electrode is going to melt? No, tungsten is once again non-consumable electrode. And why we are using tungsten? Because of high melting point temperature. Even this time we have to provide sometime the cooling along the tungsten. We are providing some external cooling so that anyhow, if tungsten is getting heat, we take that heat out so that it should not melt at any cost. Otherwise, the joint will be brittle. And my dear, whenever we are talking about this type of welding process, I would like to tell you filler rod would be there because electrode is non-consumable. Yes, filler rod will be there. What about the flux? You would be having the inert gas. So inert gas is also provided in place of flux in the plasma arc welding process. Now you may be having that whenever we are talking about this process, where it is used. So my dear, as you can see about the temperature ranges, this process is going to be used for welding of the materials which are alloys or super alloys. Okay, so those types of material generally we are going to melt or we are going to weld with the plasma arc welding process. Okay, so I feel everybody understood. Don't worry, Dheeraj, whatever the notes I have shared, there each and every process applications are given in the detail. Okay, here I am telling you some applications. There all applications are written. Yes, defense and space, like Surjit have said, to weld the titanium we are using that process. Okay, in aerospace industries we are using that process. All those things are mentioned there as well. Actually, these students are saying that from there only. Okay, so now we are moving to the next and last process, electroslag and electrogas welding. Now we are moving to the last process, electroslag and electrogas welding. So when we are talking about electroslag and electrogas welding, this is also a type of arc welding only. This is also a type of arc welding only. And whenever we are talking about this, this is the improvement over the submerged arc welding. Actually, submerged arc welding we were using for horizontal welds. Like if you want to weld the thin cylinder or LPG cylinder, it is going to be a horizontal welding process. But whenever we are talking that we are going to weld the ship plates, ship plate is not a procedure like you will go to a industry and say, give me a ship. That is done because ship is a very big thing. There you need to weld at the site you have to go. And these big plates will be held like that and you would be going for the vertical welds. So generally for vertical welds, we are using electroslag or electrogas. And for horizontal welds, we are going to use the LPG cylinders. Okay, so how this process is performed, I am telling you. Let us say we are having a workpiece plate here and another workpiece plate here. I am making actually the simplified diagram, which is not the bookish diagram. Now, if we are going to perform this vertical weld like this, the problem is if I will be keeping the plate like that, obviously to make the weld between them, I need to provide the electrode. So this is the electrode wire which I am going to provide once again with the wire spool to make the process continuous. Whatever we achieved, we will keep with us. We achieved the continuity by using the electrode wire with wire spool. So we will keep that continuity with us. We will not lose that. Okay, so my dear, when this is going to happen, the problem is if the welding will be starting here, molten metal will spill away. So to save that, we are using some starting plate. So this starting plate will help us to start the welding. Now, my dear, whenever this melting will start, from the below part, molten metal will not spill away. But as we are welding like this, from the sideways, still the molten metal can spill away. So to avoid that, we are using the copper shoes. We are using the copper shoes here. And those copper shoes, we are using both the sides. You can see in this figure, this is a copper shoe. And here we are also providing some artificial cooling because we want the welding to solidify along with that, along with the welding. So copper shoes are provided on both the sides. And as molten metal is coming, welding is going to get produced. Solidification is happening because of artificial cooling. And these copper electrode will be going upward with the welding process. Here, my dear, the losses are not going to be much without this copper shoes. Why we are using copper? Copper is a good conductor. So, my dear, here whenever we are going to do the welding, sometimes the temperature of the weld pool is reaching to a very high value, that even if we switch off the arc, the welding will continue to happen because of high temperatures. So that is why we stop, we switch off the arc, welding continues to happen. And once again, when temperature reduces, we switch on the arc. So here sometime we switch off the arc, sometime we switch on the arc. So here a term is defined that is known as duty cycle. Duty cycle is defined as the ratio of the time for which arc was switched on. So arc switched on time, but a welding time. That ratio we call it as duty cycle. Okay, so obviously whenever you would be having switch on arc, then only we are providing the power. So if duty cycle is given as 70%, 50%, it means you need to multiply with that power, because power is not provided for every second. It is provided only when arc is switched on. So when duty cycle is given, you just need to multiply this duty cycle with the power. Generally, we are having a record of standard 10 minutes continuous welding process. Generally, we are defining. Okay. Otherwise, duty cycle is defined whenever you know that already. If current will be more, then duty cycle will be less, because for welding the heat required is fixed. Let us say we want to generate 5000 joules of energy. Then to provide that, you know, I square RT. So you know I square into T if resistance is constant. If current will be more, time will be less. If current will be less, time will be more. That is as simple as that. So guys, coming back to the process. In this process, we are also providing the flux in the molten format like this. Okay, so in the molten format, we are providing the flux. So we are going to have the flux like this. Molten flux is going on. And this molten flux is going on just like the submerged arc welding, and here also the tendency of spatter will be very less, because the arc will be there in the pool of flux. And my dear, in this process, when the welding is going to happen, you can use flux also, you can use carbon dioxide also. When you are using flux, the name is electroslag welding. And when you are using CO2, because it is cheap, we are not using inert gas, we call this as electrogas welding. Process is same, the only thing is whether you are going to use the flux or you are going to use the gas. And here you can go up to 450 mm thickness. 450 mm thickness is the limit for this process. Previously it was 75 in submerged arc welding. With this arc welding is over, let us move further to the next type of welding. Everybody is clear? So guys, you can see in this 1 hour 50 minutes we completed arc welding, because it was the biggest process, because we have seen all the types of numericals as well. Are we ready for the next process? Are we ready for the next process? Please tell me. Are we ready for the next process? Please tell me. So you can see here also everything are written if you want to see later words. These PDFs are also having a lot of detail. Okay, like you were asking na? Fine. So you can see the plasma arc welding. This process is used for stainless steel, titanium, super alloys in aerospace industry. It is used for jet engine manufacturing and turbine blades. Okay, so Dheeraj, you were asking. So these things are as it is taken from my notes only. And these applications are there in detail in my notes. You can see. Notes are provided on Telegram. In PDF also they are written. Okay, I am telling also in the session. Moving further. Now we are going for the resistance welding. So my dear, whenever we are talking about the arc welding, if you know the principle, you were providing a potential difference, and whenever you were taking the electrode towards the workpiece, when the gap was such that the provided potential difference is enough to ionize the air between the gaps, welding was happening. And guys, that process is known as high voltage low current process. High voltage low current process. And I am telling you, when I will be teaching you ECM, EDM, non-traditional machining, EDM is also having the same principle. EDM is also having the same principle. धीरज, क्योंकि ये डाउट आस्किंग प्रोसेस नहीं है, ओके, ये डाउट सेशन नहीं है ना। अगर आपका कोई डाउट रह जाएगा तो यू कैन आस्क मी इन द टेलीग्राम चैनल ऑल्सो, सेपरेटली ऑल्सो। आई विल गिव यू माई नंबर ऑल्सो इफ रिक्वायर्ड, डोंट वरी। Curiosity, I will definitely try for that. I will definitely try for that. अच्छा, सारे क्लियर हो गए डाउट, that's fine. That's for that, thank you. Okay, I thought you are saying कि मैं आपको टाइम नहीं दे रहा हूँ पूछने का. Fine. Thanks then. Okay. Resistance welding is high current, low voltage process. Yes. Resistance welding is high current, low voltage process. Just opposite. And whenever we are talking about the resistance welding process, I would like to tell you guys why whenever we are talking about resistance welding process, whatever you have seen till now, we were always talking about the butt weld. You must be aware that if we are joining these two workpieces like this, it is said to be butt welding process. We have not talked about till now the lap joint configuration. This is said to be the lap joint configuration. This is butt, this is lap. This is butt, this is lap. So whatever we have told till now, whatever we have seen till now, it was related to the butt weld. Now, my dear, whenever resistance welding came into picture, it was having the first process with the configuration of lap joint. No doubt, with the time we improved that much that with the resistance welding also we can do the butt joint now. But when this process came at that time with the very first name as resistance sport welding, it was there for the lap joint configuration. Then, my dear, when we wanted multiple sports at one time, then we went for the projection welding process. But both these processes were not giving you leak proof joint. Leakage was there. So to avoid that, we wanted a leak proof joint. So we went for the seam welding process. Then we thought, okay, if we can go for the lap joint configuration, can we go for the butt joint also with the resistance welding? Yes. Whenever we are going with that, that is giving us flash butt weld. And then, my dear, with a very good application, when we will see to join the steel pipes, we are having the processes like high frequency resistance and induction welding. So these all are the processes we are going to see one by one. First we will see sport welding, and one by one we are going to see all the processes. And as resistance welding will be over, other processes will not take much time because numericals are only concentrated on these two processes. All other processes are just theoretical, where you just need to remember the application of the processes. Nothing more than that. So guys, moving further to the sport welding first of all. When we are talking about sport welding, how we are going to perform it? We are going to consider two workpieces. And we are going to keep them like this. Okay. We are having two electrodes, and those electrodes are of cylindrical shape. They are made up of copper. So one electrode is at the bottom like this, and other electrode is at the top like this. So this electrode is going to apply the force onto the workpiece. Okay, initially. And when we are going to have this, whatever is going to happen after that, I am showing you on the board. So you can see the same setup is made on the board. Just look at it. This is one workpiece. This is another workpiece. Okay, before going into all this, I am showing you a rough diagram. This is workpiece number 1. This is workpiece number 2. And let us say both are having some thickness. They can be same or different depending on the requirement. And my dear, we are going to have one electrode as fixed one, other electrode as moving one. So this bottom one is the fixed electrode. It is there like this. And that electrode is going to be like this. And when you are going to apply the forces, it is going to penetrate some part of the workpiece. Some penetration will be there, and it will be on both the sides. So you can also show like this. So my dear, initially we are going to compress them like that. We are squeezing them. And my dear, now whenever we are squeezing like that, after that what is going to happen? We are going to provide the current. And what is that current? That current is of the range more than 10,000 amperes. 10,000 and beyond that values are used for resistance welding. When you will reach to flash butt weld, there I will tell you 1 lakh ampere current is used. So that's why we call it as high current, low voltage process. Many students, whenever I say high voltage, low current, low voltage, high current, they are starting comparing the current and voltages. Like when I say that we are using the arc welding, you may have seen the voltages like 80 volt, 95 volts, like that. And current in that process you have seen like 950 amperes, 1000 amperes, like that. This was in the arc welding. And in the resistance welding, I am saying current will be used as more than 10,000 amperes. And voltage you may be having of the range of 10 volt, 12 volt, like that. So compare the voltage with the voltage and current with the current. Don't compare voltage with the current. So in resistance welding, voltages are lesser comparably to the arc welding. Currents are high. Currents are more than 10,000. Even we will go up to 1 lakh of amperes. So my dear, when we are going to pass that much current, don't you feel the heat generation is given as I square RT? If you are going to provide very high current, heat generation will be too much and both the plates can melt. Yes. So to avoid that, we need to reduce the time. So very high amount of current is passed for a very small duration. Time may be a fraction of second, sometime 0.1 second. Sometime 1/4 second, sometime 1 second, like that. If plates are very, very thick, then maybe going to 2 seconds, 3 seconds. But generally, it is passed for a fraction of second only. So for a fraction of second, you are going the current, you are applying the current, you are providing the current to pass. So when you are going to provide the current to pass, then my dear, the point is how the welding is going to take place. So we are passing the current for a very small duration, but how the weld is going to produce, that I am telling you. Actually, you can see heat generation is directly proportional to resistance. So when we see, we are using this as copper electrode, and you know the copper is having very good conductivity. And if conductivity is good, resistance will be less. So for copper conductor, conductivity is good and resistance is going to be less. And my dear, then you are welding the metals. Okay. So we are defining the first resistance R1 is the resistance of the electrode. Second resistance R2 we are defining as the resistance of the interface of electrode and workpiece. Then R3 is the resistance of the plate. R3 is the resistance of the plate. And then my dear, the most important resistance R4 is the resistance for the interface of both the plates. So if this is R4, this is R3 once again, this is R3 once again, the interface will be having R2 and once again this will be having R1. If you see a large number of resistances are joined in series, you can see first of all R1 of copper electrode, R2 of interface, R3 of plate, then R4 of interface of plate, then R3, R2, R1, like that. So R1, R2, R3, R4, R3, R2, R1. You can see these three are going for 2 times. So when you are going to see these resistances, you will be finding out the R4 resistance is much more than the 2 times of R1 plus R2 plus R3. So the resistance of the gap between the plate is always more. The reason behind that is you would be having the rough surfaces. The plates are looking like this, but the real surfaces are not like that. Real surfaces will be having some surface roughnesses. And because of these surface roughnesses, you would not be having the perfect contact. And because of that gap, you would be having the high resistance. Because you know, even if air is present, air is a good insulator. If air is not there, then also for the empty space, for the vacuum space, resistance will be more than the metals. So this resistance is always more. So when the same current is passed from this entire, my dear, where resistance is more, there more heat will be there. So resistance is more at R4, so more heat is produced at R4. Because of that, melting is going to start at R4. And when melting is going to start at R4, that melted part is that you can say fusion zone is extended to the full thickness. And that is said to be the fusion zone. And my dear, whenever this molten metal which is getting melted, this is not melted out, this is inside only. After some time it will solidify. After solidification, we will be calling it as weld nugget. Previously we were calling it as weld bead. Now we are calling it as weld nugget. And this weld nugget can be of any shape, spherical, elliptical, cylindrical. But my dear, if nothing is mentioned, we generally consider this cylindrical or spherical. Generally, these two shapes are only considered for the numerical purpose. And here you have seen there is no filler material required. That's why when I was defining welding, I was saying it's the process of joining two similar or dissimilar material with or without the application of heat or pressure, or both, with or without the application of filler material. Here filler material is not required. Here no need of flux. This is a different type of welding process. Here we are going for the spot welding. This is how the things are going to happen. Is it clear for everyone? Yes, this is autogeneous weld, you can say. So this now you may be asking where this is required. In automobile sector, we are using this type of spot welding process, and it is going to provide you a very good sound quality weld. So guys, do like and share the session. We are entered into the second process. Is it clear, guys? So this is about the spot welding process. Now my dear, we have already defined R1, R2, R3, R4. Now the same process is defined with the time cycles. Initially, we are going to increase the pressure. Wherever we are keeping the plates like that, we are applying the pressure. So initially, pressure is increased to some maximum value. This time is said to be the squeeze time. As we are squeezing the plate, we call it as squeeze time. Then we are keeping the pressure constant and we pass a cycle of current. And current is passed, because of that melting will happen. Then we keep the same pressure. We allow that melted part to get solidified. After that to happen, we are going to relieve the pressure as weld is performed. Sound quality means good quality. Okay. Sound word is used for good. Like whenever you say something, like you say, sir, I got 80 marks in GATE. I will say it sounds great. सुनकर अच्छा लगा, है ना? तो साउंड्स वर्ड वहां पर ऐसे यूज होता है. हियर वी यूज साउंड एज गुड क्वालिटी. ओके, yes dear, this is English now. Okay, that much English I don't know. I just know we can use it. Okay, why we use it, that is a part of English language. Okay, so don't go into that, because I am also a mechanical guy and mechanical guys are never good in English. Okay. Yes. Although I qualified that British English certificate was there in our college. I just qualified with 1 extra mark. 60 was the minimum. I got 61. Okay. But I know that much only. Okay, guys. Dear, yes, shortcomings are there. That's why we are having the other process. It is going to provide you a weld at one place like this. You got a spot like this. Okay, continuity of weld is not present here. Continuity of weld is not present here. Okay, so you can see in the comment section there is a link where you can fill the Google form. If you want counseling for any of the exam like GATE, Engineering Services, or any of the exam, ISRO, DRDO, BARC, with our counselors. Okay, yes. So when we are talking about this is the pressure current diagram. And I am telling you, actually, you need to study only till this one. One extra point I am telling you just for the sake of curiosity, that some suggestions were also made after this. Suggestions were made that whatever the pressure you are doing, you should not apply like this, you should apply like this. Initially, you provide some pressure and then you provide large pressure like this. This should be the pressure curve. This was given as a suggestion. And current should like this. One current cycle should be provided here for the welding purpose. And 1 to 2 current cycle should be provided here for relieving the stress. What is that actually? You know that welding is happening because whenever we have these two plates, there is a resistance between the interface of the plates. So suggestion was given that if you are going to apply high pressures here, because of the pressure, the cavity and the gaps can fulfilled. Resistance of the interface may get reduced. resistance of the interface may get reduced. So to avoid that, suggestion was given कि for welding purpose you give slight pressure. After that welding is completed, then you provide high pressure and relieve the stresses. Because if you are providing high pressure here only, you may get reduction in the heat here because of resistance reduction here. Yes, very good, very good, very good, guys. Naved, very good. चलिए बढ़ते हैं आगे. Let us move further. So no comments on the Vinny's comment. Moving further, guys. So when we are talking about, there are 4 types of time. One is squeeze time, other is weld time. Then we are having relief time, and here it is the stability time. So we have seen all these things. All these things are written. You can go for this. Moving to the second process, that is the projection welding. Are we ready? Within next 10 minutes, resistance welding will be over. Now the things will go at very high speed. Okay. Are we ready? Kar dijiye start. Next, we are going to move the projection welding process. Guys, projection welding process is also known as multi-spot welding. Projection welding is also known as multi-spot welding. If you want to provide multiple spots at one time, we call it as multi-spot welding. So if you talk about the multi-spot welding, here what we are going to have. Here let us say we have one plate like this. So on this one plate we are going to provide these projections. And these projections are provided with a process known as embossing. Okay, and I am not going into this process right now because today only in the evening I will teach you what is embossing. There are 2 processes, one is coining, other is embossing. They are similar processes only. If you don't know the difference, for the timing you understand it is coining only. So we are going to provide some projection on one sheet. Okay, so what we are going to happen, what we are going to do, we are going to put this one plate with projection like this. And the second plate like this. Okay. And my dear, now we are going to provide the multiple spots. So where you want spot, there only the projection is provided. Now my dear, you would be having the electrodes. You would be having the electrodes at the top like this, at the bottom like this. And you are going to apply the pressure first. And when you will apply the pressure, this projection will be having the plastic deformation. And because of the plastic deformation, you know that bonds will be breaking. Then you are going to pass the current. When you will be passing the current here, the resistance will be more. So more heat would be produced and you would be getting the spots to be produced. And the welding you will be having like this is one plate. This is another plate. Here one spot is there. Here another spot is there. Can you see I have shown thickness of this plate to be more, thickness of this plate to be less. T1, T2. So I have shown T1 is more than T2. Actually, it is being observed because of plastic deformation. More heat is going to be produced on the plate with the projections. So that is why we are going to provide more thickness to the plate which is having the projection. Or you can say projections are provided on the thicker sheet if both the plates are made up of the same material. And at the same time, if the thickness of both the plate is same, then we will provide the projection on the plate with a good conductivity material. So either they have same thickness, different material, we will go for the material with high conductivity. If they have same conductivity, same materials are there, and we are going to have more thickness for one, we will provide the projection on more thickness. Because to take the heat out to the surrounding, either we need conductivity or we need thickness, so that it can have the heat for the longer time and then can transfer to the atmosphere. So that is how the projection welding is performed. It is similar to the spot welding, just multiple spot at one time we are going to produce. Is it clear for everyone? So this is the projection welding. So hardness of the material has to be taken into consideration. Dear, whenever we are going for the welding, we are already taking those materials which are not having that hardness. Otherwise welding is not possible, na? So we would be already taking the materials, generally metals only. Okay, so that's why that is not becoming much important criteria. Moving further, guys. Now we are having the third process as flash butt welding. So as you have seen both the processes with the resistance welding for the lap joint configuration. Now if we are going to talk about the butt joint configuration, so then it comes about flash butt welding. This is the process in which 1 lakh ampere of current is going to be used. It is used for a very important application. I am telling you, in the production where numerical will not come, their application you need to remember. So for flash butt weld, the application is to join the railway tracks. Now many of you may be thinking, sir, railway tracks are joined by the thermit welding. Yes, you are correct. Thermit welding is used in the country like India. We are having developing countries. But in the developed countries, flash butt welding is also used for the joining of railway tracks. Okay, in India, the problem is whenever you have the railway network, railways are available even in the jungles where people are not living. So there it is very difficult. When people are not living, current is not available. 10 to the power 5 ampere current would require a very big setup. Not possible to take it there. We will go with thermit welding. Because thermit welding requires the thing which you have always in the pocket. For that we require a pudia of thermit mixture. Like you have pudia of other things. We need a lighter or a matchbox which you always have in your pocket. So that is going to be very easy process. Container we will arrange anyhow. So thermit welding also we will study, but in the developed countries, we are using this process for joining of railway tracks. And how we are doing that? This is railway track 1, this is railway track 2. We are going to take them close to each other. We are going to take them close to each other. Okay. So when we are going to take it close to each other, and when they are reaching close to each other like this, we are going to provide that 1 lakh ampere current. At the same time, we are going to press them also. But when you are going to provide the current, initially a flash is generated. That flash is indicating that if any oxide layer was present over the surface, that is burnt out now. And then you are going to apply the pressure and weld is getting performed. Because of 10 to the 5 ampere current, edges are becoming soft. And this time butt weld is produced using this process. And guys, joining of railway track is the application, but this is done in the developing country. So if in the question you have a question like which process is used to join the railway track, if thermit welding is in the option, you will go for that. If thermit welding is not there, you will go for flash butt weld. Is it clear? Ha, Naved, about the unwind formula that I will tell you in the machine design. Actually, this type of things are generally not coming in the gate. But in the machine design, I will teach you the unwind formula. Okay, there we will do some question also on that. Is it clear? Yes. So my dear, let us move further. Okay, flash butt weld can also be used for mild steel, alloy steel and titanium, and used for end-to-end, edge-to-edge joining also. Major application is railway tracks. Okay, so guys, now we are moving to the next process. We are moving to the next process. थोड़ा सा break ले लेते हैं, पानी पी लेते हैं. Break नहीं, पानी ले रहा हूँ just. We will be taking first break after completion of welding. Second break after completion of casting. Okay. Fine. So guys, next we are moving for the projection welding. So when we are talking about the projection welding, sorry, seam welding, we are talking about the seam welding. Okay. So when we are talking about the seam welding, my dear, here we are going to have one plate like this, other plate like this. If we want to join the two plates, thanks guys for cooperation. Nearest thermit welding. Thermit welding will be your first preference. Okay. So my dear, we are talking about the seam welding. So you have seen projection welding, you have seen spot welding. Both the welding processes were discontinuous type. But when we are talking about the seam welding process, it is going to provide you leak proof joint and it is a continuous welding process. Here, my dear, we are going to use disc type of electrodes. This is a disc. This is a disc. This question is already asked in the production industrial paper. That is the process in which we use disc type of electrode. It is nothing but seam welding. Yes, Kundan, that's fine. So you can take it. This is the power source. And these rollers are also pressing the plates. So they are also penetrating the plate like this. Some penetration is also there. And my dear, when they are applying the pressure, at the same time the current is passed. So when the current is passed, the weld is start forming like this. But the problem with this process is, like this disc will be reaching to this position. So when the current is passed like this to weld the unwelded portion, then some current will also pass through the welded portion. And that is going to be the loss, because welded portion I don't want the current to pass. You can also feel here, we are going to have weld nugget produced in such a way that all the weld nugget are intersecting with each other. Okay, so my dear, whenever we are going to have this process, some current is passing from the welding area, and that phenomena is said to be shunting of current. That is going to give us the loss, because that is useless. So guys, that is happening in this process, but yes, we are going to get leak-proof joint in the seam welding process. Yes, like Dheeraj is saying, manufacturing of oil drum, yes, it is done using this process. So where you want leak-proof joint, there definitely we are using it. Okay. So here leak-proof joints are produced. You can see application of this process is in fabrication of fuel tanks. You can see radiator bodies of or exhaust pipes of automobiles. So exhaust pipes of automobiles, you are having fabrication of fuel tanks, you are having the radiator bodies. So all these are produced with the seam welding process. I feel everybody is okay with this. Moving to the next type of process, that is high frequency resistance and induction welding. This will complete your resistance welding process. Whenever we are talking about high frequency induction and resistance welding, they are the same process. The only difference is if you are using the inductor coil. If you are using the inductor coil, we call it as high frequency induction welding. If you are using the conductor, copper conductor, we call it as resistance welding. Here, my dear, what we are going to take, let us say you want to make the steel pipes. If you want to make the steel pipes, then this process is used. Whenever we are talking about the pipes, there are two types of pipes available. What are the two types of pipe? One pipes are said to be the seamless, or you can say seamless joint. That seamless pipe or seamless joint we are going to have in the centrifugal, true centrifugal casting. Okay, because seam means joint. In the welding, how you can get jointless pipe? Welding means itself joint. So if they say seamless joint or seamless pipe, you would be saying centrifugal casting. But if they are saying steel pipe normally, then resistance welding, high frequency induction welding would be used for that. What we are going to do, let us say you want to make a pipe from this. Okay, so you know this type of pipe would be produced. You are going to produce this type of pipe. For that, this sheet will be available with you. So you would be folding this sheet and putting this like this. And you are going to give the input to that. And what I am doing actually with this, actually these are two concave rollers. These are two concave rollers. So I would be providing my sheet like this. This is my sheet. And when I will be providing my sheet, to make the cylindricity, we are providing a mandrel. And why concave rollers? Concave rollers will be going closer, 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 and will make a perfect fit. So between the concave rollers, it is going to be like this. This is one concave roller. This is another concave rollers. And you would be having this to be mandrel. Mandrel will be maintaining the cylindricity, and you would be having the pipe to be like this. Okay. Now, my dear, they will be going closer, 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 and this pipe will be produced, because at the same time you are going to give input to this in the inward direction. And when we are providing input in this direction, at the same time high frequency current is passing. Because of that high frequency current, the weld will be produced between these two ends. And this is said to be high frequency resistance welding and induction welding. You just need to remember it with one way, that this is the process which is used for the steel pipes. So in the gate, you will have the question from the application from such processes. Nothing more than that. Is it clear, guys, for everyone? Is it clear, guys, for everyone? This is high frequency induction and resistance welding. Okay, everybody got it? You can see the current range 100 kilohertz to 500 kilohertz. This is the range of current which we are going to provide. Okay, high frequency current is provided. So guys, now we have already completed the resistance welding. Everybody is clear? Please tell me. Then we are moving to the third type of process, that is said to be solid state welding. Clear for everyone? Please tell me that. Clear for everyone? Two types of welding processes are over. Two types of welding processes are over. Is it clear for everyone? Please tell me. Clear for everyone? Please tell me. Okay, guys. So then we are going to discuss about the next process, that is nothing but the solid state welding process. So my dear, whenever we are talking about the solid state welding process, whenever we are talking about the solid state welding process, whenever we are talking about the solid state welding process, Ravan King, don't worry, numerical will come. Okay, they are actually the similar one. Okay, there is not much difference, but we will do, don't worry. In between they will be coming, don't worry. Okay, numericals are there. Okay, that's great, Dheeraj. So when we are talking about the solid state welding process, I would like to tell you कि as the name suggests, solid state welding, here melting will not happen. When we say solid state welding, melting will not happen. Rutvik, there are two types of questions coming from welding. One is the numerical questions, other is the application. So in the application, they will ask you like, कि drill bit is joined with the shank with which of the process? Like fuel tanks are manufactured or welded by which of the process? Likewise, the questions will be there, and there will be 4 processes in the option. But 99% chances are numericals is coming. Only 1% I feel ki theory will come generally. Okay, because in the recent year numericals are coming from the welding. But if you see the previous era, then theory questions were also coming in more number. So I suggest ki you should go for both. If you are going for this session, theory question you will be able to make very easily from the application part. Okay, and numericals, for that some practice is required, which we are also doing in the class. One separate practice session will also be there for the production, don't worry. Okay, so everything we are going to cover here. Now we are talking about the solid state welding process. As the name suggests, here plates are not going to melt. Here plates are not going to melt. That's why we call it as solid state welding. So my dear, here the phenomena of joining will be the diffusion actually. So you will be having one metal is getting diffused into the other. And I feel everybody would be knowing the diffusion process. Like whenever we are going to have two gases, here is gas A, here is gas B. You are having partition in between. If this partition is removed, both the gases will be mixing into each other. Okay, that phenomena will be said to be the diffusion. Yes or no? So my dear, whenever we are talking about the solid state welding, it is classified into 5 categories. The very first type of solid state process is said to be the explosive welding. Then second process is going to be the friction welding. Third process is going to be the ultrasonic welding. Fourth process is going to be the pressure welding. Fifth process is going to be the forge welding. But here pressure and forge welding you can leave also, because they are generally used in the agricultural application. So they are not important for us. They are like gharelu processes, very simple. So majorly we need to study these 3 only for gate point of view. For engineering services, we need to discuss these 2 also. But as marathons are focusing gate majorly, so we will not go into that. We will go majorly into these 3. Explosive, friction and ultrasonic. When we are talking about the explosive welding, as the name suggests, explosion will be there. As the name suggests, explosion will be there. So what we are going to do in this process, we are going to have a workpiece which is becoming target. We are having a second plate that is said to be the flyer plate. We are going to have another plate that is said to be a flyer plate. I would like to tell you, this is a thin plate and this target is always going to be thick. Workpiece is always going to be thick. So this is thick workpiece, flyer plate is a thin plate. And my dear, whenever we are talking about thin and thick, I would like to say always target is kept thicker and this is said to be the thin plate. Always we are keeping the thickness like that. And then my dear, this explosion is kept because here we are going to use the explosion. You may be thinking, sir, explosion we have seen in the movies, like whenever we have seen the scene of the movie, whenever explosion happen, the nearby peoples are also flying in the air. So here also the same thing will happen when welding will be done by the explosion. All the people who would be doing welding all around, they will fly in the air. Is it going to happen like that? No. We are going to do this explosion in a controlled manner. Like in the Deepavali, we are going to have some kind of special equipment. You must have seen where we are going to put some explosive and we are having a patas. We are going to put it on the earth and a small, you can say, explosion happens, which are not going to cause that much harm. So we are going to have explosion in the limited or controlled manner, and we are putting this explosion not directly onto the plate. In between we are having a rubber buffer plate. Why rubber? Because rubber is having excellent vibration absorbing capacity. So we are going to provide this rubber buffer plate to avoid the surface blackening of the flyer plate. Because if explosive is directly present on that, it will be harming the surface. So to avoid that, we are keeping the rubber plate in between. So that surface of plate should remain the same. Should not be affected. So guys, this is the detonator which is used to start the reaction, start the explosion. And my dear, when the explosion will be happening, this flyer plate will be having that kind of wave, energy wave, that kind of push, like Akshay Kumar is getting in the movies. When the blast happens, he is going to fly in the air. So likewise, this flyer plate will be getting that energy and it will be behaving like semi-solid and lehrate, just swaying like that, it will be going onto the workpiece. So if it will be going like swaying like that, like we have one target plate, if it will be swaying like that, it can go on the other plate like that. We don't want that type of welding to happen. That's why we are going to provide this angle so that we can give a direction to the welding. Like if you have seen, whenever you are going for the mobile lamination, what that person is doing, he is putting that glass onto this. Then he is going to take like the finger like that so that air should not be accumulated inside. He is giving the direction to that sticking process. Here also we are going to provide the direction to the welding so that there should not be any such issue happen. And my dear, initially for some starting impact, we are providing this standoff distance. This process is used for the cladding of cylinders majorly, and also whenever we are going for the composites. Whenever we are going to make the composites, there is the laminated composite. So laminated composites are also made by explosive welding process. I feel everybody is clear for that. Everybody is clear for that. Everybody is clear for that. Okay, shall we move on? The second type of process, friction welding. Second type of process is friction welding. This is very important. It was asked in the recent GATE examination. In GATE 2022, I feel so. Whenever we are talking about friction welding, it is also a kind of solid state welding. So I am saying melting is not happening, but the plate which is going to weld, it will be behaving like semi-solid because very large energy is coming because of explosion. Now, my dear, second process is friction welding. In that, we are going to join two things with the help of friction. Melting will not happen here, diffusion will happen. Diffusion means the atoms of A will be getting diffused into the atoms of B. एक दूसरे में घुल मिल जाना. It is going to be like that. Okay, so whenever we are talking about the friction welding, how it is going to happen, guys, my dear, we are going to have, like, this is a rod A, which is going to rotate at a very high speed omega. And my dear, at the other thing, we are having one more rod which we need to connect with this, join with this. This is fixed. Sorry, this is at rest, stationary. We are going to put this towards the moving one. This is rotating, this is fixed. So I am taking towards them each other. Yes, like that. So when they will be moving like each other, this was rotating, this was stationary. So one was rotating, other was stationary. When they will be coming in contact with each other, you know there will be relative motion between them. And relative motion will result into friction, friction will result into heat. Because of the heat, you know that the ends will become softer and you are applying the pressure all time. So there will be a weld produced between these two things. That will also not going to melt. It is just going to have a diffusion welding process. So I am showing you what is happening. This is moving, this is stationary. Then they are coming in contact, friction will be there between them. And because of that friction, initially this was rotating, this was at rest. Slowly, slowly its speed will also start increasing. And after some time, both will be increasing with the same speed. And during that, when the speed is increasing from 0 to maximum, the welding will be happening. And you will find two types of weld to be produced here. One type of weld is like this. Second type of weld is like this. You would be having this type of weld to be produced if both the rods are made up of same material. But this type of weld will be produced if this is hard, this is soft. Because the hard one will become less soft, soft one will become more soft, so it will be deforming more. And guys, the application for this process is drill bit with the shank. This is just you need to remember, friction welding is used to join drill bit with the shank. Many times this question have been asked. So I would like to tell you here, shank is made up of tough material. Drill bit is made up of hard material. So here, my dear, drill bit is made up of hard material. Shank is made up of tough material. In the cutting tools, we want to have both the properties. We want toughness also, we want hardness also. So as we want both the properties, so to keep both, we use drill bit of the material with more hardness, shank with the material of more toughness. And that is how drill bit will be having both the properties. Everybody is clear? You would be knowing now there is a shank for the drill bit on which that bit is connected like this. Now next time whenever you see, you can see what type of thing, whether this type of weld you will see or this type of weld you will see. Check it next time whenever drilling happens in front of you. Clear for everyone, guys? Do like and share the session. Again and again I am saying, do like and share the session, guys, so that other student can also get the benefit of this video. Okay. Moving further, guys. The next process is ultrasonic welding, the last one to complete solid state welding. So my dear, whenever we are talking about the ultrasonic welding, here we would be using the ultrasonic energy for the welding purpose. Here, my dear, first of all, we are having a transducer. First of all, we are having a transducer. This transducer is going to produce the vibrations. And my dear, when this transducer is producing the vibration, there is the arrangement known as sonotrode. There is the arrangement known as sonotrode, which is a clamping arrangement, which is going to transfer these vibration to the high-speed steel tool tip. There is a tool tip of high-speed steel. You are going to keep two plates like that. Okay, and from topward, vibrations are going to get transfer. And you know, vibrations are a kind of energy only. And you are going to have pressure is applied with the anvil. You must have seen the anvil in the colleges also when you have went to the welding lab. That kind of anvil was present in the welding lab. So my dear, whenever we are going to do the operation like forging and all, we are having the anvil for the, whenever we are going to apply the hammering process, we are having the anvil there. So my dear, here this HSS tooltip vibrations will be providing, and because of that vibrations, the weld will be getting produced. This weld is not going to be very strong. This is very weak type of weld. If I give you an example, in the childhood, you have done one thing. Sometime whenever you were having the plastic polythenes, like you were having the small packets of something, you were joining that with the help of a candle. You were keeping the candle and you were just passing that plastic from that, and it got joined. That kind of joint will be produced here. Very light, very weak. You may be thinking, sir, why we are studying this? In the welding, weak joint have no role. Dear, whether joint should be weak or strong, that will also depend on the item. If item itself is delicate, we cannot provide the welding to that, na? If you are going to join, if you are going to weld the electronic components, let us assume transistor, diode, electronic items, they are delicate items. They cannot hold your welding. So for that purpose, we are having this specific process, ultrasonic welding, for electrical and electronics, brothers and sisters. Brothers and the sisters, okay, is it clear? So this is about ultrasonic welding. Clear, guys? So ultrasonic welding is used for electronic and electrical. Whenever we are going to join the diodes, transistors, those types of elements, ICs, we are using this process. Okay, this is the ultrasonic welding process. Okay, so guys, now we would be having the next welding process. Let me see. Actually, I feel we are left with a table. I want to do a table that. So we would be having questions at the end, don't worry. Okay, I feel the table was here. Let me complete that table first. Yes, this table. अरे भाई soldering brazing will be coming, Surjit. अभी welding is not completed. We are having a large number of processes. Only 3 processes are over: arc welding, resistance welding, solid state welding. Now we will be having gas welding. After gas welding, we would be having thermit welding. We would be having then soldering, brazing, and braze welding. Okay, so that actually there is a difference. Soldering is also used in electronics component, that's correct. But what is the difference? Both the things are used for different application. Generally, that soldering process, whenever we are using, there we are not having anything melting also with the workpiece. Here also we are not having the melting. That is the similarity between them. Even we have soldering, even we have brazing, they have different applications actually. But electrical and electronic components, when we talk about, there also not only one application there, na? There are also multiple components here, there are multiple applications are there. Like if you want to join the glass, then ultrasonic welding will be used. Then we cannot use soldering, brazing. Okay? Yes. Let us move further. Yes, curiosity. Now, my dear, we are going to have a table where we are having parameters here. And then we are going to have direct current, straight polarity, direct current, reverse polarity, and AC. AC means alternating current. So my dear, whenever we are talking about the polarity, here I would be writing about workpiece, electrode. Workpiece, electrode. Workpiece, electrode. I feel everybody know that whenever we are talking about the polarity, then direct current, straight polarity will be having workpiece positive, electrode negative. And direct current, reverse polarity will be having workpiece negative, electrode positive. And in alternating current, they will be alternatingly changing positive, negative, and negative, positive. Okay. Whenever, my dear, we are talking about the heat generation, you know, at workpiece it is 67%, at electrode it is 33%. In DCRP, workpiece 33%, 67%. Here 50-50. Then my dear, whenever we are talking about the penetration, as more heat is coming onto the workpiece, penetration would be deep in direct current straight polarity. Deep penetration means your workpiece would be having the penetration like this. And whenever we are going to have less heat over the workpiece, penetration will be shallow. So here we would be having the shallow. Then we are talking about alternating current. Here it will be intermediate. In between things. When we are talking about the wire feed rate, you know the electrode is melting. So if we are having straight polarity, less heat on the electrode wire. So here we would be having the less rate of melting for the wire. Here high rate of melting of the wire. Here intermediate. Thickness of the plate to weld, where workpiece is getting more heat. Here would be having more thick. Here would be having thin. Here alternate. Then my dear, workpiece preparation. What is workpiece preparation? Whenever we want to join the thick plates, we need more flux, more, you can say, more molten metal to come into the groove. So for that, we are generally removing some material to make the space for the upcoming material. That thing is said to be workpiece preparation. We do this if thickness is more than 6 mm. Then only we try this. So my dear, if that is the case, 6 mm, even I will say when thickness is more than 12 mm, generally then we try. 10-12 mm से ज़्यादा होगा तब generally करेंगे. So that is workpiece preparation that is required in case of thick plates, not required in case of thin. And here depends, because here we are going to have in between things. So this is going to be the table from where the question can be there. Be ready for that, guys. Okay, guys, be ready for that. Let us move further. Let us move further, guys. So I feel we have done all these three processes. Now we are moving to the gas welding. You may be asking, na, sir, from where the questions are coming. Theory questions are generally coming from the gas welding process. So I am showing you that. Be ready for that. And guys, we will be having a separate practice session also for welding, casting and sheet metal operation, what we study here today. So don't worry about that as well. So let us move further. Yes, everybody, थक गए क्या? अरे थक गए क्या? किसी को भूख तो नहीं लग रही? Okay, we are reaching to the gas welding. We are reaching to the gas welding now. So my dear, whenever we are talking about the gas welding, this is a very interesting topic. And I am telling you, from gas welding, a large number of questions from the theory parts are formed. Like numerical questions are coming from arc welding and resistance welding. Similarly, theory questions are coming from the gas welding. So my dear, whenever we are talking about the gas welding, I would like to tell you that gas welding is having a special name that is said to be oxy-fuel welding. So my dear, one more name of gas welding is oxy-fuel welding. One more name of gas welding is oxy-fuel welding. Now my dear, when we are talking about this fuel can be methane, this fuel can be hydrogen, this fuel can be acetylene, this fuel can be butane, this fuel can be any hydrocarbon. So my dear, if you are going to use any hydrocarbon, with the name of the hydrocarbon, the process name will also change. When we are using acetylene, it is oxy-acetylene welding. When we are using butane, it is oxy-butane welding. When we are using propane, it is oxy-propane welding. When we are using hydrogen, it is oxy-hydrogen welding. So whatever be the fuel or hydrocarbon you will be using, with that the name will be changing. But the question comes, sir, what is the principle of this welding process? Now the question comes, sir, what is the principle of this welding process? So my dear, like you have seen, the principle of welding process when we are talking about, this is a chemical reaction type of process. It is a chemical reaction type of welding. And when we are talking about chemical reaction type of welding, here whenever a hydrocarbon is getting reacted with oxygen, it is giving us carbon dioxide plus steam plus a large amount of heat. So you can see here we can do any type of gas welding, oxyacetylene, oxypropane, oxybutane, but in our syllabus only oxyacetylene welding is there. So when we are talking about oxyacetylene welding, we are taking the fuel as C2H2. Everybody would be knowing what is acetylene. It is HCHC, triple bonded, unsaturated. So my dear, whenever we have CH triple bond, this is acetylene, and when we are doing the reaction that is going to be with oxygen, C2H2 plus 5/2O2, it is going to result into 2CO2 plus H2O plus heat. We are interested in this heat only, na? For welding purpose, we need heat. Yes, good afternoon, Dheeraj. Kahan chale gaye the? Okay, so actually guys, we are interested in this heat. So whenever this acetylene will be reacting with the oxygen, it will give you 2CO2, that is carbon dioxide, plus water plus heat, and this water will be becoming steam because energy will make it steam. And we are not interested in any of these things, we are interested in heat. And whenever hydrocarbon is reacting with oxygen and doing that kind of reaction, that is said to be combustion. So if someone will ask you what is the principle of gas welding, you will say in one word, combustion. Is it clear, guys? No issue, Surjit. So whenever we are going to say this, chemistry is not required. That's why we do not join chemical engineering branch. Okay. So whenever we are talking about this overall reaction, this is giving us the energy, and that energy will be utilized for the making of welding. Now, my dear, whenever we are talking about for complete combustion, you can see 1 mole of acetylene is requiring 2.5 moles of oxygen. 1 mole of acetylene is requiring 2.5 moles of oxygen for this type of particular reaction. But my dear, if I will be providing 1 mole plus 2.5 mole of oxygen, combustion will happen completely. It would be like an IC engine. But I want a flame to come out for welding purpose. So for that reason, I will never be providing this 5/2 moles or 2.5 moles of oxygen from the cylinder for the complete combustion. I will be providing slightly less so that for the deficient oxygen, flame will be coming outside. With the help of that, I will be getting the welding process to be done. So I'm telling you what I want to say. Actually, whenever we are going to do this oxyacetylene welding, we are having a wonderful setup. We are having a cylinder made up of that is C2H2 cylinder, that is acetylene. Then we are having another cylinder for oxygen, and both will be giving input to a torch. This is the torch. And in this torch, the reaction will be taking place. And my dear, in this torch, as you are providing oxygen and acetylene, we are never providing 2.5 moles of oxygen because we want the flame to come out. And for flame to come out, we can never provide total oxygen from inside. We want the flame to come out and take the deficient oxygen from the outside. And for that purpose, we always provide oxygen less than 2.5 moles. But still, my dear, what kind of oxygen we will be providing in ratio of C2H2? Based on that, there are 3 types of flame defined. If you are going to provide O2 by C2H2 ratio as equals to 1, means we are going to provide 1 mole of oxygen for 1 mole of acetylene. 1 mole of oxygen for 1 mole of acetylene. We call this type of process as neutral flame. We say such type of flame as neutral flame. And my dear, whenever we see that flame, we need to understand that reaction once again. Actually, that reaction is happening in two ways. I'm telling you. You have written that reaction. Actually, this reaction is happening in 2 stages. First of all, C2H2 is reacting with oxygen and making 2CO plus H2 and releasing some energy E1. Then, my dear, this 2CO plus H2 is reacting with 3/2 O2, and that is going to convert into 2CO2 plus the steam plus E2 of energy. Now, my dear, this is said to be stage 1 reaction. This is said to be stage 2 reaction. So these are the two-stage reaction. You must have studied many times that whenever we are going to get CO2, we are never getting CO2 directly. Generally, it is first becoming CO, then CO is converting into CO2. So likewise here, these two reactions are acting all the times together inside the torch. And when all the times together they are going to happen, my dear, we are not going to provide the 2.5 moles of oxygen. When I'm talking about neutral flame, I'm providing 1 mole of oxygen, 1 mole of acetylene. Let us assume half mole is going for this reaction, half mole is going for this reaction. Here requirement is 1 mole, here requirement is 1.5 mole. Like you need 4 chapatis, I'm giving you 2. For rest 2, you need to go outside. So here, half mole of oxygen is going to this reaction, rest half is not available. Here half mole is provided, rest 1 is not available. So for that rest amount for complete combustion, flame will be going outside. So that is why in these types of processes, you will be getting 2 flame. One is said to be inner cone, other is said to be outer cone. So my dear, inner cone is representing the stage 1 reaction, outer cone is showing you the stage 2 reaction. So there are 2 cones which are representing 2 stage reactions. Stage 1 reaction is represented by inner cone, stage 2 reaction is represented by outer cone. Stage 1 reaction, inner cone, stage 2 reaction, outer cone. Clear guys for everyone? Clear guys for everyone? Stage 1 reaction. Yes, we would be having inner white cone. We would be having outer bluish cone. We would be having inner white cone, outer bluish cone. So my dear, whenever we are having these 2 cones, we are generally having that inner cone to be traveling a distance. That distance I am showing with N because the name of flame is neutral flame. So in the neutral flame, the distance traveled by the inner cone is N. So don't worry guys, we would be completing the welding and completing all the process. We will see some more numericals, okay? And after numericals, we will enter into casting then. Clear? Okay, casting we will be doing after break, don't worry. Fine. First, let me complete all the processes because now we are in a good flow. Okay, so guys, whenever we are talking about this N is the distance traveled by the inner cone to get the deficient oxygen. Similarly, outer cone is getting the deficient amount by this much. Outer cone have to travel more because more oxygen is required. Inner cone have to travel less as less temperature is required. Now, my dear, some of you may be having a doubt, ki, sir, can you tell us that out of this E1 and E2, which energy is going to be more? Can you tell us out of this E1 and E2, which energy is going to be more? So, my dear, the answer is no. We cannot say. For different fuels, for some of the fuel, you may be having E1 more than E2. For other fuels, you may be having E2 more than E1. So, we can have any energy to be more. We can have any energy to be more. We can have any energy to be more. So if we can have any energy to be more, if we can have any energy to be more E1 or E2, then I would like to say, my dear, but one thing is fixed, that always the temperature of the inner cone is going to be maximum, and for neutral flame it is going to be 3260 degrees Celsius. Why? Because I told you कि temperature will be coming based on the surface, because if a surface is bigger, the same heat will be distributed. Like if 10 chapatis are distributed in 10 peoples, every person will be getting 1 chapati. But the same 10 chapati will be distributed into 4 peoples, every person will be getting 2.5 chapatis. If the same 10 chapatis are distributed into 2 people, every person will be getting 5 chapatis. So less number of persons, more chapatis per person. So my dear, that is why as the surface area of inner cone is lesser, because less oxygen is required, it is traveling lesser, so temperature will be more for the inner cone. That is why for welding purpose we are always using the inner cone. Inner cone is always used for the welding purpose. Outer cone is never used for the welding purpose. Outer cone is used for either preheating or post-heating. Either preheating or post-heating. Either preheating or post-heating. What is that? That also I will tell you. Preheating is done before welding, post-heating is done after welding. Okay, both have different advantage. We will study in detail within some minutes. First of all, tell me everybody is clear about this or not? This wonderful explanation, everybody understood or not? So that is why, as the temperature is more for the inner cone, so that is why inner cone is used for the welding purpose. And you may be thinking, sir, why we are using acetylene? Is it provide us more amount of energy? So I would like to say the highest energy per unit of fuel is provided by propane. But propane is costly also. Availability is also an issue. Okay. Yes. Everybody got it? Very good, guys. Very good, guys. बहुत ही बढ़िया. This is stage 1. This is stage 2. So my dear, we have seen welding will be happening from the inner cone. Outer cone will be used for pre and post heating for sure. Then my dear, moving further, whenever we are talking about neutral flame is giving you the sound like hissing. So in this welding process, hissing sound is there. You must have seen a movie was there, hiss. So that kind of sound is coming always whenever we are going to have the welding with the neutral flame. And guys, now we are moving to the second type of flame that is said to be nothing but the oxidizing flame. Neutral flame, oxidizing flame, carburizing flame. Oxidizing flame is the name given when oxygen to C2H2 ratio is more than 1. Some people have confusion that in oxidizing process, oxidizing flame, we are providing excess amount of oxygen. If you are asking that, I will say the answer is not correct. We are not providing excess oxygen. We are providing more amount of oxygen as compared to acetylene. You know, 1 acetylene requires 2.5 oxygen. But we are providing for 1 acetylene 1.15 to 1.7 mole of oxygen. We are still not providing 2.5. And if we are not providing 2.5, once again flame has to come out to take the deficient part. But this time, as you are providing more, flame will be traveling less. Previously, I was providing you 2 chapatis, you were going for 2 chapatis. Now I am providing you 3 chapatis, you will be going for 1 chapati. So you have to travel less. So my dear, this time, whatever the travel is done by the inner cone, that is n by 3, actually it is n by 2 to n by 3. This is in this range. If previously it was n, now it is 0.33 to 0.5 times of n. And guys, when you are talking about temperature, this time it is going to be more because surface area is reduced. So because of reduction in the surface area, temperature will increase. This time you will be reaching to 3380. Previously it was 3260. Temperature is increased. And my dear, as temperature is increased, we are going to use this type of flame for welding of alloys. For ferrous metals, for ferrous materials, we are using neutral flame. For alloys like brass, bronze, we are using oxidizing flame. There is a very interesting question which was asked in GATE. Ki why we are not welding the brass? Why we are not welding the brass with the neutral flame? But we are welding with the oxidizing flame. So guys, there is a very interesting reason behind that. You know, whenever we are talking about brass, bronze, you know, in the brass we are having zinc as an impurity. Not impurity, actually by putting the zinc we are making the alloys. Zinc is having very, very less melting point temperature. And not only melting point temperature, it is having very less vaporization temperature. So like let us say you are having a molten weld pool. There are chances that zinc will be vaporizes. So if you are going to provide oxidizing flame with some of the oxygen, zinc is going to make a zinc oxide layer over the weld pool. And when this zinc oxide layer is produced in case of oxidizing flame, because I am providing more oxygen, so my oxygen is also utilized by the zinc. It is becoming zinc oxide. And when it is becoming zinc oxide, it is having high vaporization and melting temperature. It is not going to allow the rest of the zinc to come out. So that is why we always use oxidizing flame for this kind of alloys. So for ferrous materials, generally we are using the neutral flame. But my dear, whenever we are going to have alloys, we would be using the oxidizing flame. Please tell me, is it clear for everyone or not? Very good, Ajay. Very good knowledge and information. Yes, Dheeraj understood. Sujit understood. Vamshi understood. Rutvik understood. Akhil understood. Kunal, Vinay. Everybody, please tell me, guys. Everybody, please tell me the guys. Yes, Vishal, very good. Wonderful. Very good, Neeraj. Ravan King, bahut badhiya. So, guys, this is about the oxidizing flame. And oxidizing flame is having a roaring sound. Roaring sound. Now, my dear, we are moving to the next. The next is going to be carburizing flame. As the name suggests, carburizing, we are going to have lesser fuel than the neutral flame case. Like this time, I am going to provide O2 by C2H2. This is going to be less than 1. Generally, 0.6 to 0.85 moles of oxygen is provided for 1 mole of acetylene. This time, deficiency is more. So to take more oxygen from outside, flame will be traveling more distance. And when the flame will be traveling more distance, this time this distance is going up to 2N. So temperature is getting reduced to 3060. Whatever I am saying, this is the maximum temperature of inner flame. If you want to say outer flame, temperature will be lesser. And if you are going for the average temperature of the flame, it is always going to be 2 by 3 of the maximum temperature. So if they ask you the average temperature of flame, it is generally lying in the range of 2/3 of the maximum temperature. So my dear, whenever we are talking about this carburizing flame, the average temperature will be reaching to 2/3 of the maximum temperature. This is going to be the case of carburizing and reducing flame. Here carbon amount is more, because of which sometime it is being observed that some of the acetylene feather are coming outside. And as they are coming outside, sometime carbon is absorbed by the workpiece from that. So that is why this process we will not be using to weld the elements which are able to take the carbon, which are not saturated for carbon. Like if you are going to weld the mild steel, it will be taking the carbon from that acetylene portion. So that is why we will not be using. We would be using this process for welding of cast iron, for welding of high carbon steel, because they are already saturated with carbon. They will not be going for more carbon from the acetylene. So they are saturated with the carbon. And because of they are saturated with the carbon, my dear, we can weld them from this. This is a silent flame, not having any sound. This is silent flame, not having any sound. Is it clear? So guys, just share the session once again. I don't know why some people have went to the lunch. Please tell me any doubt, guys. Please tell me any doubt, then we are moving further. We have seen all the types of flame. We have seen all the types of flame. Yes. So guys, do like and share the session. Okay, guys. Fine, everyone. Very good. So guys, now we are going to talk about one more thing. Ki whenever we are talking about all the 3 types of flame, there is something known as welding technique. One type of welding technique, we call it as forehand or forward welding technique. In that, my dear, you will see that this is going to be the inner cone, this is going to be the outer cone. I'm making outer with a different color. We are having outer cone and inner cone. You can see outer cone will be reaching first and then inner cone will be reaching to a surface. We are moving from welded to non-welded portion. This is forward welding technique. And when, my dear, this is reaching to the non-welding portion, when this is reaching to the non-welding portion, it is going to heat the workpiece before welding. So that is why we are saying that in forehand welding technique, it is going to have a concept of preheating. So preheating will be taking place. Whenever we are heating the plate before welding process, we call this as preheating process. And preheating is going to help us in removing the oxide layers. In removing the oxide layer to avoid the cracks, because you are heating it first with the outer flame, then you are welding with inner flame. So chances of cracks are minimum, plate distortion will be minimum, oxide layer will be burned out, any impurity, oil, grease present will be burned out. These all are the advantages. These all are the advantages. Very good, Ashray. Very good, Ashray. Then, my dear, we are going to have the backhand welding technique. Here you can see we are moving towards this, but we are having the face towards the welding portion. That is why this time you are going to say, whenever we would be having the torch at this position, then inner flame will be this and outer flame will be this. Always inner flame is used for the welding purpose. Here outer flame is coming after welding, so we will say post heating will take place. Here outer flame is reaching after welding, so we will say post heating will take place. And post heating will be helping us in relieving the thermal stresses. Okay guys, so this was the backhand welding technique. Now I would like to tell you about the torch angle. Whenever you are going to say this is the axis of the torch, this is the workpiece surface axis, you can see the angle between them is said to be the torch angle. So whenever we are going to start the welding, initially we are going to have the torch to be just perpendicular to the workpiece surface, because entire energy is required to weld, because starting plates are in the cooler state. But when the welding start, we would be reducing the angle between somewhere from 0 to 90, and when welding is over, we will be going for 0 degree or 180 degree. So this is how the torch angle variation is going to happen during the welding process. Is it clear, guys, for everyone? Please tell me that. Is it clear, guys, for everyone? Please tell me that. Is it clear, guys, for everyone? Please tell me that. Okay. Fine, guys. Fine, guys. Fine, guys. So now we are moving further, guys. Now we are moving further once again. So we are talking about torch angle we have seen. And I would also like to tell you the next process as air acetylene welding. You were having a oxygen cylinder, you were having a acetylene cylinder. Now, my dear, whenever we are talking about the materials of the cylinder, that is generally not coming in GATE. These types of questions are coming in engineering services. So I would like to tell you, generally we are going to use the steel cylinder for acetylene and copper cylinder for oxygen, because copper is reactive for acetylene and steel can get problem of corrosion with oxygen. So that is why we are not using copper cylinder for acetylene and steel cylinder for oxygen. So these are the cylinder material. These are not asked in the GATE exam. So I would like to tell you, whenever we are talking about the air acetylene welding, if you are saying why we are providing any oxygen cylinder when the entire air can be taken from the outside. So you are saying we will not provide any mole of oxygen from inside cylinder. We will say entire oxygen will be taken from outside. Then obviously flame have to travel more and more, because of which the temperature of the flame will be reduced up to 2300 degrees Celsius. Then the process, we call it as air acetylene welding, because this time oxygen is coming from air. So we are not saying it as oxy-fuel welding. This is air fuel welding. And my dear, when we were talking about acetylene welding, there is a very important point कि acetylene is a element which can explode under its own weight. So we never provide acetylene alone in the cylinder, otherwise explosion can happen. So we are always providing acetylene with acetone. So we are providing acetylene with acetone. And when we are providing like this, acetone is acting like a seat for acetylene. And my dear, you may be thinking, sir, when we are having both acetylene and acetone, there are chances now कि in place of acetylene, acetone will come. So acetone is heavier than acetylene, so acetylene will be coming first. and after some time if acetylene is over, completed, then my dear you will be getting a purple color flame which will indicate that acetylene is empty now, you need to fill the acetylene more. So acetone, if it will be coming out, it will give you purple color flame. Is it clear for everyone? Yes. So guys, this is about gas welding. Now we are coming to the radiant energy welding. Just 3 more processes are left. Okay. So after completion of welding, I will give you break, lunch break, and then we will go for the casting after the break, and after casting, we will be having a tea break. Then we will be having the sheet metal operations. In that way, we will be completing all the 3 topics today. Okay. And practice session of these 3 topics we will keep tomorrow. Practice session of these 3 topics we will have tomorrow, like we have midnight practice sessions. Are we ready for that? Yes, tomorrow we will be having a practice session for these 3 topics. In the class also we are solving 5, 7, 10 questions of each topic. But 20 questions separate practice session would be there tomorrow. And Saturday, Sunday we are going to have theory of machines and machine design. Everybody, those who want to make strong their TOM and MD, have to join on those 2 days. Okay guys, now we are going for the electron beam welding. My dear, electron beam welding is also said to be the radiant energy welding. When we are talking about radiant energy welding, there are 2 processes here: electron beam welding and laser beam welding. Electron beam welding and laser beam welding. So my dear, whenever we are talking about अरे भाई फनेंद्र चिंता मत करो, नहीं रहेगा वो, क्लैश नहीं होने देंगे, एक ही चीज रहेगी, है ना. We will avoid the clash. We have already talked for that. Clash will not be there. Don't worry. Okay. Is it clear? And don't worry, dear, after 20th on this channel, I feel at least 4 sessions for aptitude will be coming. So don't worry. On YouTube, on this channel, aptitude sessions would be there after 20th. So don't worry about that. Okay. So whenever we are talking about electron beam welding, how this is performed, let us see. How this is performed, let us see. No, Rishabh, today there is no bulk metal forming. Bulk metal forming will be with the material science. Bulk metal forming will be with the material science. Okay. Fine, guys. Now let us see the electron beam welding. So my dear, in the electron beam welding, I am making my own simple diagram, because in the exam, simple diagram will help you more. Okay. So this is also simple. Actually, we are going to have actually a tungsten electrode. Okay. So we are going to have a tungsten electrode like this. A tungsten electrode is there. And then my dear, with this tungsten electrode, we are having a cup-shaped cathode. This is the cup-shaped cathode. Then we are going to have an annular anode. And this annular anode is going to have connection with the power source like that. And there is a catch. Whenever we are talking about annular anode is having some holes into that. So my dear, whenever we are going to have holes into that, after that we are having here some electromagnetic focusing lens. And then we are having the plates here to join. These are the plates to join. And they are kept over some surface. Is it clear? And my dear, whenever I am talking about this, whenever I am talking about this, whenever I am talking about this, whenever I am talking about that, this is tungsten, this is power source, this is annular anode. Electron beam will be coming from this tungsten electrode, which will be acting like an electron gun. Because here it is the cup-shaped cathode. From the cathode, electron will be getting resistance, repelling with each other. So because of that repulsion, with very high speed, these electrons are going to be there with this annular anode. Have you seen an ad was coming in the previous days, where hero was doing like that? Heroine was coming, but as the heroine reaches to the hero have to handle his pent. He put his hands there and heroine falls down. The same kind of thing is happening here. Hero is saying like this. Heroine is coming from here, but here some holes are present. Because of these holes, these electrons will be passing from there. These electrons are going to pass from there because some holes are present there. So from that hole, these electrons are passing. But my dear, these electrons are very much, you can say, separate to each other. For welding purpose, I need to converge them at one place. For that, we are having these electromagnetic focusing lens. And these electromagnetic focusing lens are going to merge them at the welding area. Going to converge them at the welding area. Now, how the welding is going to happen? As you can see, from here, repulsion, from here, attraction. Hero was calling heroine, aa jao. Heroine was coming and then he is putting this. So heroine fell down. So here also electron fell down. Then these focusing lenses are focusing them onto an area. When they are focusing them onto the area, their welding will take place because the kinetic energy of the electron is getting converted into the heat energy. So when those electrons will be going to workpiece, they will transfer their kinetic energy and that will be converting into heat energy which will be helping us for the welding purpose. Is it clear? So my dear, in that way, the welding will be taking place. In that way, the welding will be taking place. And my dear, now there is one problem that if air would be present, those electrons can collide with air molecules and give their energy. So that is why we want the air should not present there. So that is why we are providing the vacuum. And there is one more problem. When electrons are going to strike a metal surface, then X-rays are produced. X-rays are very dangerous. They can cause cancer. So the person who would be working near around, they can get the cancer issues. So to avoid that, we are going to make lead line setup. Because lead is going to absorb the X-rays. Electron beam welding is going to be used for deep penetration and percussion welds. It is used in aerospace industry. As you are using vacuum, there are no chances of oxidation. So aluminium can also be welded here. The super alloys like titanium and other cobalt, those types of materials are also welded there. So this is the wonderful process of radiation energy welding. I feel everybody is clear about this. The problem is that vacuum is going to provide more cost for this process. So that is why laser beam welding is preferred over electron beam welding. And my dear, whenever we are talking about this, electron beam welding, the application of this process is in joining tungsten, titanium, nickel, cobalt, stainless steel, beryllium in aerospace industry, missile and nuclear power plant. Okay, and then we are moving to the next process, thermit welding. I already told you thermit welding is famous for joining the railway tracks. And this is the process which is used by the developing countries because it do not require the heavy setup for welding purpose. It do not require the heavy setup for the welding purpose. So my dear, thermit welding process is used to weld and repair the railway tracks. Then thermit mixture is kept in a container in some special, actually what is thermit mixture here? We are going to have Fe3O4 plus aluminium. This combination is said to be the thermit mixture. This is present in the powder form, we have it. And my dear, whenever we are going to have these 3 Fe3O4 and 8 aluminium. So they are in the ratio of 3:8. Mole wise, 3 moles of Fe3O4, 8 moles of aluminium. When they will be reacting with each other, they will be giving you 9 Fe plus. 9 Fe plus, 9 Fe plus, you will be having Al2O3, 4 Al2O3. So my dear, this iron and plus you would be having a large amount of heat. And that heat will be such that this iron will be in the boiling condition. Because this is a exothermic reaction. A large amount of heat is produced because of that steel turns to boil. And that boiling steel, actually you are going to have a container like this. In this container, you would be putting the thermit mixture. You would be putting your hand into your pocket, taking the pudiya out, putting the pudiya down in the container. You are there in a jungle, you want to join the railway track on site. You have pudiya in one hand, lighter in the pocket. You reach there, putting that. Sometimes we use barium oxide to initiate the reaction. So after initiation of reaction, you would be pouring this where the railway tracks needs to join. You would be pouring that molten mixture. And here, my dear, this Al2O3 will be acting like a slag. And that slag would be removed after the welding purpose. This is how thermit welding is done. And what kind of question will be coming? Number one, application to join the railway tracks on site. Second question which can be there, the ratio in which they are added, 3/8 by mole and 3/1 by mass. If mass wise you will say, then 3:1. Here in the reaction you can see mole ratio, 3 mole of this to 8 mole of this. This is going to be the thermit welding process. I feel everybody understood this process. This is also coming in the chemical reaction type of welding, because exothermic reaction is going to happen. So this is the entire table. We have completed explosive, friction and ultrasonic welding. We have completed submerged arc welding, shielded metal arc welding, TIG, MIG, plasma arc welding, electrogas and electroslag welding. We completed sport, seam, projection, flash butt all welding, gas welding, thermit welding, chemical reaction welding is over. Then we are going to have soldering, brazing and braze welding. We are reaching to that now. We have almost completed the welding process. Clear, guys? Are I so much moving further, guys? This is some theory parts, that's why. Okay, we have seen that. This process is not mentioned in the table, but this is a very important process and it can come in the GATE exam. That is atomic hydrogen welding. We are coming on to the laser beam welding also. Just within next 5-10 minutes, welding will be over. Okay. Then we will see soldering, brazing, braze welding. After that, we will see some question and then break. So guys, we are talking about atomic hydrogen welding. What is going to happen here? So first of all, my dear, we are going to have here a very different and interesting process. And many students have confusion there. And whenever I have taken interviews with many faculties, many students, none of them have given the satisfactory answer for this. Even the ESC mains aspirants, those who were our student, they have only answered this because I told this fact in the class. And only a multi-dimensional faculty can tell you that fact, who is having the knowledge of all subjects. What is that? Let us see. We are going to have hydrogen gas in this. And my dear, very good Sandeep. So hydrogen gas is provided from here. And my dear, whenever hydrogen gas is provided, here you are having positive and negative electrode which are going to produce arc here. By taking the energy from the arc, hydrogen is getting converted into hydrogen positive and hydrogen negative. It is an endothermic reaction. We have given energy because there is a simple rule of chemistry. Whenever bonds are formed, energy is released. Whenever bonds are broken, energy is consumed. So here bond is broken, energy is consumed. So here energy is required. That energy is coming from the arc. So we are not doing welding from the arc. We are using that arc for breaking the hydrogen. Then as these ions are unstable, they will be reforming hydrogen gas. Along with that, a large amount of energy will be produced. And that energy, my dear, would be used for the welding purpose. That energy will be used for the welding purpose. Now, my dear, whenever I ask to the student, when we are going to provide some energy here for breaking the hydrogen, the same energy when you are getting here, you are using for the welding purpose. Why you are doing all this? You directly use the arc welding. When we are using this energy for the welding, there is no need to do all this. What you are doing? You are breaking the hydrogen, then joining the hydrogen, then whatever the energy you are getting, then you are doing the welding. Then many student gives the reason that, sir, this energy is more than this. Then I say the next thing, what better than this can happen? If just by breaking hydrogen, joining hydrogen, we are amplifying the energy, means you are breaking the hydrogen, they are joining and giving you more energy. You are spending 100 joules, you are getting 150 joules. Why you are studying, guys? Just do this only, produce energy, provide it to the government. No need to do study and all. And where is thermodynamics first law? Energy can neither be created nor destroyed. So the reason is not that this energy is going to be more than that energy. That is breaking the principle. Because neither it is fission-fusion processes. Here hydrogen is remaining hydrogen, so no loss of mass happening. From where energy is coming, bhai? So my dear, reason is not that. Reason is there in the heat transfer. In the heat transfer, actually we study that whenever we are talking about the conductivity with the temperature, this curve you have studied in the first chapter, introduction. This is the curve for air, this is for hydrogen, this is for helium. So you can see conductivity of hydrogen is more than air at some temperature. So when you are going to provide this atmosphere, the same energy would be transferring with more efficiency to the workpiece. If previously out of 100, 60 joule was going, now maybe 80 joule will be transferring. So efficiency of the welding will increase. Are you getting it? So here efficiency of the welding will be increasing. So energy is not increasing, bhai. Energy is the same, but efficiency will increase. So the transfer of energy will be more. And hydrogen will also act like the shielding gas. Hydrogen will also act like the shielding gas. Clear for everyone? Clear for everyone? This is generally used for the purpose of, what? For welding of die steels, we are using this process. Okay, so this is going to be the atomic hydrogen welding process. Now, my dear, we are entering into nothing but the next one. Okay, so guys, this is a formula for the heat flow. I am telling you, this is never asked in GATE, never asked in engineering services objective. So you can leave it, but still I am telling you, for the sport type of welding, when we are considering this sport as a sphere, which is a 3D element. So for 3D, this is the formula for heat flow in the welding process, like how the heat will be flowing in 3 dimension. And when we are talking about the arc welding, so in the arc welding, we would be considering the weld as a line. This is going to be a 2D case. For that, this is the formula for welding, formula for heat flow. You can leave this topic, never question will be asked. Okay, so now I am just going to the laser beam welding. Where is laser beam welding? Let me go. Laser beam welding. The last type of welding left, then we will go to the soldering, brazing and braze welding. Okay, so let me see what is laser beam welding. So my dear, when we are going to talk about the laser beam welding, it is also a process of radiant energy welding. This is also a process of radiant energy welding. So when we are talking about the radiant energy welding, so here what is going to happen? Here, my dear, we are having a wonderful diagram where I will be telling you what is going to happen. Actually, this is a diagram for the setup. We are going to have this as a lacing tube in which xenon lamp is there. And my dear, this xenon lamp is going to provide the monochromatic light. It is a light source. Here is the pumping zone where we are going to provide the powder particle. So my dear, whenever this energy is provided, that is taken by those powder particles. And what is going to happen in that, I am telling you, actually this is the lower energy state of atom. This is the higher energy state of atom. So when you are providing the energy, because light is the form of energy, wave nature, particle nature, you know that. So when we are providing that energy, by taking the energy, atoms are going to the higher energy states. Lower energy to higher energy state, atoms are going to move. When we say this is not a space. It is not like this is Delhi, this is Chandigarh, not like that. When atoms energy level, I am showing here, energy level is increased. And my dear, whenever anything is at higher energy, it is feeling instability. So to become stable, it will leave energy. And by leaving energy, they will be coming to the metastable state. And also after that, by leaving more energy, they can reach to the lower energy state. So when this inversion taking place, when those atoms are moving to the metastable and stable states, they are leaving some packets of energy, which we call as photons. You know, energy can be felt as the wave nature also. So we are considering like wave nature. So whenever this is released, my dear, there we are going to provide a 100% reflecting surface. Here 98% reflecting surface. So whatever those waves are going to be produced in the form of laser, we want to come out. So this will not allow any waves to go outside. And this will allow only those waves, those 2% waves to come out, which are coming just straight, just perpendicular to the surface. And they will be then deviated by this mirror to the convex lens, which are going to mate it at a place where welding is required. So this is the process where no vacuum is required. This is also a radiant energy welding process. So the advantage of this process is there is no vacuum is required. That is why laser beam welding is always preferred over the electron beam welding. And they are always providing the deep welds. So when we are going to make the welds, I would like to say in electron beam welding and laser beam welding, if this is the D, this is the B, then generally D to B ratio is going to be 3:1. So depth is always more than the width. That's why we call it as deep penetration welds are produced. That's why we call it as deep penetration welds are produced. Clear for everyone? Clear for everyone, guys? Clear for everyone, guys? Clear for everyone, guys? Okay, the same things are written here. There are two types of laser we are using. One is NdYAG. Here ND is for neodymium, Y for yttrium, A for aluminium, G for garnet. Second is CO2 welding. Second is CO2 laser. Now is the question coming, guys. You were asking for question from a long duration. Sir, question karao, question karao, question आ गए भाई. Okay, आ गए question, कर लो. ठीक है? Let's do questions now. So guys, now we will do 4, 5, 7 questions. And then we will see soldering, brazing, braze welding. At 2 p.m. I will give you break. Okay. Then after that, 30 minutes of break, we will meet once again for the casting and sheet metal operations. And be there till evening. If you would be supporting fully, I will be doing everything for you. This 1 month is dedicated to you. Every student who is present here. If you want 100% out of me, show your 100% also. What would be the answer? This is a very simple question. I feel everybody can try this. This is from GATE PYQ only. Some of you may be remembering the answer as well. Yes. Because today is welding, casting and sheet metal operation. Then we are going to have one session for metal forming and material science. Then one session for metal cutting, metrology and sim. Solve it. Till that time, let me take some water. Solve this question, guys. Yes. हाँ श्रेय, क्लास में तो सब किया है यार. ठीक है, पर यहाँ पर मैराथन में क्वेश्चंस का जो कारण है वो ऐसा है कि हम ऐसे क्वेश्चंस ले रहे हैं इसमें सारी टाइप कवर हो जाए, बस ये टारगेट है. प्रैक्टिस सेशन अलग से रहेगा. दिस सेशन इज जस्ट टू कवर ऑल द टाइप्स सो दैट दिस सेशन लुक्स लाइक ए कंप्लीट सेशन. Okay, Someshwar have given the answer as 20 plus 12, which is the correct answer. I am solving it, don't worry. A direct current welding machine with a linear power source characteristic, open circuit voltage of 80 volt, short circuit current of 800 ampere. Then during welding with the machine, the measured arc current is 500 ampere to an arc length of 5 mm. Arc current is 460 for 7 mm. You know that. Let us assume V is equals to A plus BL. You already know V is nothing but open circuit voltage minus open circuit voltage by short circuit current into I. So you can write A plus BL. A plus BL. Open circuit voltage is 80 volt. Short circuit current is 800 ampere into I. So you can see the equation will be coming out to be A plus BL is equals to 80 minus 0.1 I. They have given you two values of arc length corresponding to that two values of current. They are saying when arc length is 5 mm, current is 500. So you can say A plus 0.5 B. 80 minus 0.1 into 500. 50. Next equation is saying 7 mm 460. 7 mm 460. This was 5 mm. Okay. 0.5 नहीं 5 आएगा. A plus 7B. 80 minus 46. Solving these two, you will be getting A as 20, B as 2. So equation is 20 plus 12. Everybody understood the answer will be A for this? Everybody understood the answer will be A for this? Everybody understood the answer will be A for this? Everybody understood the answer will be A for this. Very good, guys. So moving further to the next question, guys. This is a very good question. A very wonderful question. Here, Sumit, your doubt will be dear, in these questions, they all are arc welding. Actually, resistance welding is having only one type of separate question where they are giving you that heat requirement calculation. Okay, that also we will do one question. In DC arc welding operation, the voltage arc length characteristics are, they have given V as 20 plus 5L. And they are saying that, okay, the arc length varies from 5 to 7 mm. So they are saying L is varying from 5 to 7 mm. And they are saying current is varying from 400 to 500 ampere. Current is varying from 400 to 500 ampere. But the point is they are not saying respectively. They have not used the word respectively. If they use respectively, we would be saying this length is for this current, this length is for this current. But we already know VI characteristic when we are taking linear is coming like this. So when voltage is more, current will be less. When voltage is less, current will be more. That is for sure. And you know, as 20 plus 5L, whenever we are going to have voltage arc length characteristic, length is more, voltage is more. So for more length, less current. For less length, more current. That is the case. So we would be having the equation once again. V is equals to, what is OCV we need to find out. Minus V naught by IS into I. Let us assume this to be X and this to be Y. So we can write V as X minus YI. And what is voltage? They have given it as 20 plus 5L. So 20 plus 5L X minus YI. Now you need to say when length is 5, current will be 500. When length is 7, current will be 400. When you will be putting these two values here, you would be getting guys, X is equals to 95 volt. Y will be coming out to be 0.1, which was V naught by IS. So short circuit current will be coming out to be 950 amperes. C would be the right answer. Is it clear, guys? Clear, guys? Neeraj, Abhi, Sumit, Shreyas. Okay, very good, guys. Very good. Shall we move ahead? अगले क्वेश्चन पर जाया जाए. Shall we move ahead? Very good, guys. Okay, this question I feel we have done. This is the same type of question. Okay, solve this one. Then we are moving to one good question of resistance welding and we will complete the questions here. This is a very good question. You can say 3V plus I is equals to 240. You can write here 3V, 240 minus I. V is 80 minus I by 3. Arey bhai, because if that efficiency is not given, it means efficiency is 100%. So when efficiency is 100%, what do you mean by that? Both are equal? Yes, they are theoretically possible. Exactly not possible. Very good, Faninder. So when you are having this equation, they are actually asking you DC power source arc welding. They are asking you voltage should be set as for maximum power. Okay, you know power is V into I. So you can have this 80I minus I square by 3. Put it, this is power. Then we will go for dP by di, which is 80 minus 2I by 3. When you will be equating it to 0, it will be coming out to be what? It will be coming out to be what? 3 is 240. 240 by 2 is 120. I will be 120. Put this value here. 120 by 3 is 40. 80 minus 40 is 40. B is the right answer. सभी को आया भाई? कुणाल, पनिंदर, ऋषभ, ऋत्विक, रावण, सुजीत, नीरज, सुमित, सोमेश्वर. Everybody got it? Everybody got it? So we have almost completed the welding. Yes, very good. Ha, in that way also you can do. Very good. Okay guys, these things are required for PSU exam and engineering services, the various forces in welding. If you want to study them, they are not required for GATE. But still, if you want to study them, many videos of mine are available where I have discussed, okay, these things. So if anybody wants, I can show you. And I am not also showing you some theory part which is of mugging up type, like the types of flux coating. Here, if I tell you, then also you need to mug up. They are required for GATE production industrial paper, not required for GATE mechanical paper. But in this PPT, it is there. If anybody is preparing for P&I and he want to do every theory, then these are given the types of flux coatings, the types of electrodes, all these things. From these questions are not coming much in GATE. So in the marathon, we cannot go for these things. These things are not coming in paper. They are for GATE P&I, like the ISO designation of electrode. But I have kept everything here for you, okay? So that if anybody wants to revise everything, so I will be saying that yes, they can go. So guys, with this, we have done these welding. Okay, I have not seen that resistance welding question here. I will add after the break, and that we will be doing here. Let us see soldering, brazing and braze welding and finish this. And after break, we will be starting with the casting then. Okay, so let's go for the soldering, brazing and braze welding. For that also, if you are going with one table, that will be covering everything. That will be covering everything. That will be covering everything. Where is that table? This is the table. Soldering, brazing and braze welding are said to be the allied processes. What is the speciality of that? In this, we are not going to heat the workpieces. We are going to heat the filler material only. Here, heat is not given to the workpieces. It is given only to the filler material. Well, I am not saying that even coatings are also coming. Flux coating also asked once in GATE paper. I am not saying they are not coming. Okay, if you want, I will cover defects I have. Don't worry. Casting and welding defect, I will tell you together. Don't worry. Defect I will teach you. Even I was thinking to teach you those flux coating and all, but I don't feel ki students will be interested in that, because those are the thing to mug up. Okay, so if you want to have that 100% security, you have to do that. Okay, but defects I will cover. Don't worry. Defects, casting plus welding, we will cover together. Don't worry about that. Okay, Surjit, defects I will cover. Okay, now we are talking about the allied processes. Here we are going to have soldering, brazing and braze welding. So my dear, whenever we are talking about soldering, brazing and braze welding, this entire table will help you in all the types of questions. And guys, whenever we are talking about mechanism, here it is adhesion, here it is adhesion, here it is adhesion. They are said to be adhesive processes. But my dear, whenever we are talking about the temperature limit from which gate questions was asked in 2016. So my dear, temperature is less than 427 degrees Celsius, maximum temperature in case of soldering. It is more than 427 degrees Celsius in brazing, and more than 427 degrees Celsius in braze welding. This is said to be brazing. And my dear, in this process, what we are doing, let us say you need to connect these two things. You need to connect these two things. Okay? If you want to connect these two things, what you will be doing? You are not going to heat them. You will be taking a third filler material, solder. You would be melting it, and that melting will be provided in between them like the Fevicol is provided, and then they will be joining with that. And as you are doing the same what you do with the Fevicol, we are calling it as adhesive processes. Adhesive is the mechanism for joining here. This is said to be allied process. No heating is done with the workpieces. When we are talking about the filler material, here it is solder, which is lead plus tin. Here it is brass, which is copper plus zinc. Here it is bronze, which is copper plus tin. Then my dear, whenever we are talking about joint preparations are not required here. Here it is required, here it is required. Because we are going to join thick plates in brazing and braze welding, thin in the soldering. Then my dear, we are going to have the flow filler material. It is done by capillary. Because my dear, between these two elements which we are going to join, we are going to provide a very small gap which is of size of hair. So that's why with the capillary action, the molten metal will be filled. Not molten metal, actually the filler material will be filled. So guys, that is why capillary action. But where we have welding kind of thing in braze welding, we are going to have gravity. It is clear. It is used for electrical and electrical circuits. It is used to repair the crack. Okay, it is used to prepare the cracks in the hydraulic circuits. Okay. So wherever fluid flowing is there, brazing is used in the hydraulic circuit. And my dear, it is used to join the tip of tool with the shank. Okay, like whenever we will be studying metal cutting. So in the metal cutting, you will be having the HSS shank. On this HSS shank, you would be joining the tip of carbide. And that tip of carbide will be joined with the braze welding. Okay, that tip is going to be joined like this. So this is just an example I am taking. Is it clear for everyone? Yes, Someshwar, you are correct. So guys, it is clear na? Surjit, it is fine na? Actually, I can cover all the theory parts. But in that case, timing will be more required. And that is not important because marathons are not meant for the complete syllabus. They are meant for the things which are to taught. रटने वाली चीज तो आप खुद ही कर लोगे ना. आप जैसे फिलर मटेरियल मैं बताऊं, फ्लक्स कोटिंग मैं बताऊं, ये सब चीजें मैं बताऊंगा भी तो आपको मजा थोड़ी आएगा. ये तो रटने वाली चीज है ना. तो उसमें मैं बताऊं या नहीं बताऊं बात बराबर. एंड दैट्स व्हाई आई एम शेयरिंग द नोट्स विद यू आल्सो. दोस नोट्स एंड दीस पीडीएफ्स आर हैविंग ऑल दैट डिटेल्स. If you want to read that, you can read it. Otherwise, for mechanical paper, whatever I am teaching, 99% chances questions will be from there. Marathons are never meant for 100%. They are meant for 90+%. Okay? I feel you are okay with that. So guys, with this, we have completed the welding. Now you suggest me, shall we go for the break, and after break, we will start the casting? Will it be okay? Will it be okay? We start the casting after break. Everybody, please tell me. And I want every one of you to come back after the break. If you want each and every topic to be done like that, I need everybody to be with me. This is a wonderful revision you can do with me. So guys, how much time you require? 2:30. We will meet 2:30 is fine. Shall we meet after? Okay. That's great. So guys, now we are having the break and we would be starting the casting at 2:30. So we would be starting the casting at 2:30 now. All the things we have covered in a nice manner. So defects I will be covering as you have requested for that. Okay. So we will be resuming the class at 2:30 p.m. guys. Be ready. and then we will be starting the metal casting that we will try to complete by 4:30 to 5, and then 1 hour would be required for sheet metal operations, 1 to 1.5 hours. We will be covering it by 6:30. So we will be resuming That's great, Sujit. Yes, guys. So we are starting within next 2-3 minutes. Don't worry. Let me share the session. Okay, guys. So are we ready? सभी लोग तैयार हैं? So once again, guys, share the session so that students gets to know that class is resumed again. Okay, then we are starting it. So guys, now we are going to start the second topic, that is metal casting. And metal casting is asked generally for 2 to 3 marks. For 2 to 3 marks in paper. Okay, it is coming for 2 to 3 marks in paper. Let us continue. Okay, fine. Surjit, I am showing you once again. If you want, I am telling you what is the case. Okay, I feel you have some doubt regarding the schedule, so I am telling you. Like when we would be having material science, metal forming will be with that. Tome session is separate. Okay, and whenever we are talking about vibrations, so vibrations is a separate topic. If on that day, tome day, if we would be having time, we will cover it there only. If we would not be having, then whenever you would be having the small marathon on some of the day, like when I will be teaching you material science, that day marathon would be over. It is not going to be very longer. So for such cases, we can have this 3-hour separate marathon for vibrations. But don't worry, I will be teaching that. That is for sure. Okay, I will be teaching that. That is for sure. Okay, so every subject will be covered. So don't worry about the subject. Okay, that we will be covering. Everything will be covered. And guys, don't worry. For all mechanical civil students, I am telling you, after 20th, we have already planned the mathematics and aptitude separately on this channel for you guys. Don't worry. It is going to be there. Okay. So don't worry about some other sessions because for you guys, as this marathons are going on, we will be planning. We have already planned maths aptitude schedule also. We'll be showing you by tomorrow. Okay. On the Telegram channel. Schedule is already done. You will see that schedule by tomorrow on my Telegram channel, on YouTube community post. Okay, everywhere. So let us continue, guys. Now we are talking about the metal casting process. So my dear, whenever we are going to talk about the metal casting process for the first time, that also you have seen in your college. Surjit, don't worry. If you will say I will make it as a 5 hours marathon, there is no problem. When I will teach you, you will never find it difficult, and this is my promise. Even from the marathon, if you are zero in vibration, you will be able to perform very nicely. You will be able to do more than 80% questions just with the marathon only. Okay, so don't worry about that. We will cover each and everything in a nice manner. When we are talking about metal casting, guys, then metal casting also for the first time you have seen in your college when you were entering into the very first year of BTech. and you were going there to the foundry lab. So when you went to the foundry lab, what you have seen there, you have made a mold in that, molten metal was kept and that was allowed to solidify. So metal casting is the very fundamental process, is the basic process, and it is also used for mass production. What is that process? In the metal casting, we are going to allow the solidification of molten metal. We are going to allow the solidification of molten metal in a predefined cavity. So first of all, we are making the cavity same as that of the shape of product you want. And then that cavity is going to be filled with the molten metal. Then molten metal will be allowed to solidify and the product will be ready. So I will be showing you one by one entire process of metal casting. So don't worry about that. Okay. So when we are talking about the metal casting process, generally it is including 10-step procedure. The very first step in metal casting is the preparation of pattern. Now what is pattern? Pattern is nothing but the replica of casting. When we are saying replica of casting, it means it is very much similar to the casting, not exactly same. It is similar to the casting. When it is similar to the casting, not same. It is similar to the casting, not same. Okay. I said it is similar to the casting, not same. Okay. So when I am saying it is similar to the casting, some allowances are provided. So it is similar, not same, means some allowances, means some size and shapes difference will be there. And my dear, then we are going to have the second thing as preparation of mold. Here mold means you would be making a cavity. So my dear, I am giving you a small example where I will tell you how the casting is going to be performed and what you have seen in the first year of college. First of all, my dear, I am showing you, let us say if you are going to have a product like this, you want to make a product like this. You want to make a product like this. Let us say you want to make a product like this. This type of product you want to make. This is the product. This is the size and shape of product you want. So first of all, you will be making a pattern of this size and shape. First of all, you will be making a pattern of this size and shape. This is going to be the pattern. This pattern can be made up of metal, plastic, rubber, all those types of materials. And my dear, now what you are going to do, you would be having a molding flask. That molding flask is something which is having the 4 walls, this and this, but there is no top, no bottom. It is a kind of 4 walls without top and bottom. Okay. So my dear, this is molding flask and we are going to keep this molding flask on a wooden board. This is a wooden board. This is a wooden board. And when you are putting it here, you would be putting now the pattern here. You would be putting now the pattern here. The pattern is this. You have kept the pattern here. Then my dear, there are some metallic pieces which are said to be ingates. We are putting the ingates here and here. Is it clear? Okay, I am going to make another example. Let us feel like that. If you are going to have this as the product, so this is going to be the pattern. Here I am going to provide this to be the ingates. And here you would be having a cylindrical element known as sprue. Then you are having another cylindrical element which is said to be riser. And then rest part in the mold is going to be filled. And that is going to be filled with the sand. Okay. That is what you have seen in the college. Whatever I am telling you is not the exact casting process. Here many steps are missing. I am just showing you this is how whenever you are putting it. Now from this area by inverting it, if you will take the pattern out, you will be getting a cavity. And when you will be taking this part out, you will be having a cavity. So from now this cavity, when you will be pouring the molten metal here, that molten metal will be filling this entire cavity part. And then you will allow it to solidify. Then after solidification, you will get the final product. I'm just giving you a rough idea what casting is because the fair idea I will be giving in the chapter. So my dear, fair idea you are going to learn now one by one in a very detailed manner. Generally in the paid courses, I tell this thing also in first 2 hours. First class, I just tell what you have seen in the lab. Here we will not waste time. Okay. let us move further. So my dear, these are the 10-step procedure. First one is preparation of pattern, other is preparation of mold. Third one is the gating system. Whatever I have shown you, sprue, ingates, they are the part of gating system. Then we will go for the design of riser. Then we will be melting the metal, because for pouring the metal you need to melt it from the furnace. Then you will be pour the molten metal, then you will allow it to solidify. After that you will break the mold, then the finishing process will be done with the casting. And guys, just give me a minute. Okay. Fine guys. So then we are going to have the testing. So this is the 10-step procedure. This is the 10-step procedure of casting. So when we are going to have this 10-step procedure for the casting, we will now see each and every step one by one. But I would like to also tell you that whenever you are saying this is a 10-step procedure, this is a conventional procedure. Like you would be knowing conventionally about your life when you were a child. You were studying, you were knowing that when I will be completing my studies, then I would be getting a job. Then my parents will allow me to go for marriage. After marriage, I would be making family. And then I will be living happily with my family. And then we'll do the same thing for my children that you will be having in the mind. That is convention going on in your family. And let us say every time your family is favoring the not love marriage, but arranged marriage, let us say. But my dear, this is the tradition going on. This is the convention going on in your family. But you said, I will be doing something different than tradition. And you are going for a love marriage. So whenever you are not following that tradition, that thing is said to be non-traditional. That thing is said to be non-conventional. Like some people are saying, in my family, every person was doing the business of this thing. But I am the only who studied, became engineer and doing the job. So that is a non-traditional thing, which was not done by the other family members previously. So similarly, if you are following this 10-step procedure, it is said to be conventional casting. And my dear, if any of these steps are going to be missed, like let us say you don't have a riser, let us say you don't have a gating system, any of the step. If any of the step is going to be missed, then the same process is given the name of non-traditional or non-conventional casting process. Okay, so this is how we are going to differentiate between conventional and non-conventional casting process. So guys, first of all, one by one we will see all these processes, all the types of question I would be telling you. And after this traditional machining, after this traditional casting, we will go for non-conventional casting. This chapter is not as lengthy as welding, not as boring as welding, because here we are going to have a very less amount of theory if we compare with the welding. Okay, so guys, just give me 2 minutes. Actually, Rakesh sir is there on the gate. Let me talk to him for 2 minutes. There is a small thing. Then I am coming back and we will be starting with the preparation of pattern. One by one, we will be covering all the steps. Okay. So don't worry. I will be completing casting in next 2 hours for sure. Just give me 2 minutes. Yes, guys. So sorry for the inconvenience. Actually, we were just planning for that clash only, which was happening. So let us start, guys. Let us move. So guys, now we are going to start with the preparation of pattern. First of all, we will be talking about what is the pattern. So my dear, you have already seen the pattern is going to be the replica of the casting product. And whenever we are talking about the molding flask, if you have never seen the molding flask, I can show you. This is how the molding flask is looking like. It is having no top, no bottom. And my dear, whenever we are going to have bigger casting, then my dear, we are going to have the 2 to 3 molding flasks to cover one part. And whenever we are going to have such thing, then my dear, top part is said to be cope, bottom part is said to be drag, and in between part is said to be cheek. Okay. And my dear, whenever we are going to have two, then we are having first part as cope, second as drag. So this is how we are going to name the molding flask. Okay. This is how we are going to give the name to the molding flask. And my dear, whenever we are talking about these boxes, they are used to make the mold actually for the conventional casting processes. Now my dear, whenever we are talking about the very first thing which I said, the pattern. So pattern, whenever we are saying is, it is nothing but the replica of casting. It is replica of casting, and that is with some allowances. When we are talking about the replica of casting with some allowances, so I would like to tell you guys, these allowances, whenever we are saying, is provided for various reasons. So we will see those reasons also, and we will see all these allowances also. When we say replica of casting with allowances, it is going to make the pattern similar to the casting but not same as the casting. So you will see casting and pattern would look like similar, but they will never be the exactly same. And when we are saying this casting plus allowance, these allowances we are going to study. There are 5 allowances. Number 1, we are going to see the shrinkage allowance. My dear, then we are going to see the draft allowance. Then we are going to see the machining allowance. Then we are going to see the, yes, distortion allowance. And at the last, we are going to see, my dear, the last allowance is going to be what? It is going to be wrapping allowance. So guys, खाना ज़्यादा तो नहीं खा लिया है, overeating तो नहीं कर लिए है, are you getting it or not? नींद तो नहीं आ रही है? So guys, these are going to be the 5 types of allowances. And guys, out of these, question is generally coming majorly from the shrinkage allowance. Shrinkage allowance is going to be important part. So if you have seen all the 10-step procedure here, numerical are coming from gating system and riser. For other parts, only theory questions are coming. So let us see one by one what are the things. Okay, let us see one by one what are the things. First of all, we would be having the shrinkage allowance. Let us see the reason for the shrinkage allowance. You know, whenever we are going to melt the metal, initially you would be having metal in the solid format. So that solid format is available at the room temperature. Then my dear, you would be heating it in the furnace. When you will heat it, it will be becoming from room temperature to melting point temperature. Then at melting point temperature, it will melt. Then after that, we are going to have some extra heating, which is said to be superheating. The point is, if at that point of temperature, we already get the molten metal, why we are going to provide this extra superheat? Because my dear, casting is going to be performed at this place. Furnace is present at this place. So when the molten metal will be coming from furnace to the cavity, there are chances that in the path, heat losses will happen. And if heat losses will be happening, in place of this point, you can reach to this point. And if you will be reaching to this point here, you will be having some solid plus liquid. Because of that, defective casting will be produced. So to avoid that error, to improve the fluidity of molten metal, we are going to heat up to this. And this extra temperature what we are providing is said to be degree of superheat. This extra is said to be degree of superheat. This extra is said to be degree of superheat. And this is generally 100 to 150 degrees Celsius. So generally that much extra temperature is provided. 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 Okay, so my dear, whenever we are talking about this, now finally what we have actually, finally we have metal at pouring temperature. Finally, we have molten metal at pouring temperature. Pouring temperature is more than the melting point temperature. Now, my dear, at this temperature, what we are going to do? As we are going to pour this molten metal into the cavity here. Now, my dear, it will start cooling down. Where it will be cooling down, it would be cooling to the melting point temperature. Then it will be going to solidify. Then it will be going to the room temperature. So this is said to be heating and cooling curve. But many of you would be thinking, sir, why you are telling all this here? The point is, my dear, you have studied from your childhood that whenever we are going to heat a component, then it is getting expanded. And whenever we are going to cool it, it is getting contracted. Heating results into expansion, cooling results into contraction. Heating results into expansion and cooling results into contraction. So when we are going to heat here, some expansion happen. We are going to heat here, some expansion happen. We are going to heat here, some expansion happen. So my dear, just imagine if we are having this much cavity. If we are having this much cavity, if you are going to make this type of product, you are having this much cavity. And here some ingates are there. Here we are going to have sprue and here we are going to have riser. You know, molten metal will be coming from here. When molten metal will be coming from here, it will be filling the cavity like this, like this, like this. So my dear, you know that when the cooling will be happening from pouring temperature to the melting point temperature, this is said to be liquid state. Here metal is present in the liquid format. So my dear, at that time, you know that shrinkage will happen, because whenever you cool something, shrinkage will be happening, contraction will be happening. So whatever the volume covered by the molten metal, if previously this was the volume covered by the metal, now the volume covered will be getting reduced to the new volume like this. But my dear, at that time we are going to have riser here. So this riser will be pushing the molten metal here to fill the cavity again. So that is why whatever contraction is happening in this stage, that is said to be liquid shrinkage, for that riser will compensate. And once again the cavity will be filled whatever it was initially. Then my dear, once again the cavity is getting the same size. Why? Because riser have given the shortage of molten metal. Then my dear, second stage cooling will happen. That is nothing but solidification will be happening. That solidification, we call it as solidification shrinkage. And once again the size will be getting reduced to this green one. And once again riser is designed in such a way that it is going to solidify at the last. So riser will once again provide the molten metal and once again fill the cavity. So for first stage of shrinkage, we don't have any problem. For second stage of shrinkage, we don't have any problem. Because for these two stages, our riser is helping. For these two stages, our riser is helping. Riser is compensating the molten metal. But my dear, whatever shrinkage will be happening in the third stage, that cannot be compensated by the riser. The third stage shrinkage cannot be compensated by the riser, because after this riser will also start solidifying. Now the riser will get solidified. Now in the third stage, when you are reaching to room temperature, some solid shrinkage will happen. This time, my dear, whatever shrinkage will happen, for that riser is not there. Up to that point, previously riser was saying, "Main hu na." But now riser is saying, "I am not there. Take care of yourself." So this time, my dear, if shrinkage will be happening, you can see this much part will be empty. For this much part, we will not be having the molten metal for this shrinkage. Everything is solidified now. So for that shrinkage, we need to provide the shrinkage allowance. What is shrinkage allowance? As we know, the size is going to get shrink. Like whenever you are going to purchase the clothes of winter, if you know that this is going to get shrink, you are always taking one size bigger, because you know after shrinkage it will reach to this size. Are we doing this or not? So my dear, that's why I am saying here we are going to provide the extra size. For that you should know that, first of all, you should know that for this stage only the shrinkage allowance is provided. For other two stages we have riser. So always remember, these two stages are compensated by the riser. Only for the third stage, we require the shrinkage allowance. Clear for everyone? Clear for everyone? Now, my dear, I would like to tell you shrinkage is always provided on the linear dimensions. Like let us say someone is saying ki 2 mm per 100 mm is the shrinkage allowance. Then let us say you want to make a part of this size. Just feel it. This is 100, 200, 150. If you want this, you would be making a pattern of which size? Can you tell me what would be the size of pattern? If this is the casting I want, what should be the size of pattern? Can you tell me, guys? Can you tell me, guys? Can you tell me, guys? Yes, if this is 100, for every 100 mm, 2 mm is the shrinkage. So don't you feel it should be of 102? Don't you feel it should be of 204? Don't you feel it should be of 153? बोलो यार, कुछ तो बोलो. Everybody. Tell me, everyone. Very good, very good, very good. So I feel everybody, Darshan, wonderful, guys. Keep answering, guys. Keep answering. Very good. Very good, guys. I just want to place the charger for my mobile. Just wait. Fine, guys. So everybody have given the right answer. This is said to be the shrinkage allowance. Then, my dear, whenever we have seen the shrinkage allowance, I would like to tell you here one more thing. There is a table for shrinkage allowance. Bismuth is having negligible allowance. White metal is having 5 mm per meter. Cast iron is having 9 to 10 mm per meter. Copper is having 11 mm per meter. Aluminium is having 13 mm per meter. Steel is having 20 to 35 because with the impurity, the value is changing. Manganese steel, whenever we are talking about, is having the highest one. Okay, that is 35 mm. 35 mm. Then you have brass 23, zinc 24. So this is how the values are varying. You need not to worry about that. You need not to remember these values. And I would like to tell you that there is one more material, Invar, that is also having near to zero. Very less shrinkage allowance is required. Okay. Yes. So guys, this is something about the shrinkage. And I would also like to tell you that whenever we are talking about grey cast iron, it is always said that grey cast iron is an exception. So I am telling you, if I am having a pattern, let us say the same pattern is there. Let us take the same pattern is there. Now you tell me, if I say for the same that this, let us say the casting is going to be the grey cast iron. Okay, let us say we are going to have the pattern of grey cast iron. Tell me, the answer will remain same or the answer will change? If the material is becoming grey cast iron, the answer will be same or answer will be changing. Very good, Faninder. If I am saying we are going to make the casting of grey cast iron, I am asking you whether the answer will remain or answer will be changing. Answer will remain same or answer will be changing. Please tell me that. Yes, Faninder, Ravan King, Rutvik, Abhi, Kunal, Surjit, Ashray, Darshan, Ajay. Okay, Faninder saying changing. What about others? What about others? चेंज होगा. सोच समझ कर बोलिए, चेंज होगा. So my dear, I would like to tell you, yes, grey cast iron is having different nature. But you need to understand what is that different nature. My dear, I am telling you one thing. You have studied this as the cooling curve. Grey cast iron is having different behavior. What is that? All other material are expanding on heating, contracting on cooling. Grey cast iron shows reverse behavior. It expands on cooling, but only in this stage. Only in this stage, grey cast iron will expand because of the graphite flakes. But you tell me, You tell me, you were providing shrinkage allowance for second stage or third stage? You were providing shrinkage allowance for this stage or this stage? You are providing shrinkage allowance for this stage or this stage? For second stage or third stage? I'm telling you, at many places this is taught wrong. You can check GATE 2 times I have asked this question. And what they have given, the answer is matching with my concept, which is the correct one. So don't get affected by the wrong information. So you know that as grey cast iron, we are going to have that change or different behavior in the second stage. But in the third stage, it has the same behavior. And you know, first two stages have nothing to do with allowance. First two stages are nothing to do with allowance. It is related to riser. So what happened is, in this stage, whatever contraction will happen, the same expansion is happening in this phase. So when we are using grey cast iron, then the need of riser is not there. But shrinkage allowance will remain as it is. Answer will also remain as it is. There is no difference in the answer. Clear for everyone? Faninder, you got it? This is a doubt with many of the students, I know that. But you can see in the 2016, in 2008, questions have been already asked by the GATE. And every time they have taken the same way. They have never given the opposite way. Okay? Understood Shreyas? Understood Kunal? Understood Ronaldo? Surjit? Darshan? Ravan? Ajay? Vinay? Yes. Wonderful, guys. Okay, no issue, Sumit. कोई बात नहीं. हाँ, grey cast iron is the only exception. Okay, grey cast iron is only exception. It is always exception. Even during welding, it is easily welded by the carburizing flame of gas welding. Generally, for other processes, also it is facing difficulty to weld also. Grey cast iron is having exceptional behavior every time, everywhere. Yes, very good, Dangi. Moving further, guys. Moving further. So we talked about this. Okay. We have discussed about the stages, different stages also. And when we are talking about these materials, now there are some important note points. You can see liquid and solidification shrinkage are maximum for aluminium, but total is maximum for steel. Then you can see in case of grey cast iron, due to conversion of carbon into graphite flakes, there is a possibility of expansion of the material, but there is no requirement of riser when casting is done for cast iron. So riser requirement is getting restricted, but all other things are going to remain same. There is no change. Yes, Ashray, already 2 times they have asked the ratio of volume of pattern to the volume of casting. How they are asking? They are asking find out the volume of pattern to the volume of casting. That kind of questions are coming. I already told you. Moving to the second type of allowance is draft or taper allowance. So my dear, whenever we are talking about draft or taper allowance, if you are having a workpiece here, just imagine if you are having a workpiece here. So my dear, when you would be taking this workpiece out, you know that there will be wall hindrance, friction will be present throughout the walls. And when the friction will be happening, when the pattern will be taken out, you should be knowing that because of this friction, there are chances that some sand will be eroded from the mold, because all around we have sand cavity only. So my dear, if any sand erosion will be happening, then it is going to create a problem, because if any particle of sand is going to break from here and will become the part of casting here, then my dear, the problem is this sand particle is having Na2SiO3 because it is silica sand. And if it will be reacting with iron, it may convert into Fe2SiO3, which is said to be phthalate. It is a very, very hard and brittle material, and if it will be the part of workpiece, when you will be going for machining of this casting product, because casting never give you good surface finish. So to remove the first layer, which is rough one, you need to go for machining. And when you are going for that, this phaelite pocket are so hard and brittle that they can break the cutting tool by providing the impact loading. So that is why that kind of thing we should not do. We should avoid it. So that is why we don't want that erosion to happen. So for that, what we are going to do, we are going to make our pattern like this. And when we are making the pattern like this, we are going to provide a draft. And whatever the draft you are providing, this angle is lying between half to 2 degrees. What is the benefit of that? When you are providing like that, let us say we are going to have this as cavity. And we are going to have the pattern to be like this. So this time now, if you are going to take the pattern up by just a small differential amount, if the pattern will be going up just by the differential amount, let us say this much, entire contact will be loosened of the pattern with the molding sand. Okay, and if this will be happening, my dear, obviously now there is no contact, so there is no such friction happening. So half to 2 degree draft is provided to the pattern, and that is said to be nothing but the draft allowance. Moving to the third thing is machining allowance. As I already told you, when molten metal will be coming in contact, like molten metal is coming in contact with the sand. You know, sand is like khurdura. If you are going to touch the sand surface, it is not going to be plain surface. It would be having very rough surface. So when you are pouring the molten metal here, it will also solidify with the rough surface. So when you will be taking this casting product out, this casting product will be having the rough surface like this. So my dear, if that is having this rough surface, this is not acceptable. So we always need to remove these roughnesses and we need to make the good surface. So for that we will be going for machining this much, machining this much, machining this much, machining this much. And finally you would be getting this product. So once again some part is getting removed. So that is why for that purpose we need to always prepare bigger size of pattern, so that after removal of this rough surface, we would be getting the exact sizes which is required. So for machining allowance also we need to keep the pattern size to be bigger than the casting required. Is it clear, Sumit? It is clear, Surjit? Everybody, Dangi, Rutvik, Ajay, Darshan, Kunal, everybody is clear for this or not? Please tell me that. Is it clear for everyone? So guys, this is said to be the machining allowance. Okay, and machining allowance is provided as per side. Like let us say if this was the product after removal of material. So you have removed some material from here, some material from here. You have removed some material from here and some material from here. That's why it is given as like 2 mm per side. So 2 mm is removed from here, 2 mm is removed from here. 2 is removed from here, 2 is removed from here. So if previously you are saying that you want a size of 100 mm, so for machining allowance, you would be providing it to be 104 mm. This I am just telling because of machining. For shrinkage allowance, further considerations are required. So likewise, you can see for machining allowance also pattern should be bigger than casting. For draft allowance also it should be bigger than casting. For shrinkage allowance also it should be bigger than casting. So till now what we have seen that pattern size should be bigger than the casting size. Is it clear for everyone? Sumit, Vinay, Rutvik, Anush, Sujit, Ajay, Ravan, Darshan, Kunal, Sumit. Everybody is clear? Moving further, guys. This is the next type of allowance. We are calling it as draft or distortion or camber allowance. So my dear, whenever you are going to make a U shape, this type of critical shapes you are going to make, then my dear, you can see if this is length L1, this is length L2. So my dear, you know delta L is always given as L alpha delta T. Delta L is given as L alpha delta T. So from this you can see that delta L is directly proportional to L. है ना? So if you are going to say this L1 is bigger than L2, if L1 is bigger than L2, don't you feel delta L1 will be bigger than delta L2? Is it clear for everyone? delta L1 is bigger than delta L2. So if guys, this delta L1 is bigger than delta L2, if this delta L1 is bigger than delta L2, so my dear, because of that, what will happen? It is going to bend. It is going to bend. So this would be the final shape of the product, which is not acceptable. We wanted U shape, we are getting this shape. So for that, what we are doing, we are going to provide the reverse direction distortion, so that after this expansion, it will take the exact U shape. So this type of allowance is provided only for the critical shapes like U, V, H and that kind of thing. So that is why, my dear, we are calling it as distortion or camber allowance. Okay, it is going, and you may be thinking, sir, how do we know how much to be bent? This from the experience that person would be knowing, those who are doing this for large number of years. Next, we are going to have shaping or wrapping or shake allowance. So my dear, when you are going to keep the pattern inside the cavity, you need to remove the pattern as well. So my dear, first of all, when you have made the pattern, you have made the cavity. So you would be knowing that. So you would be knowing that. You would be knowing that. Like this is the cavity initially. So actually this is the pattern. Right now it is not cavity, it is the pattern present. So when you will be removing the pattern, for that what we are going to do? For removing the pattern, first we need to make the space. So we are going to apply some pressure onto the pattern. So when we are going to apply some pressure onto the pattern, because of that what will happen? Because of that, sand will be making some distance from the pattern. Sand will be making some distance from the pattern. So we are taking a hammer of wood, and by hammering on this gap will be coming. And now my dear, because of this gap, the cavity size is this much bigger than the pattern size automatically. And that we are doing just to remove the pattern easily. So that is why we are calling it as shaping or wrapping or shake allowance. And my dear, that is also increasing the size of pattern. So we have seen all the types of allowance. Here I would like to say that if you want to write down the pattern size, you would be saying casting size plus shrinkage allowance plus draft allowance plus distortion allowance plus machining allowance plus wrapping allowance. But if you see all these allowance, there is only one allowance which is of negative nature, this wrapping allowance. Because wrapping allowance is going to increase the size of cavity, and size of cavity will be more than the size of pattern. So this is the only allowance which is said to be negative allowance. This is reducing the size of pattern, because we know cavity size is going to be more than the pattern size. Please tell me everybody is clear on this or not. Please tell me everybody is clear on this or not. Please tell me everybody is clear on this or not. Yes, tell me. Yes. Clear? Yes. So guys, this is about the types of allowance. Now we are moving further to the pattern material. First part is going to be over very soon. So when we are talking about this pattern material, we can use wood, we can use metal, we can use plastic, wax and rubber. What are the advantages, disadvantages? When we are talking about wood, is going to be better because we can do any kind of operation on that. It is easy to cut. Any kind of shape can be given. High carbon steel is very easily cutting the wood. So we don't require any extra hard materials to cut the wood. So guys, wood is lighter in weight. That is also an advantage. And I would like to tell you the master pattern is made up of wood only. Master pattern is made up of wood only. Okay, master pattern is made up of wood only. Is it clear? So master pattern is made up of wood only. Then my dear, whenever we are talking about the metal, the problem with the wood, that's why we are reaching to the metal. Wood is having one problem, that it is going to be susceptible to moisture. You must have seen many times your doors are getting swallow because of the rain, and then when you are going to close them, they are extending that much, it is very difficult to close. Even in the summer winter days this happen because of the temperature changes, that they are going to show this kind of behavior. But generally the swallowness because of water is a dangerous thing. So we don't want that our pattern will be swallow getting the water inside. So that is why, my dear, wood material, whenever we are talking about, we are going for the master pattern, but always there is a problem of swallowing. So for that there is a compromise. We are going for the metals. In the metal there are something good, that their strength is good, they are not susceptible to moisture. But there are some bad thing, that their weight is more, they are heavier. So whenever they are heavier, pattern is bigger in size, they can also deform the sand and change the size of cavity elastically for some time. So that is why metal is not going to be good always, because corrosion is also a very big problem with that. So for that purpose, my dear, we are having a compromise as aluminium. Aluminium can also be used because it is light in weight also, and it is not having any susceptible to moistureness or corrosion. So they are the advantage with the aluminium. Or you can do one more thing, the wood pattern can also be painted, and when you are going to paint the wood particle, they will not be taking the swallowing again. So that is also one more way to go. And my dear, next material is plastic. Plastic is light in weight, we can use it very nicely, but the problem is it is dimensionally unstable at higher temperature. If temperature will be more, plastic is going to expand, you know that. It is going to be difficult to use then. Wax, my dear, is used in the special casting process known as investment casting, and we are going to use this only if we want excellent surface finish. Okay, if we want excellent surface finish. And last one, when we are talking about the rubber, so my dear, rubber is also light in weight. Okay, but the problem with the rubber is elastic deformation. Like if you are keeping a pattern like this, because of the sand, my dear, when you are going to put the sand, because we are going to use the hammer to put the sand over the pattern. So because of that, because of the weight of sand and other purposes, there are chances that some elastic deformation is going to happen on the rubber pattern, and cavity would be shrink by that. And when you will be removing the pattern will take once again the original shape. So that is the problem with the rubber, and that phenomena is said to be the bulging phenomena. The problem with the bulging, if the big size pattern you will be making for the rubber, generally it is going to get hang like that. है ना, रबर का बहुत बड़ा पैटर्न लोगे तो ऐसे लटक जाएगा. So that is also a problem. So that is why out of these, every pattern material is having some good points, some bad points. So based on the requirement, we are going with that material particularly. But let us say if you want to make the pattern of metal, then that is also made by casting. You take the master pattern of wood, then you are making the pattern of metal, then you are making the casting of metal. So my dear, one time you are providing shrinkage allowance here, then you are providing shrinkage allowance here. So this is said to be the concept of double shrinkage allowance. So when you are making the wood master pattern and final product of metal, we are going to provide 2 times the shrinkage allowance. That's why it is said to be the concept of double shrinkage allowance. So guys, please tell me, is it clear for everyone or not? Please tell me guys, is it clear for everyone or not? Clear for everyone or not? Please tell me that. Clear for everyone or not? Please tell me that. Yes. Yes. Sorry guys for the disturbance. Now I have made the phone switched off. Okay. But actually they were important for you guys only. Okay. That's why I went there. Is it clear guys? Pattern is clear for everyone? Pattern is clear for everyone? Pattern is clear for everyone? Moving further guys. So we have completed one step, that the preparation of pattern is over. Now we are moving to the second step, that is the preparation of sand, preparation of mold. So my dear, when we are talking about preparation of mold, when we are talking about the preparation of mold, first of all, I would like to tell you, whenever we are talking about the preparation of mold, while making the mold, many theory questions are going to be framed from that, and they are coming in 1 mark. In 2011 one question came, 17 one question came. So in 3-4 year one question is coming from this part in the theory, and just after this numerical part will start. So just be ready. We are going to enter into wonderful thing, that what is the preparation of mold. So I already told you that we are going to take a wooden board like this. This is the wooden board. लकड़ी का बोर्ड होता है ये, और इस वुडन बोर्ड के ऊपर माय डियर वी आर गोइंग टू हैव ए मोल्डिंग फ्लास्क. दिस इज द मोल्डिंग फ्लास्क. दिस इज द मोल्डिंग फ्लास्क. You know what is molding flask? Free from top, free from bottom, that is the molding flask. And my dear, in this now we are going to put the pattern. In this now we are going to put the pattern. In this now we are going to put the pattern like this. This is the pattern. Now my dear, till this point I already told you, now the new things are going to come into the picture, which you may not have seen in the laboratory in the first year. So my dear, after putting the pattern, what we are doing the first step? Yes, initially we would be putting the ingates, and the reason for ingates we will be discussing in the third step, because it is going to be the part of gating system. After that, my dear, you are going to take a special type of sand, which we are going to say as the facing sand. Facing sand are the carbonaceous material in which you would be having either coal dust or wooden floor. कोयले का powder या लकड़ी का बुरादा. You would be taking that in the powder form, and you would be putting that onto the pattern like this. And my dear, whenever we are going to put it like this, you will be just sprinkling over it. It will help us to avoid the sticking of pattern and sand. So that is why we are providing this, and this sand is said to be the facing sand. And now my dear, after putting this facing sand, we are going to put something called as baking sand. This baking sand is making the back part of the pattern. And my dear, this is reused sand again and again. So my dear, whatever we are providing this as, this is just to fill the part of this mold completely. And my dear, we are going to hammer it with the wood so that this sand will tightly take the shape of the pattern and the cavity is getting produced. And this is reused sand, because every casting is using the same sand again and again. But my dear, you may be thinking, sir, whether we can use the facing sand again or not. No. Because when the molten metal is coming into the cavity, at that time, my dear, this facing sand is going to get burnt. Jal jati hai, gas ban jati hai. So my dear, that is why only one thing which is used to be used again and again in every casting, that is nothing but this reused baking sand. We also call it as molding sand. And my dear, whenever we are talking about parting sand, it is used if your casting is in two parts. Let us say your casting is big in size and you are going to make a product like this. This is one part. This is another part. In that case, you are also having the pattern in two parts. So one part of the pattern was here, which you have put it here. For the second part of the pattern, a new cavity will be produced. For the second part of the pattern, a new cavity would be produced. Let us say once again, you are going to put this pattern part like this. Here is the ingate, here is the ingate. Then you would be having, here is the riser, here would be the sprue, here would be the riser. And rest part once again will be filled with the molding sand. Now you have made these two molding flasks. One is top, other is bottom. Now, my dear, if you see, those two parts will be combined with each other. How they will be combined with each other, I am showing you. So I am going to have one part of the flask this much. Second part of the flask is this much. And you are going to have, my dear, this as the first part, this as the second part. And as you are going to have ingot here, ingot here, ingot here, ingot here. This is the sprue, this is the riser. Molten metal will be coming from here. So, my dear, whenever you are going to join these two flasks like that, then this line is said to be the parting line, which is dividing it into two parts. And my dear, whenever you are going to put one flask over the other, we don't want those two molds to stick with each other. So in between, once again, we are sprinkling a special type of sand, which is said to be nothing but the parting sand. So parting sand is sprinkled to avoid the sticking of these two molds, these two molding flasks. Okay, so my dear, then these three things we have discussed. We got it. Yes, it's fine. Now, my dear, these three things you may have seen also in the laboratory. But the fourth thing is not shown in the lab. This is something advanced way. What we are going to do. Now, my dear, whenever this cavity is getting formed, how this cavity will be forming? When you will be removing these pattern from here, removing this pattern from here, then only the cavity will be produced. So when the cavity is getting produced, you are going to have a paint or a paste which is made up of the wooden floor, lakdi ka burada, in alcohol so that wo mast rahe, or in water. So when you are putting that lakdi ka burada, wooden floor, inside the water or alcohol, it is becoming a paste. That paste is applied on the periphery of the cavity. And when we are going to provide that paste on the periphery of the cavity, why we are doing that? Because my dear, whenever the molten metal is coming, the problem is molten metal is coming in contact with the mold. And you know, there are three stages of shrinkage. In first two stages, okay, riser will compensate. But when the solidification will be happening in the second stage, molten metal will be provided by riser. There is no problem. But when this will try to shrink, don't you feel that this mold wall will be creating the resistance? They are in contact and it is trying to shrink. So this mold wall will be creating the resistance. And if you are going to allow this, my dear, you will be getting cracks over the casting surface. And if you don't want that crack, my dear, we are providing the mold wash. Because when the molten metal is coming, this mold wash is getting burned and become the gases which provide the gap between the molding sand and the molten metal. And when the shrinkage is going to happen because of solidification, there is no resistance from the wall, because the gas layer is going to save that problem. And that is the use of mold wash. So whether it is mold wash, facing sand, parting sand, whatever comes with the contact of molten metal is getting burnt out in the form of gases. And as it is in the molding flask, these molding sand are going to help them, those gases, to go outside. So whatever the gases will be produced at the pouring of molten metal, those gases will be going out from the mold, from the molding sand, because there are some pores available. So those gases will not remain in the casting, they will go away. Till this point, please tell me, guys, everybody is clear? I am going to tell you each and everything in detail. That's why it is taking time. Then we are talking about the types of mold. The very first type of mold is green sand mold. This is the composition of green sand mold. 60 to 80% silica sand, 20% clay, 6 to 8% water, 0 to 1% additives. Additives are added to improve the properties. Then, my dear, this is used for the small casting. Why? Because, my dear, because of high water content, its strength is going to be very, very less. And where water is present, we are calling the strength of such part as green strength. So the strength of this mold is said to be green strength. And in GATE 2011, they have asked what this green indicates. The green indicates the water content, the moisture content. Okay, so this is the green sand mold. And my dear, next sand mold is said to be the dry sand mold. Whenever you are going to take the green sand mold, put it into the oven for 8 to 48 hours and heat there for 150 to 350 degrees Celsius temperature. This temperature, this much hours. The water vapors are going out of that. And when water vapors are going out of that, the strength will increase. And then we call the strength of such mold as dry strength. And the mold is said to be dry sand mold. This is used for large size castings. But cycle time is more because 8 to 48 hours are used just for the solidification. Then my dear, don't worry, in gating system riser, we will not go for derivation. Direct results will be there. When we are talking about the types of mold, the third type of molding sand is loam sand mold. And loam sand mold is used, my dear, for the cast iron. And here we are using 50% silica sand, 50% silt clay. 50% silica sand, 50% silt clay. This is loam sand mold. And the last one is CO2 molding. Whenever we are going to make the core is always having a problem of buoyancy forces. Like let us say you want to make a hollow cylindrical part like this. If you want to make the hollow cylindrical part like this, then my dear, you would be making a cavity like this. You would be making a cavity like this. Let us say this is the cavity mold I am making. So I would be having this is the entire cylinder. In between you want the hole. So here we would be placing the core like this. This is the core. And this core will be sitting on a seat. And that seat is said to be the core print. Tere Nishan. Okay. Now my dear, you would be having something sprue here and something riser here. Now when the molten metal will be coming inside, then my dear, this molten metal will be applying the force onto the core. This molten metal will be applying the force onto the core. Why? Buoyancy force. And because of this force, there is a tendency that core will get break. So that is why we need to make the core in such a way that core should have more strength. So for that purpose, what we do, we are going to pass, like Na2SiO3 is the silica sand, we are passing carbon dioxide from that and we get sodium carbonate. It is a very, very hard part. And that is why core are made by this. So cores are made by this. By passing carbon dioxide, we are increasing the strength, and in that way we can avoid the failure. Everybody understood all the types of mold. We are going for the properties of molding sand now. From here, numerical is starting. And numerical will continue till riser. And once riser is over, 90% chapter is over. It will not take much time now. Everything is there in the slides. Don't worry. So guys, we are moving further now to the first property, that is said to be permeability. So when we are talking about the permeability, you already know mold wash, facing sand. Whenever you are having mold wash, facing sand, they all are getting burnt and convert into gases. Now to remove of these gases, because if gases will remain inside, they will be creating the cavities in the casting, which will be nothing but the defect of casting. And we never want our casting to be defective. We never want our casting to be defective casting. So my dear, if you don't want your casting to be defective, you need to take this gas out. So my dear, the ability to take those gases out from the cavity is said to be permeability. And my dear, it is found that this permeability is found to be the function of percentage of water content. And my dear, when we make the curve, it is found to be maximum at 8% of water content. So permeability will be maximum at 8% of water content. If you are having less than 8%, permeability is poor. More than 8%, permeability is poor. When it is more than 8%, water is more. That's why it is not capable of removing the water. Pores will not be present. Actually, when the gases are going away from the moulding sand, they are going away because some pores are present. And we are going to create the pores when molten metal will be coming by taking heat. The water present in the sand is also getting evaporated. By that, the gaps will be produced. So when we are talking about less than 8%, it is less because clay is not becoming active. Like we are having this as 4 particles of sand. In between you would be having the clay. Clay is not activated. And my dear, if you are going to have exactly 8% water content, then between these 4 sand particles, our clay particles are activative and they are having all around water. And the water is getting vaporized, so the gap will be becoming present for removal of the gases. That is why at 8% it is going to be maximum. After 8% water is more, it is difficult to evaporate. So this is experimental curve, we found it. Now my dear, when we are talking about permeability, there is a numerical comes from the permeability number. So my dear, what is permeability number? Permeability number is defined as VH delta P A T. This is the very first formula from the casting where the questions are coming. When we are talking about the permeability number, actually we are going to take a cylindrical specimen. This is the specimen, cylindrical specimen of the same sand for which the mold is going to be produced. Now my dear, we are going to allow some volume of air to pass. We are going to provide some volume of air to pass from this. And when this volume of air is going to pass from this, it will be taking some time. And for that, there should be some pressure difference also. So my dear, here V is the volume of air which is going to pass. A is the area of this mold. H is the height of this mold. Delta P is the pressure difference between these two ends. And T is the time required to pass by the air this cavity, this mold. So my dear, if permeability number is more, permeability will be less. No, permeability will be more. And my dear, permeability has what function? If the air is going to pass fastly, it means permeability is good. So we want the air to pass fast. So my dear, if time required to pass is less, permeability number is bigger, permeability will be bigger. And if permeability is poor, then what we will do? We are going to have some vent pins. And with those vent pins, we are making the hole in the mold. Everybody would be knowing that. Am I correct? You must have done this in the college because you were not using mold wash, all those things. But you were doing the vent pin holes so that we can produce the holes for gases to flow outside. Am I correct, Sumit? Am I correct, Raman King? Am I correct, Vinay? So this is what we have done. Clear, guys? And I would like to tell you that this diameter and height you should remember. Sometime it is not given in the question. This is 5.08 centimeter. And I am telling you the units of volume is centimeter cube. Units of height is centimeter. Time is in minutes. Area is in centimeter square and pressure is in the gram per centimeter square. This is the empirical type of relation coming from the test. So you need to remember the units. Put the values in the same units. Clear, guys? Wonderful. बहुत बढ़िया. So guys, this was the permeability test. This is a question for you. Try to solve this question for permeability number. 2000 centimeter cube of air takes 1.5 minutes to pass through a standard specimen which is 5.08 centimeter and diameter and height are equal. Pressure difference is 5 gram per centimeter square. Find out the permeability number. Very good, Rishabh, Kunal, Sujit, Vinay, Ravan, Abhi, Ashray, Shreyas. Faninder is saying 66.83. Very good, Faninder. So when we are going to find out the permeability number, you know the formula is volume 2000, height 5.08, delta P 5, time is 1.5, area is pi by 4 into 5.08 ka square. So answer will be coming out to be 66.67. That is correct. Permeability number is correct. Very good, guys. Next property is collapsibility. We have just seen you are providing the mold wash, and because of yes, Vinay, the answer is correct. Very good. I feel everybody understood. Is it clear now, or shall I show you the question again? Everybody got the answer? Everybody got the answer? Theory part is now covered. We are going to have numerical parts. Everybody is clear? Yes. 66.7, 68. That is correct. Fine. Very good, Ravan King, Ashray. Moving, guys. So collapsibility we have just seen now. Whenever we are providing the molding wash, the gas was providing a gap between molten metal and molding sand. Because of that, cracks were not coming on the surface. That property is said to be collapsibility. So that property is said to be collapsibility. Okay, so that we have already discussed. Then, my dear, next is flowability. So, my dear, you know that whenever you were having the cavity, whenever you were putting the pattern, on this pattern you need to fill the sand, and you wanted the sand to take the shape of pattern. So, my dear, when you are going to provide the force onto the sand, sand should take the shape of the pattern. That is possible if sand can easily flow on applying the pressure. And that property is said to be flowability. So, flowability is the property of molding sand by which it can easily flow over the pattern. Surjit, actually, this is not a physical quantity which we are defining. It is an empirical relation. So, you can see it is not coming, I feel, dimensionless. Dimensions we are measuring for the theoretically calculated formulas. For empirical relation, we don't do this analysis. Then, my dear, we are talking about refractoriness. As you know, molten metal is coming at a very high temperature. So, as it is coming at high temperature, molding sand should be in a position to remain solid at that high temperature. That property is said to be refractoriness. Then, my dear, we are having one question on the shrinkage allowance. This is also a previous year gate question. Let us see how many of you give the right answer for this. And then we are entering into the gating system design and riser design, the most important part. Next 40-45 minutes, we will be doing that. Okay, so by 5 to 5:15, we will complete casting. Don't worry. Clear, guys, for everyone? Please tell me that. Yes. The answer for this will be 7%. Answer for this will be 7%. Because when you are going to say this, these two are compensated by the riser. 3% and 4%. Answer will be 7%. Very good, guys. बहुत ही बढ़िया. Yes. So, guys, moving to the third point, the gating system. And my dear, I am going to tell you wonderful things in the gating system, as we are not going the derivation. But I will show you a gating system where I will tell you all the related points from where the questions can come. You should know everything about the gating system. It is a very big and important thing for us. So I am making a cavity like this. I am making a cavity like this to just explain you the gating system. And my dear, we are going to have, first of all, this type of figure. Okay, guys, just look at it very nicely. It is a very, very important topic, and from here numericals are coming. So you need to understand how to do, what to do. So my dear, whenever we are pouring the molten metal is coming in a ladle. Ladle is a container in which you are having the molten metal, like you take milk in some of the container. So molten metal is coming in a container that is known as ladle. And you will be putting this ladle in this part. And I would like to tell you this part which is shown like this. We call it as pouring basin. We call it as pouring basin. Pouring basin. And my dear, when you are pouring the molten metal here, from here it will be going down. And this part we call it as sprue. And my dear, here we are putting a jali. Jali means a strainer. Like whenever you take the tea, then you are going to have a jali. You are going to have a strainer for that. So that only tea will go out of that and tea leaves should not go inside. So that is why we are going to have this strainer. And then my dear, how the things are going to happen, let us start one by one. Actually, whenever we are going to make a gating system, what is the purpose of the gating system? As you know, molten metal is coming from the furnace. You are pouring into that cavity. And actually, this is the final product which you want. This hatched part. So we are calling this as cavity. So I want molten metal to enter into that. So my dear, whenever we are talking about the gating system is having some purposes. What are those purposes? The very first purpose of gating system is that ki whatever molten metal I am supplying, that should reach the cavity in the minimum possible time. Because if the molten metal which I am pouring will be taking more time, if it will be taking more time, then in between it can solidify. So to avoid that problem, I need to fill the cavity in minimum possible time. First point is clear. Second point, like Rishabh is saying, I don't want any kind of jhag, dross nahi chahiye mujhe. And you have seen whenever you are going to the sweetman for drinking the milk, they are going to give you a glass and they are putting the milk from a large distance and you have seen a lot of dross is forming. Jhag banate hai na. Hame nahi chahiye dross. So we need to avoid the vortex motion. We need to avoid the turbulence because we don't want any kind of dross. We don't want any impurity coming from outside like stone and all. Foreign element we don't want. And also we don't want any air to come from out because air will be coming, that will also be producing the casting defects. So all these things are the responsibilities of the gating system, and how gating system will be fulfilling it, I am telling you that. So first of all, we are going to provide this pouring basin, my dear. And in this pouring basin, we are going to provide the molten metal like this. So we are putting the molten metal in the pouring basin. We are not putting it in the cavity. We are putting it in the pouring basin. So when we are putting it in the pouring basin, my dear, from here, when the pouring basin will be filled, molten metal will be flowing here. You may be thinking, sir, why not we are providing directly from here? Why not we are providing directly from here? So my dear, for that there is a reason. For that there is a reason. So when molten metal will be coming from here, when molten metal will be coming from here, then my dear, there are chances, very less chances of dross formation. If you are going to pour molten metal from here, because of this height, there are chances of dross formation. So if we don't want the dross formation, we would be pouring the molten metal in the pouring basin. From pouring basin, slowly it will be going. And when this molten metal will be going from here, this is a strainer. Strainer is provided so that if any heavy impurity is present inside the molten metal, like some stone, like some foreign element, that is also going to be stopped here only. It will not be allowed in the cavity. And also it will reduce the momentum of the molten metal. Then the molten metal slowly from this will be reaching here in the bottom. And here also, my dear, that molten metal is coming. We don't want it to penetrate into the molding sand. So we are providing a ceramic splash core. This is said to be splash core. This is made up of ceramic. So we are providing it so that it should not, molten metal should not penetrate the sand. And my dear, whenever molten metal will be coming here accumulating, this is said to be the pouring basin, is said to be the Reservoir of molten metal at the top, it is at this sprue base well. This is said to be sprue base well. This is said to be the reservoir of molten metal at the bottom. And from here, my dear, molten metal will be going inside, which is said to be runner. And here we are providing skim bob. And this is provided for impurities to be accommodated at two places. Here heavy impurities, here lighter impurities. Okay, then my dear, molten metal will be reaching to this area, which is said to be ingate. And from here, molten metal will be entering inside the cavity. Is it clear? So guys, this is how the molten metal will start its journey from ladle till cavity. And from ladle till cavity, whatever elements you are having, all are the parts of gating system. Pouring basin is for avoiding the dross formation. Strainer is to have the heavier impurities. This splash core is to avoid the penetration of molten metal into the sand. Then my dear, we are going to have this skim bob to have heavier and lighter both types of impurity. We have this ingate for entry, and then my dear, once it enter into the cavity, there is no role of gating system. So my dear, this is about the gating system. We have seen one by one each and every element. Now my dear, we would be having the types of gating system. So my dear, when we are talking about the types of gating system, objective we have seen. Type is top gating system, bottom gating system, parting line gating system, and stepped gating system. These are four types of gating system. And my dear, whenever we are talking about top and bottom, they are more important. You can see, my dear, there are top and bottom gating system. This is the top gating system. So top gating system and bottom gating system are the most important. Rest are not that important. So my dear, just we are going to see both of them, and then I will give you the formula for that. And after that, our gating system will be over. Then we will reach to the gating ratio and all. Okay. So everybody is getting it. Please tell me. Everybody is getting it. Please tell me. Then we are moving further. Okay, guys. Now, my dear, we are talking about the top gating system and bottom gating system. Whenever we are talking about the top and bottom gating system, what is the advantage? Wonderful, guys. Wonderful, guys. Wonderful, guys. So, whenever we are using the top gating system, my dear, the definition of top gating system is that molten metal is coming from the top. 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 From the top of what? From the top of cavity. So this is the top of cavity, and molten metal is coming from here. Now you know the first layer of molten metal will be coming here. Second layer of molten metal will be coming here. Third layer of molten metal will be coming here. Fourth layer of molten metal will be coming here. So you know first, second, third, fourth, whenever that will be coming. You know, if this much layer is solidified, then also the next layer can enter. There is no problem in that. That is said to be favorable temperature gradient. It is not resisting the upcoming layer. So we call it as favorable temperature gradient. So we will say in the top gating system, the temperature gradient is favorable. Second thing, my dear, whenever we will be finding out the time required to fill the cavity by top gating system, it is always coming lesser than the bottom gating system. This is the second thing. These are two advantages. But here, molten metal is directly coming from the top. Chances of dross formation are more. As it is coming from a height, chances of turbulence are more. So these are the disadvantage. Okay, when you will be finding out the time required to fill the cavity, it is coming out to be volume of casting or cavity divided by ingate area into velocity at ingate. It can also be written as area of casting into height of casting divided by AG. When you will be calculating VG, it will be coming out to be 2G HM. So guys, in the marathon, we cannot go with the derivation. So I'm directly giving you the results. Everybody understand? This is the time required to fill the cavity by top gating system. We are calculating it using the Bernoulli's theorem. Everybody understood this? In the classes, I derive it, but there should be a difference between 150-hour class and 15-hour marathon. Okay, that will be there. Okay. Then, my dear, we have bottom gating system. Whenever we are talking about the bottom gating system, here you can see molten metal is entering from the bottom of the cavity. Okay, it is entering from the bottom of the cavity. And that is why we call it as bottom gating system. Here, let us say molten metal is filled till this point. And at that point, if molten metal of this layer is getting solidified, you cannot fill the entire cavity. So I will say unfavorable temperature gradients. Unfavorable temperature gradient. But my dear, whenever molten metal is coming from here, dross formation is not there. And third thing, there is no turbulence. So my dear, there is two disadvantage, one advantage. What is disadvantage? Time required to fill the cavity is more here. Is it clear? Time required to fill the cavity is more here. So when you would be finding out the time required to fill the cavity this time by bottom gating system, it would be coming out to be 2 into A. 2 into A divided by AG. Here it is going to be root 2G. Here we would be having square root of, yes, it is HM minus HM minus H. Now what is this I am telling you? Don't worry. So my dear, this capital A is the area of casting. Capital A is the area of casting. G, everybody know. This is the area of ingate. Sorry guys. This is the area of ingate. And my dear, if you are going to have, this is the height of molten metal. And this is the height of cavity. Just, sir. Okay, guys. Okay, guys. So this is going to be the formula. And my dear, if by chance HM will become equals to H, then this term will become 0. Then this term will become 0. And when this term will become 0, you would be getting TF as equals to 2 times of A by AG. Here root 2G. Let us say I am multiplying here with HM, 2G HM. And here we are having 2A and root HM. Here also we have multiplied with root HM. Here also we are multiplying with root HM. So it will become HM. Or HM is equals to H. So if you see, this formula will become TF of bottom as equals to 2 times of A. HM is H divided by AG root 2G HM. So my dear, you can see it is coming out to be directly equals to 2 times of time required to fill the cavity by top gating system. So if my dear, this is the condition given that molten metal height and casting height is going to be equal, my dear, double time would be required by bottom gating system. The same cavity can be filled in 20 seconds by top gating system and will require 40 seconds for bottom gating system. So guys, if any doubt is here, please tell me. I am giving you 1 minute. If any doubt, please ask. Please ask. Just 1 minute. Please tell me. Okay guys, is it clear? No doubt, no doubt. Wonderful guys, बहुत बढ़िया. So guys, this is about the top and bottom gating system, but I would like to tell you till date there is no question on this formula. Till date whatever questions are coming, they are asking from there only. So what they are doing, they are giving the data in such a way that you can find out the time required to fill the cavity by top gating system and just double it to get the bottom gating system. Is it clear? Yes. So guys, I would also like to add here one thing. Like some students wants to know that, like let us say there is an instant whenever this part is filled, which is up to height h. Then at that time, if you will be finding out the in-gate velocity, here in-gate velocity is not constant. In top gate system, gating system, it was constant always. But in bottom gating system, as you can see, the height difference is this much. So this time, if you would be writing at any instant, the velocity of in-gate will be coming out to be 2g hm minus h. This is the in-gate velocity for any instant. For any instant, when h height will be filled in the cavity. But in case of top gating system, it is always 2g hm, because in the top gating system, it is always coming from this height only. This is hm. Everybody know hm is the height of molten metal. Everybody know this h is the height of cavity. Everybody know A is the area of cavity. Everybody know AG is the area of in-gate. Clear for everyone? Clear for everyone? Clear for everyone? Okay. Both the areas I have written in front of you guys. Both the areas I have written, both the formulas I have written in front of you guys. This was about the top and bottom gating system. And guys, now there is one more thing I would be discussing. You can see here derivation also in the slides are given. So if anybody is interested in the derivation, he can see the derivation also. Now this is the question guys from the top gating system. Solve it. Here G is 980. Dear, that will be depending on the units in which unit we are putting. So they would be giving you height in mm sometime, in centimeter sometime. So if you are talking about G, it is 9.81 meter per second square, or it is 981 centimeter per second square, or it is 9810 mm per second square. Choice is yours. Choice is yours. Clear guys for everyone? Clear for everyone? So you can see a mold has down sprue whose length is 20 centimeter, cross section area at the base of the down sprue is 1 centimeter square. The down sprue filled with a horizontal runner leading to the mold cavity, volume is this. Find out the time required to fill the cavity by top gating system. You know the time required to fill the cavity by top gating system is volume of casting divided by AG root 2g hm. You know volume is given as 1000. Area is given as 1, 2, 9, 8, 1. Height of molten metal is nothing but what? 20 centimeter. Because they have given the down sprue height. I would like to tell you, whenever this type of figure is there, this is the height of pouring basin. This is the height of sprue. The summation is said to be the height of molten metal. Okay. Some people are also calling this as height H1. This is height H2. Total is HM. So when you will be finding out, this will be coming out to be 5.05 seconds. 5.05 seconds. Is it clear guys for everyone? Is it clear guys for everyone? Yes. Very good Pradeep. Moving to the next. Aspiration effect. Next is aspiration effect. So my dear, actually what is aspiration effect? I am telling you, like whenever we are going to have top gating system, I am taking like this. Okay. This is the top gating system we are having. This is H1, this is H2, and this is height of the cavity. This is the in-gate, area of in-gate, and this is the area. So my dear, whenever we are going to find out, whenever we are going to use the Bernoulli equation, how we are using the Bernoulli equation, everybody know. I am taking here 3 datum. This is the third datum. This point is 2, this point is 1. If we are going to apply the Bernoulli equation at 2 and 3, this is the formula, you know that. And my dear, we are generally talking about this is 0.3, this is 0.2. This 3, 1, we are generally assuming they are open to atmosphere. And if they are open to atmosphere, generally we are assuming there the pressure is going to be equal to atmospheric pressure. Atmospheric pressure means gauge pressure will be 0. And if gauge pressure will be 0, I can say P3 is going to be 0. And you know Z3 is 0. Why Z3 0? Because you are talking at the datum. And you also know that the sprue is of cylindrical shape. So by continuity equation, A2 V2 is equals to A3 V3. From here, A2, A3 will be cancelled out, to V2 will be equals to V3. So this and this will also get cancelled out. And you would be getting P2 as equals to minus rho G H2. Can you say that pressure at second point will be negative? Can you see pressure at second point will be negative? Can you see pressure at second point will be negative? And my dear, whenever we are going to have negative gauge pressure, look, absolute pressure can never be negative. It is negative gauge pressure. So it means the pressure is lower than atmospheric. So my dear, if here the pressure is lower than the atmospheric and outside pressure is atmospheric, don't you feel there are chances that air from outside will be entering at the point 2? Don't you feel, very good Raja, don't you feel air will try to enter at point 2 from the outside? So when my dear air will try to enter at point 2, that entry of air is said to be air aspiration effect. And if the air is going to enter, it is going to make our casting as defective casting, because my dear, wherever air bubbles will be present, molten metal will not be present, and there will be a defect known as porosity, blowholes, that kind of defect will be coming. And that is why we need to avoid this aspiration effect. If this aspiration effect, this is going to create a lot of problems, casting defects. So we don't want this. We don't want this. So if we don't want this, that is having only one treatment. That pressure at this point P2 should be at least equals to the atmospheric pressure. And when the pressure is atmospheric, gauge pressure is 0. If I once again apply the Bernoulli equation, this is the Bernoulli equation. This time I am saying P2 and P3 will be equal. Why equal? Because I am assuming the minimum value as atmospheric pressure. Z3 0 because it is datum. Now my dear, here we have 2 terms, here I have 1 term. So this time V2 and V3 cannot be equal, because if V2 and V3 are equal, Z2 has to be 0, which is not. Because you have just seen in the previous figure that when we are taking the datum, this height will be Z2. So Z2 is not 0, Z2 is H2. So that is why when I will be using this Bernoulli equation here, my dear, this time V2 and V3 cannot be equal, because here 2 terms, here 1 term is there. And if V2 is not equals to V3, my dear, A2 can also not be equals to A3, because anyhow A2 V2 will be equals to A3 V3. So for continuity equation to be followed, areas have to change. I don't know how the area will be changing, but yes, we can find out by the conditions that how the area will be changing. And we are assuming that yes, different areas are there. At point 3, we are assuming the area to be A3. At point 2, we are having the area to be A2. So my dear, once again, I am writing the equation V2 square by 2G plus H2 is equals to V3 square by 2G. So we are assuming the ratio of A2 by A3 as V3 by V2. Okay. We are going to consider it like this. Or you can also say A2 by A3. In place of that, A3 by A2 will be V2 by V3. And we are considering this ratio to be R. So if that ratio is R, we can write V2 as equals to RV3. V2 as equals to RV3. So when you would be putting this ratio, you would be going for the derivation. Then my dear, you would be getting the final result, and that final result will be coming as R to be equals to square root of H1 by HM. Is it clear? It is coming out to be H1 by HM. So if R, which is A3 by A2, is equals to this ratio, then my dear, you can avoid the air aspiration effect. Here HM is nothing but HM plus H1 plus H2. Height of pouring basin plus height of sprue. I have done half of the derivation and then I am giving you result. So my dear, if you see, the area ratio is a square root of height. So when you will see, you will be getting this type of parabolic figure for sprue. So actually it want to say, if you want the air aspiration effect to be removed, you need to change the area like that. But as an approximation, we are generally consider it to be taper. So as an approximation, we are going to consider it to be taper. Otherwise, it is coming parabolic in nature. Clear, guys, for everyone? This we are doing to avoid the air aspiration effect. I feel everybody is clear. Everybody is clear. अरे भाई इससे अच्छा और क्या रिवीजन लोगे? Derivation भी चल रहे हैं. This is for bottom gating system. We have already seen. Derivations are given in this slides. Okay. Now, my dear, we are moving to the third type of gating system, that is parting line gating system. Parting line gating system is used when the cavity is of very, very big size. When the cavity is of very, very big size, my dear, you can see, we are going to divide the cavity into two parts. We are going to divide the cavity into two parts. And my dear, you can see for this A part of the cavity, molten metal is coming from the top. For B part of the cavity, molten metal is coming from the bottom. So my dear, to find out the time required to fill the cavity A, we would be requiring the formula for top gating system. To find the time required to fill the cavity B, we would be using the formula for time required to fill by the bottom gating system. And my dear, in that way we can say the total time to fill the cavity is going to be time of top plus time of bottom, or time of A plus time of B. That is said to be parting line gating system. Is it clear for everyone or not? Thanks, Sujit. Very good, Ashray. Everybody is clear on this or not? Please tell me that. Yes, guys, everybody is getting it or not? Please tell me. We have almost completed. We have almost completed. Yes, guys. Wonderful. We have almost completed. Very good. Wonderful, guys. So moving further. Yes. Moving further, stepped gating system. So my dear, whenever we are going to have very big size of casting like lathe bed, then for that case, we are going to provide multiple gates. Like we are going to have molten metal is coming from this. So that kind of thing is said to be stepped gating system. Here, nobody will be asking you the time required to fill. If they ask, just need to add all of them. But this type of question have never been asked in any of the exam. They are asking only the application of this. The application is lathe bed. The very big size casting, lathe bed. Clear for everyone? Yes, guys. So with this, we have done all the four types of gating system. Now we are having a wonderful term, that is choke area. For the first time in GATE, it was asked in GATE 2014. And they have asked which of the following area is said to be the choke area. Just listen to me properly. Which of the following area will be said to be choke area? Number one is sprue area. Number two is in-gate area. Listen to my options properly. Number three is runner area. And number four is nothing but the minimum or throat area. Answer it from your knowledge rather than going through the slide. Which of the following area is said to be the choke area? 4 options are there in front of you. Sprue area, ingate area, runner area, or minimum or throat area. Rishabh is saying minimum area. Abhi is saying minimum area. Everybody, सोच लो भाई, गलत ना हो जाए. It is a question of GATE 2014. Yes, Ajay is saying A. कोई तो फिसला. Yes. Abhishek is saying B. Yes. अरे भाई विनय, आपसे उम्मीद नहीं थी मेरे को ये. एटलीस्ट क्लासरूम स्टूडेंट को नहीं फिसलना चाहिए यार. I told you also this na. When this question came, many coachings have given the answers. Sprue area, ingate area, runner area. अरे भाई minimum area is choke area. The definition of choke area is the minimum area actually. Okay. It can be sprue area for some case. It can be ingate area for some case. But the definition is not that. Definition is it is the minimum cross-sectional area in all the gating elements. And my dear, this is going to help us in find out all the dimensions, because all other areas can be found out with the help of choke area if you know the gating ratio. So choke area is defined as this. This is the formula in front of you. So my dear, choke area is defined as M by rho TF CD 2GHM. This is the choke area. Okay, Vinay, no issues. So this is going to be the choke area. So here M is the mass of casting. Rho is the density of metal. TF is the time required to fill the cavity. CD is the coefficient of discharge. 2GHM is the height of molten metal. So my dear, whenever we are going to say this is the formula for choke area. Choke area is always defined as the minimum area. And my dear, once we know that, after knowing the gating ratio, we can find out area of any element. So we are going to have the next heading as nothing but gating ratio. Gating ratio is defined as the ratio of 3 areas. One is sprue area, other is runner area, other is ingate area. Here the confusion is, sir, which sprue area? Sprue is having infinite number of areas. So I am making a figure for that. So I would like to tell you that this area, the below area of the sprue, is said to be the sprue area. This is said to be the runner area. And this is said to be the ingate area. Okay? Yes. So my dear, this ratio of sprue area to the runner area to the ingate area, we call it as the gating ratio. Is it clear for everyone or not? Please tell me, guys. Please tell me everybody is clear about the gating ratio or not. So my dear, the point is, if we know the minimum area, okay, that's fine. Choke area is known to us from the formula. We know that. Now if someone is saying that 2 is to 3 is to 1, this is the gating ratio, then we know the minimum area is looking like the ingate area. So you would be directly knowing the ingate area. Multiply that with 3, you will get runner area. Multiplying that with 2, you will get sprue area. So that is why, that is how it is going to help us in finding out all the unknowns. So please tell me, guys, everybody understood this or not? Then we are moving further. Everybody understood this or not? Please tell me that. Okay? Okay? Okay, guys. Tell me the answer for this question. Tell me the answer for this question. Yes. sprue to the runner to the ingate. A is the right answer. Very good, guys. This is GATE 2011. Let us see how many of you have listened to me properly. So guys, do like and share the session. Still casting is going on. Yes, yes, yes. D would be the right answer. Okay, guys. One more thing I would like to tell you. Whenever we are talking about the gating system, how many types of gating system you have studied? How many types of gating system you have studied? 4 types. But that was depending on the size and other requirements. Based on the gating ratio, also gating system are classified into 2 categories. One is unpressurized gating system. Other is pressurized gating system. So my dear, a gating system is said to be unpressurized gating system if sprue area is the choke area. If sprue area is the choke area, then it is said to be unpressurized gating system. Means minimum area will be present at the sprue. And if ingate area is becoming the minimum area or choke area, then we call it as pressurized gating system. In pressurized gating system, we are generally also providing the inert gas environment. So inert gas is always pressurizing the entire mold, and that is going to help us for those material which are having the problem of oxidation. Okay, so this is how we are going to say unpressurized and pressurized gating system. These are of 2 types. So when we are going to have here, the minimum is sprue area, here the minimum is choke area. So I feel everybody understood these types, and with that gating system is over. Now we are going to move to the riser design, my dear. The next step, step number 4, is riser design. Only this is the next step which will take some 30-35 minutes. But after that, I am telling you guys, once we will cover this, after that entire part would be requiring very less time, because other steps are just one-liners. Only up to this step the time will be required. So my dear, the 4th thing is the riser. Here we are doing only 1-to-1-2 questions of gate, just to tell you how the questions are coming. But in the practice session which will be there tomorrow, you will see all variety of questions. So be ready for that. Practice session will give you the real practice. Here just we are seeing this what type of questions are coming. So this will also give you a feel, but for better, good questions, good level, we will see tomorrow. Very good, guys. So now we are talking about the riser, because in the marathon we are doing only the types of question which have there in the exam. Okay, new type of question, dangerous question, we will see in the practice session. So when we are talking about the 4th, my dear, 4th is going to be the riser design. Anybody can tell me what is the purpose of riser? What is the purpose of riser? What is the purpose of riser? Tell me, guys. What is the purpose of riser? What is the purpose of riser? What is the purpose of riser? Yes, very good. So you have seen, my dear, the very first purpose of riser is to compensate for the molten metal during first 2 stages of shrinkages. And the second thing is, when you see the riser is full, you have a guarantee that casting is full. Why? Because if this is the sprue, this is the sprue, this is the cavity, this is the riser, let us say. Okay. So when you see the riser is full, it gives you a guarantee that cavity is also full. And my dear, as you are saying, riser is going to provide the molten metal during first 2 stages of shrinkages. That is possible only if riser is going to solidify at the last. So my dear, for that what we want, that whenever we are talking about the solidification of the molten metal, solidification of the molten metal shall happen in this direction. In this direction means riser should solidify at the last. So solidification should happen in such a way that the area near to the riser should solidify last and area away from the riser should solidify first. So solidification should go in this direction, and that is said to be the directional solidification. And that is said to be the directional solidification, which is the minimum requirement for the riser design. Is it clear? So my dear, whenever we are talking about the method of riser design, we are having a large number of methods. The very first one is the Keynes law. Second one is the Chigorinov law. Third is the Keynes method. Fourth is shape factor method. Fifth is modulus method. Sixth is shrinkage volume method. Out of these 6 methods, my dear, for your syllabus, from where the questions will be coming, if you are asking me that, so I would be ensuring you that question will be coming from here most of the time. Nowadays, they are also asking from these 3. So chances are 50% from Chigorinov's law, 50% from any of these 3 methods. That is what I feel so, by looking at the previous recent year trends. So my dear, when we are talking about Keynes law is just defining a very, very important parameter, which is said to be cooling characteristic. So my dear, Keynes law says that cooling characteristic is directly proportional to surface area by volume. We know that for a given volume, more surface area means more cooling rate and less time for solidification required. So my dear, if surface area will be more, cooling rate would be more. If surface area is more, cooling rate will be more. If surface area will be more, cooling rate will be more. Is it clear? If surface area will be more, cooling rate will be more. Is it clear? So when we are talking about the cooling characteristic, it is said to be surface area but a volume. And my dear, you can see for a given volume, cooling characteristic is directly proportional to surface area. So for a given volume, more surface area, more cooling and less time required for solidification. So this is the Keynes law. Okay. Then my dear, whenever we are talking about the Chigorinov's law, it says that solidification time is equals to K into volume bate surface area ka square. And we know that it should be the case, because if surface area will be lesser, time required for solidification will be more. But cooling characteristic, Keynes law does not tell the real relation. Here it is giving the real relation. Here K is the solidification factor, V is the volume of casting, surface area, S is the surface area, not casting for anything. So you can see TS is nothing but directly proportional to volume bate surface area ka square. Majority you will see previous year questions on this topic. If you go 5 years before, 90% questions were coming from Chigorinov's law. But if you see all the years, then this 50-50 I am saying, because nowadays questions are also coming from shape factor method, from shrinkage volume method, from modulus method. Previously they were not asking. Is it clear for everyone? So guys, do like and share the session. We are reaching to the riser design now. Everybody is clear or not? Please tell me that. Everybody is clear about this or not? Please tell me that. Then I am coming on to these methods also. Don't worry, one by one. Okay. So my dear, now I have already told you what is Keynes law. It states that the cooling characteristic of casting, okay, that we have seen. Chigorinov's law we have seen. Okay. Then my dear, K is the solidification factor. It is depending on thermal conductivity of material, latent heat, pouring temperature, freezing temperature and all. Is it clear? Clear for everyone? So now one by one I am showing you all other methods. Okay. The third method we are going to say as the Keynes method. So I am telling you guys, you can leave the Keynes method for gate. Generally it is suitable more for the engineering services, because here they have given a relationship, and that relationship was Y and X, and between Y and X they have plotted a curve like this, and they have said this is Keynes curve. And what is this y and x if you want to understand? Here y is said to be the volume ratio. Volume ratio. It is said to be volume of riser but a volume of casting. Volume of riser but a volume of casting. Okay. Then my dear, x is said to be freezing ratio. X is said to be freezing ratio. मैं ऊपर लिख रहा हूं थोड़ा सा. दिखाई नहीं दे रहा क्या जो मैंने लिखा? इज इट क्लियर और नॉट? दिख तो रहा है यार. एनी डाउट गाइस? कोई है तो पूछो. Okay. Just let me check if there is a doubt. Just give me a second. I'm checking it. Okay. So guys, then we are having freezing ratio. It is defined as volume by surface area of riser divided by volume by surface area of casting. Is it clear for everyone? And if I would be asking you, tell me whether you find this relation, like this curve, is it a parabola or hyperbola? Is it a parabola or hyperbola? Is it a parabola or hyperbola? Tell me, is it a parabola or hyperbola? Is it a parabola or hyperbola? Is it a parabola or hyperbola? Parabola or hyperbola? Tell me that. This curve is a parabola or hyperbola? This curve is a hyperbola. This is not a parabola. If you remember, if I say xy is equals to constant, you will plot like this. So this is not a parabola, this is hyperbola. And when we are going to write down this relation, Keynes have given a relation like this. Keynes said x is equals to a y minus b plus c. Here a, b and c are the constant which will be depending on the material. A, b, c would be depending on the material. Okay. So when we are talking about, this is the Keynes formula, my dear. X, y are nothing but the freezing ratio and the volume ratio. So my dear, this relation is an empirical relation. And question can come from this in the engineering services conventional. There are no chance that question will be coming from GATE in this. Then sir, why you are teaching this here? I am teaching because my next method is related to this. What is my next method? Actually, first of all, what is the problem with this method? When this Keynes curve was given, if you are writing the relation between x and y, We are going for riser design means what? We know the casting size, but we don't know the riser size. So we are going to calculate the riser size. Here in Y also we have volume of riser. In X also we have volume but a surface area of riser. So both X and Y are having the unknown terms. So it is going to be very difficult to calculate. And that is why we are calling this as empirical relation. This relation is also giving answer very difficult way. So guys, that is going to be, yes, like Dheeraj have written, trial and error. Here this is a trial and error method. Here you need to put the value and see whether the answer is coming or not. So value put करके आप answer check करते हो यहाँ पर. So that is why gate will not ask on this. In conventional ESC also only once the question came. So my dear, this method was improved, and that method after improvement is said to be naval research laboratory method. Naval research laboratory method. You may be thinking, sir, such type of method you have not written on that sheet. So I am telling you, this is also known as shape factor method. This is also told as shape factor method. Now my dear, in this what they have done, the same curve, the same cane curve. What they have done, they have replaced the freezing ratio. Here Y only. Freezing ratio is replaced by shape factor. And when we are talking about the shape factor, it is totally depending on the shape of casting. Like if you are going to have a casting of this shape, this is L, W into T. Or I will not make the shape, but you know, you can directly call it is a plate. I am directly writing it is a plate of dimension LWT. Then my dear, you would be going for shape factor as L plus W by T. This is how they have defined the shape factor. So how you would be solving the question here? You would be given the size of the casting. From the size of, now my dear, we are going to design for the riser. So riser is unknown to us. Casting is known to us. So we want to calculate the size of riser with the help of size of casting. So my dear, that is why X should be having the dimension related to casting, not related to riser. Because Y is already having volume of riser but a volume of casting. So here shape factor is depending on the size of casting. You can see L plus W by T. They are the dimension of casting. Once you will get this number, what you need to do? If you will get this number, let us say shape factor is coming this one. Okay, you would be given this curve or the values of shape factor corresponding to the volume ratio will be given. Like they will give you a table. And in this table, they would be writing two values. Here they will say volume ratio, VR but a VC. Here they will say shape factor. So you would be finding out first of all shape factor, and this value will be matching here. So for this shape factor, this is the volume ratio. So you would be getting volume of riser but a volume of casting. Then my dear, that ratio you already know. Now volume of riser is a cylinder. You can find out the riser volume very easily if the casting volume is known to us, which would definitely be known to us. This is said to be the shape factor method. Till date, one question only from this method in GATE. We will do the questions, don't worry. Correction factor if given, yes, we will be using, but there are very, very few chances that you will get it. Because generally, if you see in 2016, the question was there. They have directly given this. If correction factor is given as these are empirical relations, we will be using that for sure. In the question, I will tell you how to use correction factor. Don't worry. So my dear, this is how we are going to find out the dimensions. Everybody is clear? Everybody is clear with the shape factor method? Everybody is clear with the shape factor method? Tell me, two methods are left. Very good, guys. Very good, guys. Then, my dear, we are going to have the fifth method as modulus method. Fifth method as modulus method. Here, my dear, this method says, first of all, you need to understand that when we were defining modulus, it is volume but a surface area. We are defining the modulus as volume bate surface area. Why we are defining? Because you know solidification time is directly proportional to volume bate surface area ka square. And you know that if volume bate surface area is more, solidification time will be more. You tell me, if I am comparing for riser and casting, for which of them solidification time should be more? Who should solidify at the last? Who should solidify at the last? Riser or casting? Who should solidify at the last? Riser or casting? Riser. So my dear, that is why I would be saying here, the modulus of riser should be more than the modulus of casting. Modulus of riser should be more than the modulus of casting. Modulus of riser should be more than the modulus of casting. Modulus of riser should be more than the modulus of casting, and this method says it should be 20% more. So my dear, if you are already knowing the size of casting, we can very easily find out the size of riser. Because what you will write? Volume of riser by surface area of riser. That is equals to 1.2 times of volume of casting but a surface area of casting. Don't worry, we are having questions on that. Don't worry. Clear for everyone? Fifth method is clear for everyone? Fifth method is clear for everyone? Fifth method is clear for everyone? Bolo bhai. Very good. Moving to the last method. Sixth method is shrinkage volume method. So my dear, in this method, first of all, there are two conditions. The very first condition is volume of riser should be more than or equals to 3 times of shrinkage volume. In the question, they will be giving that casting is shrink by this much amount of volume. Yeah, this much percent. So you will first of all find out the shrinkage volume. You will multiply it with 3 and riser volume should be more than that. If in the question examiner says it is more than 4 times, then you will use that formula. But minimum is this. Riser volume should be more than or equals to 3 times of shrinkage volume. And my dear, when you will be doing this, when you would be knowing this, this is a constant which will be known to us. You would be writing the volume of riser. You would be writing the volume of riser, and from here you will be finding out the dimension. How you will find out the dimension? You know that volume will be pi by 4 d square into h. That is more than equals to, let us say, some xyz number is there. The problem is diameter and height both are unknown. How we will calculate? So my dear, for that, once again, there are two things. If height or diameter is given, one thing is given, second thing can be calculated very easily. Yes. So we can say one is given, other calculated. There is no problem. But if D or H not given, then we will be going for the optimum condition. What is the optimum condition? You should know there are two types of riser. One type of riser is said to be the top riser. For top riser, we have derived in the paid courses. In my notes, derivation is also given. Here we are not going to waste the time. I would like to say for top riser, height should be equals to radius. That is the optimum condition. And if we are going to have the side riser, then my dear, height will be coming out to be equals to diameter. So when we say height is equals to radius, height is equals to d by 2. So either height will be d by 2 or height will be d. So when you will be using either of these two relation, only one unknown will be left. And in that way, you would be able to find out diameter, height, both of the things. But the condition is you will use this only if given is not there in the question. If it is given, then you cannot assume like this. If it is not given, then you will assume like this. What is the difference between top and side riser? I am telling you in brief that whenever we are talking about top riser, this surface and this surface are losing the heat. For side riser, this surface and this surface, these three surfaces are losing the heat. Okay guys? Okay guys? So my dear, the problem is not completed here. After this, you would be getting either height or diameter with this condition or with this condition. Whatever height or diameter you are getting, you need to check. With that value, modulus of riser is more than modulus of casting. If with those value, modulus of riser is coming more than modulus of casting, then that is your answer. There is no problem. But if modulus of riser is coming less than modulus of casting, then previous values will not be the answer. Then you would be putting modulus of riser to be more than modulus of casting, and whatever answer you will get, that will be the answer. Means overall condition is it should solidify at the last only. So if a question is coming from the shrinkage volume method, you need to take care of these steps. I feel as it is marathon, everybody is here for the revision purpose. So you would be understanding what I want to say. Is it clear for everyone? Clear for everyone? बोलो भाई, आप लोग बैठ के पढ़ रहे हो, मैं खड़े होके इधर उधर जा जाके पढ़ा रहा हूं ऐसे ऐसे, थक आप गई हो मुझसे ज्यादा है। Okay, Dheeraj, I am once again repeating yellow part. So whatever the dimension you are going to get there, they need not be the right answer actually. Whatever you are getting is, they may not be the right answer. Because you have said that volume of riser should be more than equals to 3 times of shrinkage volume. It could be 4 times, 5 times, 6 times also. Why 3 times only? Okay, so we have taken this, not a valid answer. We are taking it as kind of range. Where inequality is there we are having a range of answers. So more than 3 times of shrinkage volume you have considered, with that you will get some answer. If height or diameter will be given, second you can calculate very easily. If not given, then you will be using either of these relation and then you will calculate. So up to this calculation will be done, there is no problem. Okay. Now my dear, what you will be doing, whatever the dimensions you got, with those dimensions you will be checking that modulus of riser is coming out to be more than modulus of casting or not. Because riser should solidify at the last, that is my sufficient condition. Without this, riser design is of no use. So if this condition is satisfied, that is your answer. There is no problem. There is no problem. But if modulus of riser is coming out to be less than modulus of casting, answer is leave the answer. That answer is wrong. Then you will put modulus of riser to be more than modulus of casting and find out the answer using this condition. And whatever you are going to get, that is my final answer. Is it clear? That is said to be the sufficient condition. So we have used here 2 conditions, like in CR equation you have. This is said to be the necessary condition. This is said to be the sufficient condition. Both should be satisfying. If this is satisfying and that is satisfying, both are satisfying, then only the answer is correct. Is it clear for everyone? Please tell me that. हाँ, हमें चेक करना होगा. इस मेथड में चेक करना जरूरी होता है भाई. जो लोग मुझसे क्लास में पढ़े हैं उन्हें तो पता ही है सारी बातें, और जो लोग नहीं पढ़े उनको कुछ नया सीखने को मिल रहा है कि नहीं? आर यू लर्निंग समथिंग न्यू हियर और नॉट? प्लीज टेल मी दैट. आर यू लर्निंग समथिंग न्यू हियर और नॉट? प्लीज टेल मी दैट. Clear for everyone? So now we will see the questions. Don't worry, we have completed the riser design part. Okay. So you know, after riser design, the fifth step was melt the metal. And when we are talking about melt the metal, for that we need not to do anything. For melt the metal, we just need to put it into the cupola furnace. So cupola furnace is not in our syllabus. We would be melting it in the furnace. Then my dear, next step will be the pouring of molten metal. That you also have already studied. When we are going to pour, we are going to pour it with a degree of superheat. That pouring temperature is going to be equal to melting point temperature plus degree of superheat. Can you tell me why we are going to provide the degree of superheat? Can you tell me why we are providing the degree of superheat? Can you tell me why we are providing the degree of superheat? Tell me, tell me, tell me. Yes, yes, yes. To maintain the fluidity of the molten metal. Because if you are going to have furnace at one place, casting at other place, then when the molten metal is coming to the cavity, it is going to lose heat. So the temperature should not be less than this. We should always be either above this. We should not be left to this. So that is why we are going to heat extra, so that even some cooling happen, we reach at the max up to this temperature point only. That is why we are putting this pouring temperature. So this is the pouring one. We are going to keep the fluidity to be constant. Is it clear? Yes. So fluidity should be there. And now what is the fluidity? Fluidity is the property of molten metal. Fluidity is the property of molten metal. Never confuse between fluidity and flowability. Never confuse between fluidity and flowability. Flowability and fluidity are different things. When we are going to talk about them, fluidity is the property of molten metal. And flowability is the property of molding sand. So my dear, actually you know that whenever we are talking about fluidity, there are some tests, like we have seen the permeability test. There are some tests to be performed to check the fluidity as well. For that we are going to take a cavity, and that cavity is of helical shape. And we are going to provide the molten metal at the pouring temperature inside this cavity. And this is start flowing in this helical cavity like this. And let us say reaching to this point, it is going to get solidified. Then after this, the molten metal will not flow because here it is solidified. We will find out the length which it have covered before solidified. More the length, more the fluidity. So the length will be the measure of fluidity. When we perform this test, this is said to be spiral test. And if that spiral test cavity is having the constant cross section, we call it as rod test. And if its cross section is continuously decreasing, we call it as V test. So my dear, I have used the term spiral test, which can be a rod or V test. Clear for everyone? Yes, 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 yes. Very good, guys. So my dear, why we are so much worried about fluidity? If fluidity is not there, there would be some casting defects. What kind of casting defect will be coming for poor fluidity? I am showing you that. So fluidity, if not proper, my dear, we would be having the defects like misrun and cold shut. Let us say our cavity is having this type. Then my dear, molten metal is not able to fill this properly before solidifying. This much part was remained empty. Then this casting defect is said to be the misrun. And if you are going to have your cavity in two parts like this, if you are having your cavity in two parts, Then my dear, from here molten metal was able to flow till this point. Here it was able to flow till this point. And this much part remain empty. That's great, Dheeraj. तभी तो यहाँ पढ़ रहे हैं. Okay. So my dear, that defect is said to be cold shut. That is said to be cold shut. Is it clear? So these are the defects which are coming because of improper fluidity. And my dear, when you are going to say that molten metal is getting filled, this is the minimum cross section which can be filled by the molten metal. Then this is said to be the sectional sensitivity of the molten metal. Sectional sensitivity is the minimum cross section which can be filled by the molten metal before solidification. Is it clear, guys, for everyone? Is it clear, guys, for everyone? Is it clear, guys, for everyone? Okay, guys. Now we are moving to the next step, that is solidification. Now we are moving to the next step, which is solidification. Now we are moving to the next step, which is solidification. My dear, solidification is step number 7. Two types of solidification is happening in the casting. One is said to be the pure skin forming. Second is said to be the dendritic growth. One is said to be the skin forming, other is said to be the dendritic growth. One is said to be the skin forming, other is said to be the dendritic growth. So my dear, I would like to tell you skin forming is going to happen in the pure metal and dendritic growth is going to happen in the elements which are having the mushy zones. Mushy zone is the area where solid and liquid both are present, that you will see in detail when I will be teaching you the material science. So my dear, first of all, we would be talking about the pure metal skin forming. So my dear, this is the top view shown. I am showing you separately. This is the top view of the cavity. And my dear, you know, molding sand is all around present, which is cooler, molten metal is hot. So when from the colder wall, molten metal will start solidifying, the solidification front will be running like this. And layer by layer solidification will be happening. They all are going towards the center. So whatever during the solidification shrinkage will be happening, that shrinkage will be accumulated at the center, which can be compensated by providing a single riser at the center. So when you are going to have this type of solidification, there is no problem. There is nothing at all. We are having the complete solidification properly. It is said to be the skin forming. Then my dear, we are talking about the second dendritic growth. This is happening with the mushy zone configuration. Where we are going to have mushy zone means solid plus liquid is present. So my dear, what kind of thing is happening in the dendritic growth? Like you are going to have this top view. This time what is going to happen actually? The solidification fronts are coming from the mould walls, that is for sure. At the same time, some solidification fronts are coming from the center, where mushy zone is present. And where these solidification front are going to collide, the first type of solidification front which are coming from the mould walls are said to be primary solidification front. And the second solidification front are this one. So my dear, where primary and secondary solidification front are going to collide with each other, some cavities would be produced. And you know, many primary fronts are going to collide with the secondary. So at many places you would be having the shrinkage happening. And we cannot provide that much number of risers. So it would be producing the defects in the casting. We call it as shrinkage cavity defect. So to avoid this, we are going to provide, my dear, some metallic pieces which are said to be the chills. So we are going to provide some metallic pieces at different places in such a way that before the secondary dendrites are producing, primary dendrites are reaching to the center, just like the skin forming. And when the primary dendrites will be reaching to the center before secondary form, there will be no defect like that. And one riser will be enough. Arey bhai, whenever we are going to have something solidifying, then for the first time crystal structure is getting formed. After solidification, we are interested in crystal structure. Okay? And that crystal structure is BCC, BCT, FCC. You have studied that. You will see in the material science. Is it clear for everyone, guys? Please tell me that. Clear for everyone, guys? Please tell me that. Okay. So my dear, after solidification is happening, we are going to break the mold. And breaking of mold is said to be the fettling process. We are sometime putting that mold onto a vibrator, and because of vibrations, those sands are going to go break, and gating system and riser will also be getting removed, and you would be left with the final product. So that is said to be the fettling process. Then my dear, after this is produced, sometimes let us say this is the casting. On this, some sand particle may be stick. So to remove those sand particle, we are going to have some small steel balls up to 5 mm, and we are going to bombard them onto the surface of casting, which is going to remove the sand from the surface, and that is said to be sand blasting. And my dear, after that, surface is very bad after casting, we need to go for the surface finish. For that, machining allowance is also providing, so we are going for the surface finish process. This is process number 9. The 10th, my dear, and the last one is nothing but the inspection. Once the casting is produced, surface finish is done, we need to go for the finishing of the surface. We need to go for the testing of the casting. Let us say this is the casting. What are the various way to check it? Just give me a minute. Okay. Yes. So my dear, now at the last we will go with the inspection or testing. The very first inspection is coining technique. We are having a surface for which we want to check whether this casting is good or not. We will take a coin, knock the coin onto the surface. That's great. Okay. So whenever we are going to have this knocking of the coin over the surface, if you will see all wear same sound pattern, it means casting is good. But if sound pattern are different at different places, it means casting is not good. Some defects are there. So where defect will be there, sound pattern will be changing. Okay. So that is said to be the coining technique. The second is, yes, MI power bank. Second, my dear, is the ultrasonic or X-ray inspection. We are going to pass the ultrasonic rays or X-ray and see the pattern of theirs. If the pattern is uniform, product is good. If pattern is non-uniform, it is said to be defective casting. So guys, this was the 10-step casting procedure. Hope you guys have understood this properly. Please tell me you understood or not. Then we are going for the core design, and we will see some questions now as well. Please tell me, guys. And after that, we are just left with the non-conventional casting. Okay. Let us see by which time we are able to complete casting. Tell me. Okay. So we have done each and everything in detail. Don't worry. Okay, guys. Okay, guys. So my dear, now we are going to have the design of core. We have already seen that the weight of core will be acting downward and buoyancy force on the core will be acting upward. So I feel everybody know When we are talking about the weight, mg, it is rho vg. This is going to be the rho of sand only. Arey Dheeraj, don't worry. Now you have joined this channel, na? So don't worry. Everything will be covered. Dear, we have promised you that by 20th, we would be completing all the subjects marathon. After that, aptitude and mathematics sessions would be coming. So if any topic you are facing that कि जैसे आज हम sheet metal operation का plan है, if you feel sir today अगर cover नहीं हुआ तो then don't worry, we have already planned with 2 more sessions for production. Material science day we have, metal cutting day we have. Okay, so don't worry, we have planned. If anything will not be able to complete, we will be completing there. We will not be leaving anything. Don't worry about that. Okay. Yes. If I will skip here, go to metal operation, then also some loss will be there. We will not be going for any loss. That's why we started marathon 30 days before. Otherwise, we could start 10 days before also. So don't worry. Just follow the stream. Okay. नहीं डरना क्यों है यार, डर क्यों रहे हो, डरना किस चीज का है, आपकी अच्छी तैयारी है. So my dear, whenever we are talking about the weight is acting downward, and when we are talking about the weight is acting downward, weight is rho s, v and g. This volume is the volume of core. And my dear, when we are talking about the buoyancy force, it would be the rho of molten metal, volume into g. Yesterday only you have seen the fluid mechanics, so you would be knowing about the buoyancy forces very nicely. अरे भाई विनीत, ये जो मैं आज बार बार बाहर जा रहा था वो इसीलिए ही जा रहा था क्योंकि वही डिस्कशन चल रहा है हमारा कि किस तरीके से उस क्लैश को खत्म किया जाए. मैं बार बार जो जा रहा था ना, राकेश सर से ही बात करने जा रहा था, तो हम वही उसी पर साथ साथ चल रही है डिस्कशन. तो वो ऑलरेडी सॉर्ट आउट हो चुका है. डोंट वरी अबाउट दैट. कोई क्लैश नहीं होगा. वी विल. अरे भाई हमें भी तो पता है आपको दोनों अटेंड करना है. वो गलती से हो गया था, उस गलती को सुधार रहे हैं. ठीक है. So don't worry about that. अभी इस पर ध्यान दो. Rest leave on us. Okay, and don't worry. Last year some you are going to talk about if some session is going to happen on app also, na? Recording of that will also be available. Don't worry. So now let us move further. So my dear, this buoyancy force will be acting upward, weight will be acting downward. So what would be the net force on the core? You know density of molten metal is very, very large as compared to sand. So you would be having rho of molten metal minus rho of sand into volume of core into G. So guys, this is the net force acting onto the core. Okay. So now we are going to see the questions. And after questions, we will go for non-conventional casting. Non-conventional casting, I will be completing in 15, 20, 25 minutes at the max. Don't worry. अरे भाई क्वेश्चन कहाँ गया? उड़ा दिया क्या मैंने? ये तो नॉन कन्वेंशनल कास्टिंग है. एक सेकंड रुको, मैं चेक कर लेता हूँ क्वेश्चन है कि नहीं है इसका. ओके, मुझे लग रहा है कास्टिंग कंप्लीट होने के बाद है क्वेश्चन. मैंने गलती से बाद में डाल दिए. बाद में कर ले चलेगा? पूरा कास्टिंग होने के बाद में कर ले चलेगा? ओके. सो माय डियर, वी हैव कंप्लीटेड दिस पार्ट. नाउ वी आर गोइंग टू से वन मोर थिंग, दैट व्हेनेवर वी आर गोइंग टू हैव this core, because of the buoyancy force, there are tendency that core will be getting broken. So my dear, to avoid that, we are going to provide some metallic pieces to support the core. Some metallic pieces to support the core. These metallic pieces are said to be what? Chaplets. The seat of core is said to be core print. And the metallic pieces to avoid the secondary dendrite formation is said to be chills. And if we are going to have a casting of this shape, To avoid the damage of the corner, we are going to provide some paddings also. Some paddings are also provided here like that at the sharp corners. Is it clear for everyone? So guys, we have seen all the terms very nicely, and moving further to the non-conventional casting process. So if you remember, I already told you, I have given you a 10-step casting procedure. If out of 10 steps, any one step we are not going to follow, we call such process as non-conventional casting. Okay. So my dear, when we are talking about non-conventional casting processes, we are going not with the conventional. You have decided, in my family there have no person who have shown the courage to do the love marriage. I would be doing that. And when you are planning already for that, you are going to go for non-traditional. धीरज, ये आता है नॉन ट्रेडिशनल मशीनिंग में. आप अभी हम पढ़ रहे हैं नॉन ट्रेडिशनल कास्टिंग. Okay, so that will be covered with the metal cutting. So don't worry, that will also be covered. So when we are talking about the non-conventional casting processes, that's great. Best of luck, Sujit, for that. Okay. So my dear, the very first process we are going to study here is said to be shell molding. The very first process is said to be shell molding, and shell molding is used to make cylinder block for IC engines are made by the shell molding process. And my dear, for that what we are going to do, actually we are going to have some cast iron pattern which are also said to be metallic patterns. And my dear, we are going to have this pattern. We are going to heat them. Where we are going to heat them? We are going to heat them in the furnace at this temperature. And when we are going to heat them, their temperature will increase. Then my dear, in a container, we are going to have silica sand plus phenolic resin plus alcohol. Sometimes we are providing alcohol to make the mahol. Okay. No, it is provided for localized heating. Okay. For localized heating, alcohol is provided here. So my dear, when we have this mixture, on this mixture, we are going to provide this pattern here, and with the clamping, we are going to tighten it. Then we are going to invert it. When you will be inverting it on this pattern, when you will be inverting it like this, then my dear, on this pattern, can you feel that this sand will be making the layer? And because of heat of the pattern, it is going to stick. Because of heat of the pattern, it is going to stick. And my dear, you would be having a layer like this. You would be having a layer like that. And you will be removing this pattern from here. And after removal of pattern, you would be having this. This part you would be getting of sand. If two such parts we are going to have, and joining them we are having a cavity. This is made up of sand only. Now my dear, you would be pouring the molten metal into this. You would be pouring the molten metal into this. So when you will be pouring the molten metal into this, my dear, as you are just making the mold with the help of this process. So that's why process is said to be shell molding. And then those shells are going to make the cavity. So they are used to make the cylinder head of IC engines and all. Here good surface finish is produced. And I would also like to tell you one very, very important thing here. One very, very important thing here, that whenever we are going to do this process, whenever we are going to do this process, my dear, this is silica sand plus phenolic resin plus alcohol. This combination is available. And when this shell is produced, it is a weak shell. To make it strong, we keep it in oven at this temperature 300 to 350 so that bonding is formed and it is also becoming strong. And this is the process known as shell molding. I feel everybody understood. And if you want a thicker layer over it, you need to put it for longer time duration. So how much thickness this layer would be having will be depending on the time duration. Is it clear? So this is how we are going to deal with it. Then my dear, we are going to have shell molding is over. Then the second is said to be nothing but the slush casting. So when we are talking about the slush casting is used for, okay, if you want to see, I would like to tell you one thing, that here I have written this entire process. So if you have any doubt, this PDF will be having everything written in the theory. Everything is written. And notes also are provided to you. The application of this process is in manufacturing of cylinder head and cylinder block of IC engine, rocker arms, valve plates of refrigerator. Okay, surface finish produces better than the conventional casting. So why this is non-conventional? Because here we have not made all the 10 step. We were having the pattern. Yes, first step was common. We have make the mold. Yes, we have make the mold. But after that, have we make any gating system? No. Have we make any riser? No. So that is why, as those steps were missing, that is why this process is going to be non-conventional casting process. Is it clear for everyone? Yes. Ashray, okay, if tomorrow you would be having the fluid machinery practice session, then don't worry, I would be shifting it to some other day. There is no problem. Okay, don't worry about that. Because the bigger marathons are going on till Sunday. From Monday onwards, there are small subjects starting. Like when you will be having HMT, industrial, they will be over in 6-7 hours. Okay? Clear? So don't worry about that. Now, my dear, we are going to have the second process, which is nothing but slush casting. So, my dear, whenever we are talking about the slush casting, it is a very, very old process. When we are talking about slush casting, it was used by the ancient kings also when they were having the big ornaments. Have you seen the serial like Surya Putra Kard, Srimad Ramayana going on? Then you must have listened to some other serials like Kunti, like there are some serials Ramayana, Sri Krishna, Om Namah Shivaya, Jai Hanuman. So all these serials, you will see the old kings were shown and they were having heavy ornaments, jewelries in their ears, on their entire body. So those kind of things were made by this process only. Nowadays also the statues of the politicians we are making or of the lords we are making, they can be made by this process. In this process can also be used to make the light shades, can also be used to make the toys for the children's. Okay, so all these are the applications. All those Shaktiman I am not talking about. In Shaktiman those ornaments are not there. Okay, so when we are talking about this, how to make them. So my dear, we are going to produce a cavity like this. And in this cavity, we are allowing the molten metal. In this cavity, we are allowing the molten metal to fill. When the molten metal is filling, you already know that the cooling will be starting from the walls. Cooling will be starting from the walls. And after some time, when the desired thickness of this ornament is produced, we will be inverting it such that the other rest molten metal will go out. And you will be getting the product like this. Similarly, if you want to make a beer toy for a small children, you have make a cavity of this size. This is a beer, and you have filled the molten rubber, and you are allowing it to solidify up to this much only. After this much solidification, you will invert it back. So you would be having this for the children's to play toy. So these are the processes we are doing in the slush casting. As we are not allowing the complete solidification to happen, so this process is also said to be partial solidification. And that is why in this partial solidification, when you will apply the Chemourinov's law, it is directly proportional to V by surface area ka square. If, my dear, we are talking about the thin section, for thin section, volume but a surface area is nothing but thickness. So we can say from here, the solidification time is directly proportional to thickness ka square. So we can say thickness is equals to solidification time ka square root. Okay. I am saying this. Okay. Let me write it again. So when we are going to write it, you can see from here this thickness is directly proportional to solidification time. We can also write it as thickness is C1 square root of TS plus C2. This is the relation between thickness and solidification time. Sometime in the question they will be saying for this much thickness this is the time required. For that much thickness this is the time required. Then find out the time required for this thickness. So whenever they say, first of all, find out C1 and C2 with the given conditions. And after that, you can go for the unknown thickness. So this way, you can get the question on slush casting this year in GATE 2024. I feel because this is the only area from where GATE have not asked in the casting till now. So I have chance that in GATE 2024, you can have the question from here. Clear for everyone? Please tell me that. Clear for everyone? Please tell me that. Okay, guys. Next, we are going to have the investment casting. Next, we are going to have the investment casting. Next, we are going to have the investment casting. So, my dear, when we are talking about the investment casting, then my dear, here we are going to do it only whenever we want excellent surface finish. Like whenever you are going for the turbine blades or surgical instruments. Then we are going for the investment casting process. So when we are talking about this investment casting process, my dear, first of all, we require the pattern of wax. And these wax patterns are made up of centrifuging that we will study after 5-7 minutes. So this is produced by centrifuging. This is a part of centrifugal casting. Okay. Then my dear, whenever we are talking about this, let us say you want this type of instruments, medical instrument, large in numbers. So we are going to put these multiple ones on a pattern tree. So we are saying it tree because it is looking like a tree. So we are making this tree of wax on which these wax patterns are attached like this. Now, my dear, we are having a slurry. And that slurry is made up of silica sand plus ethyl silicate plus water. This is looking like a jelly. We are taking this pattern tree and dipping it a number of times into that until the desired layer over the pattern is going to be produced from this. And when that layer is produced, you can see this layer will be available over the patterns. Layer will be available over the pattern. And when these layer will be available over the pattern, my dear, these layer will be totally covering the pattern and the pattern tree also. We will be going for that much dip when we get the desired thickness. And after that, my dear, I would like to tell you that this entire will be covered by the slurry. Slurry is having high melting point temperature. We will heat the pattern tree. When you will be heating the pattern tree, my dear, the wax will get melt out. And after getting melt out, wherever wax was there, you will be getting the cavity. So my dear, when you are having the cavity here you are having cavity inside, then my dear, you will be putting the molten metal here to fill these cavities. And after solidification, you will be removing these components from the pattern tree and you will be get the final casting product. As you are making the wax pattern, excellent surface finish will be produced, my dear, by this method. Excellent surface finish will be produced by this method. Excellent surface finish will be produced by this method. Is it clear, guys? So moving to the next process. Full molding technique. Next process is full molding technique. If you want to make the complex shapes like motor casing, or you want to make a tool casing, then my dear, we are going to use this process. Is it clear? So whenever we are going for the full molding technique, dear, actually whenever we are giving some name, like if we are talking about investment casting, here the wax is also going to be losted. We also call it as lost wax technique. Good evening, Jyoti Manjan Hans. So guys, like whenever we are going to have a loss of wax, so we also even call it as lost wax technique. So investment casting is also said to be lost wax technique. Is it clear? तो expendable का मतलब ये थोड़ी होता है कि आप ऐसे हीट करके expend कर रहे हो. This is not like that. Okay, actually whenever you are making a layer of the ethyl silicate over that, how you will now expend it? That layer is going to fill it properly. Now the point is, when we are talking about full molding technique, it is used for motor casing and tool casing. So my dear, this is a very interesting process. This is a very interesting process. We are having a cavity like this. We are having a cavity like this. No, dear. That lost wax is different. Okay. Here, my dear, we are going to have, what you are saying is, you can say thermocol, you can say foam, you can say plaster of Paris, whatever you want to use. You are going to make a complete pattern with the gating system and riser of plaster of Paris or foam or thermocol or PVC or polyvinyl chloride, anything, whatever you want, which are having less vaporization temperature. Like I have made this shape. So I would be putting this here. I have put it here. And rest of the part I will be filled with the sand like we were doing in the sand casting. Okay, Dheeraj, you got it now? Is it clear, guys? So now, my dear, as I said, this can be made up of any synthetic plastic, plaster of Paris, thermocol, foam, whatever you want to say. And my dear, now what we are going to do, we are going to pour the molten metal from here. We are going to pour the molten metal from here. When the molten metal will be coming, it is having very high temperature. Because of the very high temperature of the molten metal, this pattern is not going to melt, but is going to convert into gas. And this will be vaporizing and molten metal will be taking the shape of this. Like in the previous case, we have lost the wax. Here we will lose the pattern material permanently because it is going to convert into the gas. Okay, so that process is said to be full molding process. And here you just need to remember the application: motor casing, tool casing. Nothing more than that. Next, my dear, we are entering into very important process, centrifugal. After that, die casting, it will complete. Only two processes are left. So my dear, first of all, we are going to have the centrifugal casting. Centrifugal casting is of three types. The very first one is true centrifugal casting. So when we are talking about the true centrifugal casting, we are calling it true because we are just using the centrifugal force, nothing more than that. Okay, so we are having a circular cavity like this, and in this circular cavity we are going to rotate it at very high speed, 15,000, 17,000, 18,000 RPM, like that. This is the process which is used for seamless pipes, jointless pipe. If you remember, I told you today only about this. So my dear, whenever we are going for this seamless pipe, true centrifugal casting, here it is going to rotate, and at that time you are providing the molten metal from here. A very small angle, like if you see this is making an angle with the horizontal. That theta is very, very small. Theta is 1 degree, 2 degree, that kind of angle. So whatever this molten metal is coming, that will be filling the entire length. Okay, but here as we are using the gravity very, very, very less, so we call it as true centrifugal casting. And my dear, because of the rotation, the molten metal will make a layer, like you are having this opening. So molten metal will be flowing outward, and because of that, this layer will be produced in the outer periphery of the cylinder, like this, like this. And my dear, you know the centrifugal force will be acting onto the metal in the outward direction, which is nothing but m omega square r. Whenever you are using this formula, always use the outer radius. Why we are using outer radius? Because we need to completely full the molten metal in this cavity. So we are using the outer radius always. So my dear, whenever we are going to say that, we are filling the molten metal, and molten metal is automatically going outside because of the centrifugal force acting. And my dear, whenever you feel that desired thickness is obtained, you will stop the flow of molten metal, and still rotation will continue until the solidification will happen. And solidification will happen in that only very good surface finish, not so surface finish, I am saying, very good properties will be obtained. Because my dear, because of this centrifugal force, the heavier impurity will be available on the outside surface, because large centrifugal force is acting, and lighter impurity will be coming inside because of less centrifugal forces. So after the product will be there, you would be removing the material from outside and inside. Machining will be done, and you would be getting without impurity a sound quality product. Here no riser, no gating system. So my dear, whatever the casting you are making, more than 90% of that is fine. You need not to remove the parts. So that is said to be that whenever we are going to define the percentage yield, it is defined as the volume of casting, but a volume of casting plus volume of gating system plus volume of riser. So my dear, percentage yield is going to be more than 90% in this case, because no gating system, no riser is present. And my dear, if someone will ask you what is centripetal force, the centrifugal force, so you know AC is going to be nothing but omega square R maximum. This is how you can find out the acceleration. Multiply this with mass, you will get the force value. Is it clear for everyone? Yes, Surjit, very good. So this is about the true centrifugal casting. Then my dear, the application of this process is in hollow cylindrical pipe, gun barrels, large size bushes or propeller shaft. Then we are going to have the centrifugal casting. Second part is semi-centrifugal casting. So when we are talking about the semi-centrifugal casting, here we are using not only centrifugal force, but also we are using the gravity force. So my dear, here when molten metal will be coming, gravity force will be helping us in filling of molten metal to the center, and then because it is rotating with the omega, molten metal will going to the outward, and you would be having this type of shape like pulleys, flywheel or wheel with the spokes can be produced by semi-centrifugal casting. The last is centrifuging. If you remember, I already told you centrifuging is the process with which we can make the pattern of the investment casting. So here what we are going to have, let us say you want to make the pattern of the investment casting. You are going to have a very big surface, and here you are going to have this is the product you want to make from the investment casting. So you want to make the pattern for that of wax. So you are providing a cavity here to the central sprue. I am showing you the top view. Molten metal will be going down by the gravity action. Then with the centrifugal force, it will be filling in this cavity. Here molten metal is nothing but the molten wax. So in this way, this is also going to rotate. So centrifugal force is there, gravity force is there. And after solidification of wax, we will be removing these four things. Four products are ready. You can also make symmetrical, unsymmetrical, all types of products here. This is used for making the small products large in number. Or it is also used for making the patterns of investment casting. Everybody is clear? Please tell me this is the application of centrifugal. So guys, centrifugal casting is over. Next we are going to have the die casting. Okay, we are slowly about the completion, towards the completion. So my dear, whenever we are talking about this die casting, okay guys, let me take some water. Okay guys, so when we are talking about die casting, so my dear, when we are talking about die casting is, you can say, a kind of permanent mold is provided. When we are going for mass production, it is very difficult to make the new mold every time. So we are making a permanent mold of metal. Okay. And my dear, there are two types. One is gravity die casting, other is pressure die casting. Gravity die casting is used for the simple shapes like aluminum piston. And pressure die casting is used for the complex shape like carburetor. So there are two types, hot chamber and cold chamber. So let us see one by one both of them. First of all, there is a gravity die casting. Here we are going to have this die in two parts. I would like to say this may be the fixed part and this is the movable part. Here molten metal is poured and filled by the gravity action. So with the gravity action, molten metal will be filled here like this. But my dear, when this product will be solidified, you cannot take it out. Now, how you will be taking out? For taking it out, you need to take this part out. That's why we have made this in two parts. So you would be taking one part away, then the product can be coming out. And here also we are providing the ejector rod, which will be pushing the workpiece to go out from the cavity. And my dear, we can make the aluminum piston type of product from this gravity die casting. Then my dear, we are going to have the second type of die casting as pressure die casting. Why we call it as pressure die casting? Because here cavity is filled with the help of external pressure. Here cavity is filled with the help of external pressure, so we call it as pressure die casting. And my dear, here what we are going to have, this is the cavity. This is the molten metal present. This is the ram. So we will be applying the force onto the ram, because of which molten metal will be filling in the cavity. And when the molten metal will be filling in the cavity, this is by external pressure. So even we can go for any level of sectional sensitivity, smaller sections can be filled. That is the advantage of pressure die casting. But at the same time, my dear, why we are saying the cold chamber? Because furnace is separate, casting is separate, cavity is separate. So my dear, we are going to have this as cold chamber because furnace is not the part of this entire setup. Similarly, if the furnace is the part of entire setup, we call it as hot chamber hot chamber pressure die casting. Here furnace is the part of the system. So my dear, here when you would be applying the forces from here, once again the cavity will be filled. The point is hot chamber pressure die casting is advantageous because here molten metal is not coming from far away distance. So molten metal is not coming in the contact of oxygen. Here only metal is melted because of this furnace. So that is why no exposure to atmosphere, no oxidation, very good quality, very good surface finish. So guys, that is why hot chamber pressure die casting will be giving always the good products. But my dear, the point is we cannot use it for the workpiece or material with high melting point temperatures. Why we cannot use that? Because my dear, whenever we are going to have high melting point temperature, this entire setup, including the furnace, is always with the good one. But entire setup we have to make with the material which can withstand very high temperature. So that is not possible. Is it clear? Is it clear? Krishna, this is related to gate. This is related to gate. So then when we are talking about cold chamber is used for the materials with high melting point temperature. Because here we need not to make the setup according to the melting point. No, according to the furnace temperature. Okay, so guys, this is about cold chamber and hot chamber. We have already seen the applications. The last one is continuous casting. My dear, whenever we are going to have a very, very big size bowl, whenever we are going to have a very big size bowl, then if molten metal is present in this bowl, or maybe molten metal is not there, but a big size bowl which is having hole here, we call it as tundish. A big bowl with a small hole, we call it as tundish. So when we are talking about a big bowl with small hole, we call it as tundish. And if we are having the hole here, molten metal will be continuously coming. Die is there to give the shape, and water is sprayed to cool it properly. And then rollers are provided that if the shape is distorted anyhow, then rollers will be making them in the shape, and the final product is coming in the continuous form. Continuous shafts are getting produced by this process. So this is said to be, my dear, the continuous casting process. Is it clear? We have seen all the known conventional processes. Now the last thing, we are going to have the casting defects. So guys, now I would like to ask you, shall I tell you these defects quickly, or will you be covering it from the notes? Because these are the things which you need to mug up, kind of thing. So if you say I am having on slides, it is there in the notes also, in this PPT also. If you want, quickly I will show. Okay. Fine. You can cover from the notes, but okay, I am showing you this very quickly. So my dear, whenever we are talking about the gas defects, so gas defects, we are going to have porosity, blowholes. Whenever we are going to have these small gas defects, they are coming whenever some gases are remained inside, then these types of bubbles are going to produce, and we are calling them as blowholes. And my dear, whenever these are present over the surface, we call it as open blows. and if they are covered with a layer of material, and if they are covered with a layer of material, if they are covered with a layer of material, like we have seen the blowhole, if we are going to have a big hole covered with a layer of material, we call it as blister. And if this big hole is present over the surface, exposed to the surface, we call it as scare. Small holes, blowholes. Big hole, scare. If covered by the layer of material, blister. Which is the layer of material? This layer of material it is covered by. So we call it as blister. So my dear, whenever we are, I get these notes. Krishna, you can get the notes on my Telegram channel, Mechanical by Dheeraj Sardana. There you can get the notes of all the subjects, SOM, TOM, MD, Industrial, Production, you know, all these things. Then my dear, we are going to have porosity and pinholes. That is coming because of the presence of the moisture. If moisture is present, then we are going to have this. Okay. So my dear, you can see all these are the gas defects. Scare we have seen, blister we have seen, pinholes or porosity we have seen. And what are the remedies? So the remedy is the proper permeability. And for proper permeability, either you provide 8% of water content, which give you maximum permeability. Second is you should provide the vent holes to increase the permeability. And third thing, you can add some additives which are improving the permeability. Okay. So my dear, next my dear, we are going to have some other defects like drop and dirt. Like let us say this is the cavity. So my dear, let us say if your cavity molding sand is not having the enough strength. If it is not having the enough strength, because of this, what will happen? Some sand particle may get dropped from here. And if it will be getting dropped from here and collected here, then my dear, this defect we call it as drop. And this defect we call it as dirt. Okay, this defect we call it as dirt. Is it clear? Is it clear, guys? Is it clear, guys? अरे भाई धीरज वो मुझे ही बोल रहा है, आपको नहीं बोल रहा है, ठीक है? Okay. So guys, when we are talking about this is drop and dirt. This is happening if your molding sand is not having good strength. Then my dear, we are going to have cuts and washes. If sharp corners are present, strength is not good, then the molten metal can break these sharp corner. That defect is said to be cuts and washes. Okay. Then my dear, we are going to have the shrinkage cavity. You already know shrinkage cavity. I already taught you where shrinkage cavity is happening. When we are going to have mushy zones, by providing the chills, we can avoid them. Okay. Then my dear, we are going to have some other defects like misrun we have already seen, cold shut we have already seen. Sectional sensitivity I already taught you. All these things we have already discussed. Guys, now whenever we are talking about the fluidity, if you don't want any defect which are coming due to fluidity, there are many ways to improve the fluidity. Fluidity can be improved by increasing the pouring temperature, increasing the viscosity. Viscosity will, whenever viscosity will be increasing, density will be increasing, percentage water will increase. This is the effect. Increase of pouring temperature will increase fluidity, obviously. Then viscosity will increase, fluidity will decrease. Motion will be difficult. Density will increase, fluidity will decrease. Obvious, it will become heavier. Percentage water content will be increasing, fluidity will be decreasing, because more heat will be taken by the water to become steam. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. Then my dear, you can see, okay guys, now these 2-3 defects I am leaving on to you. You can do this from the notes, okay? Because there is nothing to explain there. They are very, like, if I told you this, just by the figure you can say what it is. This is the mold shift, है ना? Because if the clamps are not provided here and here, we may not be knowing whether the mold is set or not. So we are going to provide them so that there is no mold shift happen, है ना? So that's why it will be better if you go by yourself for these things. Very good, guys. So I feel we have seen all the defects. This is the core shift. If core will be getting shift, previously you were making the cylinder with hole here, and my dear, here if this is shifting, hole will become here. So this is the core shift. Why this is happening? If buoyancy force is more, if you want to avoid this, provide the chaplets. We have discussed this already. Okay. Okay, these are the additives. Wooden floor or wooden saw, lakdi ka burada, improves collapsibility and permeability of the mold. Linseed oil, dextrine improves the hardness. Graphite improves refractoriness. Coal dust improves surface finish. So these are the additives we are using to improve the properties. Okay, is it clear, guys? So with this, we have completed the casting. Okay, welding and casting are over. Now, my dear, here I would like to ask you an important question. We have completed casting and welding, that's for sure. Okay. Now we have one option. Either we will take a small break and we go for the sheet metal operations. And there is one more option. If you want, we can go for metal forming and sheet metal operation, both the topics with material science also. So choice is yours. If you have बची है अगर हिम्मत तो बचाइए, ठीक है. हिम्मत नहीं है तो कोई बात नहीं. We can do that with the material science also, because material science would be a very small topic. So there, if you want, we can go for metal forming and sheet metal operation there also. Sheet metal operation is 1.5 hours topic around. Yes. Okay, so enjoyed casting welding or not, everybody? Please tell me. 8 घंटे हो गए हमें पढ़ते हुए. Ajay, he's saying धुआं धुआं, not धुआं धुआं. Okay. Fine. So guys, अरे धीरज तुम इतना परेशान मत हो. तुम आज सिर्फ आज के लिए आए हो क्या? है सिर्फ आज के लिए आए हो क्या? Dear, this marathon series is not for one two topic. This is for entire mechanical engineering subjects. Okay, we have covered already SOM completely, FM completely. Okay, and production we have divided into the parts. Like today we have done casting, welding. I have added sheet metal operations. Then my dear, second part would be having metal cutting, metrology and metal cutting, metrology and sim. Third part is material science plus metal forming. These are the 3 parts we have decided. Okay, on Saturday we are going to have theory of machines. On Sunday we are going to have machine design. So all these things I am going to cover. SOM is already over, FM is already over. This was the 3rd session. This will be on Saturday, Sunday. Then we have these 2 sessions also. Yes. Don't worry. Everything will be covered. Now everything would become strong. Okay? Fine. Okay, so how much time break is required then? How much time break is required? How much time break is required? धीरज इंडस्ट्रियल पढ़ लेना. इंडस्ट्रियल तो यार मुश्किल नहीं है. इंडस्ट्रियल तो सिंपल है. इंडस्ट्रियल तो स्कोरिंग सब्जेक्ट है. Okay guys, so right now the time is 6 p.m. We would be meeting by 6:25. Okay, so I'm writing this here. Okay, let us do 6:30 p.m. only. Yeah. Okay, and we will be completing it by 8 p.m. Okay, don't worry about that. Is it fine for everyone? हाँ 20 seconds are over. Okay, so let's start. अरे मेरा सोचो मैं खड़ा हूं यार इतने घंटे से. Okay. हाँ ऋषभ, उसको हम कल शिफ्ट कर रहे हैं. ठीक है, मैं अभी करवा देता हूँ उसको. ठीक है, सो उसको हम 2 बजे करवा दें कल दोपहर में. कोई दिक्कत तो नहीं है? मुझे आइडिया नहीं था कि इतना टाइम खिंच जाएगा. विल इट बी फाइन ऋषभ? क्योंकि यहां पर भी आप पढ़ ही रहे हो. ओके फाइन फाइन. चलिए मिलते हैं 6:30 बजे. Yes, guys. Shall we start now? Are we ready, everybody? So sorry for the 5-minute delay. Yes, everybody, please tell me. Let me share it once so that those students. Okay, guys. So now we are starting the third topic, sheet metal operation. Okay, just give me a second so that मैं थोड़ा हल्का हो जाऊं जैकेट हटा के. Okay, guys. So my dear, whenever we are talking about the sheet metal operations, when you see the syllabus of GATE, good morning. When we are talking about the syllabus of GATE, in the metal forming, we are having bulk metal forming operations and we are having sheet metal operations. We are having bulk metal forming, we are having sheet metal operation, and bulk metal forming we will be having with the material science. In the bulk metal forming, we study rolling, forging, extrusion, wire drawing. Okay, so guys, Hari Sandhu, today there is no practice session actually. Chandra sir was busy, so that's why Chandra sir would be taking practice session tomorrow. Okay, so when Chandra sir would be taking tomorrow, I will be taking day after tomorrow. No issues. Okay, so be ready, just come up with the revision. Okay, so guys, now we are talking about the sheet metal operations. First of all, when we call a operation to be a sheet metal operation, if it is going to be performed on a sheet, and when we are talking about the sheet, we are talking about something which is having thickness less than 6 mm. There are two types of operations which are performed on the sheets. One is going to be sheet metal forming operation and other is sheet metal cutting operation. So my dear, whenever you are going to have the induced stresses to be more than the yield strength and less than the ultimate strength, we call it as sheet metal forming operation. Someshwar, Som session already have completed. Yesterday we have taken strength of material practice session. Yesterday already we have taken. You can see that. Yesterday it was already over. Now tomorrow you will be having for fluid mechanics. Okay. Today there is no practice session. Okay. So already yesterday we have taken by yesterday 11:30 PM session was there. You did not attend perhaps. Okay. So guys, when we are talking about the induced stresses, if they are more than yield and less than ultimate, then we call it as sheet metal forming operation. And if the stresses are coming out to be more than the ultimate strength, more than the ultimate, then we are going to talk about them as sheet metal cutting operations. Yes. Is it clear? So when we are talking about this sheet metal forming and sheet metal cutting, in sheet metal cutting we have blanking, punching, shearing operation, and in sheet metal forming we have deep drawing, we have bending operation. So these are the operation which we will be discussing here, and we will totally be going as per the GATE point of view, because these marathons are keeping GATE in mind. Is it clear for everyone? So we are moving further, guys. when we are talking about planking, punching, first of all, we will discuss sheet metal cutting operation. Then we also have some miscellaneous operation to be discussed. So first of all, we will be having the blanking and punching operation. We are going to have blanking and punching operation. So my dear, for both these operations, the setup is going to be exactly same. For blanking and punching operation, the setup is exactly going to be same. Actually, we are having a punch like this. We are having a punch like this. This is the sheet we have. This is the sheet we have. And we are going to have the dies like this. We are going to have dies like this. And my dear, if we are going to see the difference between punch and die, that is said to be radial clearance. We are calling this radial clearance by C. Now, my dear, whenever we are going to have clearance, radial clearance as less than 10% of sheet thickness, less than 10% of sheet thickness, Shreya, according to me, there should be 2 marks from welding, 2 to 3 marks from casting, 2 marks for sheet metal operation. So that is having 4 plus 3, 7, 6 to 7 marks today's session will be covering. Material size would be having 2 to 3 marks. Metal cutting will be having 4 to 5 marks. Bulk metal forming 2 marks. Okay. And metrology 2 marks. Sim 2 marks. So approximately 18, 19 marks production should be there. Okay. So now, my dear, whenever we are talking about the clearance is less than the 10% of sheet thickness, then, my dear, this operation is going to be either blanking or punching. Why I am saying like that? Because, my dear, when this punch will be coming down and when this punch will be reaching to this location like this, then, my dear, you tell me, if you are going to provide the space here only which is 10% of the thickness, if I say you that you sit at a place where I will be providing you 10% of the space required for you, will you be able to sit there? No way. When you are going to sit 3 in the seat of 2, on the bike when you will sit 4 in the seat of 3, 4 in the seat of 2, then also 50% is managed. You are not going to manage 90%. So the point is, if the sheet thickness is T and you are going to provide the clearance less than the sheet thickness of 10% of sheet thickness, then, my dear, when the punch will be coming down, there will be no option for the sheet. Ultimately, sheet have to break. And how this will happen? When your punch will be reaching to this position, when your punch will be reaching to this position, initially you would be providing some compressive stresses. Initially, you would be providing the compression. So when you would be having the compression, some penetration will be happening in the sheet. So after that penetration, my dear, then it is punch will try to go down. Then sheet have no other option but to get cut. And this sheet, if you want to see, actually is a circular in cross section. So if this is the sheet and you are going to provide a hole like this into this, so when you will be producing this hole, obviously that kind of disc will be coming out as a product. And this product is said to be the blank. So finally, from this process, we get 2 types of product. One product is this disc. Other product is this disc with hole. So my dear, when you are getting these 2 products, the point is, out of these 2, you are looking for one. Because when you are using the chappals, footwear, they are cutted from a total rectangular block of rubber. And from that, like you are going to have a total rectangular block from which you are going to cut the footwear. Likewise. So when you are going to have this rubber block from which you are taking these parts out, then these things are your product, na? whatever you are left with this block with hole is useless. So similarly, if this is your product, the operation name is blanking. And when the blanking is the operation, this is our product, this is the scrap. And if this is your product and this is scrap, then the process name is punching. And we also call it as piercing. So we are using both the words punching and piercing. They both have same meaning. So my dear, the point is, for punching and blanking we can study together only. The only thing is, the difference is only in the type of product. If your product is this, we call it as blanking. If your product is this, we call it as punching. Is it clear for everyone? Yes, guys. So my dear, now we have already seen if C is less than the 10% of sheet thickness, when clearance will be more than the 90% of the sheet thickness, then this operation will become deep drawing. Okay, so that we will see after some time. First, let us concentrate on blanking and punching. Okay, now my dear, I would like to tell you, actually whenever we are going to have this punch size, this is the punch size. So I would like to tell you that punch is closely associated with the hole. And whenever you are going to cut, obviously, if this is the sheet, you are going to make a cut, punch is coming like this. So initially some plastic deformation are going to happen. So because of plastic deformation, you know, sizes will be changing. So first plastic deformation will be happening, and finally you would be having the fracture in the sheet. And that's why this blank will be coming out. So as this is coming after plastic deformation, its size will always be more than the punch size. So initially when it is going to happen, I am showing you some diagram which will give you a clear picture. Like whenever initially we have the sheet like this, after some time, when the punch will be reaching to this location, sheet will take this shape. Can you feel it? So some plastic deformations are going to happen. And then my dear, obviously after some time here breaking of bonds will happen. Because of this only the blank will be coming as a final product. So I would like to tell you that when we are talking about hole was produced like this. So hole size is associated with the punch size. And the blank size is associated with the die size. You can see very easily that die is always kept bigger than, this is the die size. And this is the punch size. You can also write here that die size is going to be equals to punch size plus 2 times of radial clearance. And if someone is asking you the hole size, it is equals to the punch size. And if someone is asking you the blank size, you will be calling it as the die size. And the reason for that is plastic deformation. Clear for everyone? The reason for that is plastic deformation. Yes, Ajay, hello, how are you? So the reason for that is plastic deformation. And my dear, whenever we are talking about these 2 types of clearance, C is the radial clearance. I already told you. Okay. So guys, this is how we can see the association with die size, punch size and all. And this is how we are going to define it. So many times question have been asked from this, that they will be giving you one size out of this, and second they will be asking you. Now my dear, I would like to tell you, whenever we are having the operation to be blanking. So obviously if I want to make a blank, I would be aware of the blank size. So you would be aware of the blank size. Blank size is nothing but the die size. So my dear, if you are going for blanking operation, blank size or die size will be known to you, and you can find out the punch size by subtracting 2 times of clearance from the die size. This is said to be that in blanking operation, we are finding out punch size with the help of clearance. So we will call in blanking operation, clearance is provided over the punch. clearance is provided over the punch. Means which we don't know, we are saying clearance is provided on that. Is it clear for everyone? Clear for everyone? Shovik, I am not saying blank is die. I am saying whatever blank is coming out, that is equals to the die size. Die is having some hole, na? First of all, listen to me what I am saying. This is the die size. So because of plastic deformation, this blank is taking this size actually. That is what I want to say. Even for easy removal, sometimes we are putting the dies like this. Like this. So this is actually the die size. Okay, this is actually the die size. Now you are putting the sheet over it. And then you are going to pass a punch from here. When this punch will be coming, then you would be getting a blank. And this blank size and die size will be equal. That is what I want to say. Shovik, you clear now? Are you clear now? Shovik, are you clear now? Shovik, are you clear now? This is about the die. And I would like to tell you, like, if they are not giving clearance, but clearance is required, then optimum value of clearance is 0.0032 times of thickness into ultimate value of shear strength. This is for the optimum value of clearance. So we are going to say clearance is provided on the punch or die. I have shown you, once again I am showing you. Clearance is provided on the punch in the blanking operation, and clearance is provided on the dies in punching operation. Why? Because if you are going for the punching operation, then you would be aware of the hole size. Hole size is punch size. So you are knowing the punch size, then die size can be written as punch size plus 2 times of clearance. Here I will be saying that clearance is provided on the die. The point is, whatever is not known, clearance is provided onto that. Clear for everyone? So guys, do like and share the session. You can say more than 8 hours are over for this session, and session is still going on. This is possible because of viewers' energy. Yes. Is it clear for everyone? So this is going to be, my dear, something. Clearance is provided onto the punch in blanking operation, onto the dies in punching operation. Okay. Okay, guys. I have given you the formula for optimum clearance. Okay, that we have already discussed. The same things are written here. Okay. This is the question now. Let us see how many of you give the right answer to the question. A metallic disc of 20 mm diameter is to be punched from a sheet of thickness 2 mm. Radial clearance is 3% of the sheet thickness. Find the required diameter of punch. Let us see how many of you give the right answer for this. This is the gate question only. Solve it, guys. Solve it. Solve it, guys. Yes. So guys, they are saying a metallic disc of 20 mm diameter is to be punched. Never see these type of word, is to be punched, is to be blank. Forget about that. What they are saying? They are saying 20 mm diameter disc. 20 mm diameter disc is always a blank. So this size given is for blank. I don't know whether the operation is blanking or punching, but the size given is of blank only. Because 20 mm disc can be a blank only, na? Okay, so we are knowing the blank size, which is nothing but the die size, 20 mm. And they are asking me the diameter of punch. You know that punch size is die size minus 2 times of radial clearance. 20 minus 2 times of radial clearance. It is 3%. 3% means 0.03 into thickness is 2 mm. It is 19.88 mm. Everybody is clear? Very good. Vinay, very good. Farindra, very good. Abhi, very good. Shreyas, very good. Neeraj, Darshan, everybody. Surjit, bahut badhiya. Okay guys, that's great. So this is about... Now my dear, we are going to talk about the force requirement for the punching or blanking operation. So my dear, whenever we are going to have a body like this, which is having a thickness of T, ultimate shear strength is tau ultimate. Now my dear, we are having a circular punch and we want to create a hole into that. So we are going to have a hole of diameter D. For that we will be having a punch. Okay. So when you will be producing this hole, what is the force requirement? So force requirement in blanking and punching is nothing but the shear strength tau ultimate into what is the shear area. Here shear area is nothing but pi dt. So this is going to be the blanking or punching force required. This is said to be blanking or punching force required. Then my dear, after this we are going to have a shearing operation. After that we are going to have a shearing operation. This time we are going to cut it from here, let us say. If we want to cut it from here, like this. This is the width W, this is the thickness T. So this time this area is said to be the shear area. So my dear, shear area is here W into T. So let us say, like whenever you are cutting the cake, let us say this is the body I want to cut, I have a knife. Then this operation is neither blanking nor punching, this is a shearing operation. So when I will be cutting like this, shear area will be W into T for this. So when shear area is W into T, what you will be answering? You will be saying that the force required in shearing is tau ultimate into W into T. So that's why we are covering 3 operations together, blanking, punching and shearing. Everybody is clear for this? Please tell me that. Everybody is clear for this? Please tell me that. Yes, Sumit, Rishabh, everybody. Okay guys, so I have already given you these formulas. Now we are moving to the next thing, that is the work done. That is the work done. That is the work done. So my dear, whenever we are going to have this sheet, on this sheet we are going to have first of all a punch is coming like this. When punch is penetrating, initially some compressive stresses are produced. Because of this, what will be happening? As we are going to have dies here. As we are going to have dies here. So you would be having this to have this shape. Like this. Okay guys. Neeraj, WT means the shear area. So my dear, now what is going to happen? So after some penetration, now my dear, I am considering this part separately. This part separately. Initially we were having this. And punch was coming like this. Because of punch, you can see here the bones are extended like this. Bones are extended like this. Now, my dear, if you are going to continue this force and punch is going to go down, then my dear, from here the bonds will be breaking. When the bonds will be breaking, you can see this part, this fiber will be reaching at this location. And obviously this fiber will be reaching at this location. When all these fibers are traveling, my dear, can you feel when all these fibers are traveling, then all the fibers would be breaking the bonds at one instant. So after moving P distance penetration only, the entire blank will be getting separated from the body. For that, this tool need not to travel the complete distance. So I would like to say P is the penetration which is required only to cut the sheet. So if you want to write down the expression for work done, I would be writing it as F into P. Here P is the penetration. You can also write P as equals to K into T. Here K is penetration to thickness ratio. Everybody understand, guys? This is the formula for the work done. And my dear, whenever we are talking about the work done is the energy required to get fracture, which is not going to be changed. It is the property of the material. So this is the expression for work done. Now, my dear, there are something we are going to study. That is nothing but work done we have already seen. Here we have assumed the force to be constant for the entire penetration. But in reality, force is not constant. Initially, force is increasing, then becoming constant, then decreasing. But my dear, we are considering it to be a rectangle. This is our ideal assumption. This is the reality. But don't worry, for calculation purpose, we will go with ideal only. So you will write work done as force into KT. Is it clear for everyone? Then, my dear, there are some ways by which we can reduce the force requirement in blanking and punching. What are the various ways where we can reduce the force requirement in blanking and punching? So there are two major methods in that. The very first method is by providing the shear. Very first method is by providing the shear. What is that providing of shear? We know that work done is force into penetration. Why we want to reduce the force when we cannot reduce work done? The energy can neither be created nor destroyed, you know. So whatever energy required to fracture a material, we cannot change that. Then what is the benefit of changing the force? Because, my dear, whenever I am applying some force onto workpiece is also applying the same force onto me. So if punch will be applying 10 Newton to the workpiece will be applying 10 Newton to the punch. So, my dear, if you will apply more force will be coming onto the punch, which will affect the life of punch. So if we want more life for punch, we will apply less force from the punch onto the workpiece. So that is why to reduce the force, we need to increase the penetration. So for that purpose, the very first thing we are going to do is by providing the shear. So here what we are going to do, we are going to make the tool or the punch like this. Yes, it is circular in cross section only, but we have provided it in this shape. What would be the benefit of this shape? I am showing you that. So when we are coming with this shape, what is the benefit? Now you can see initially this is the punch interaction starting at a point. Then after some this, then this. So my dear, this time when the punch will be reaching at this location, and even when the punch will be reaching at this location, then finally the entire cut will be produced. So because of this, the punch have to travel a large amount of distance. So as you have increased the distance traveled, work done is force into distance traveled. Force will be getting reduced. So my dear, this time if you are going to equate, when we provide the shear, Fs is the force provided. It is Kt plus I is going to be equals to F into Kt. So from here you can find out the shear force. It is going to be F into Kt divided by I plus Kt. Here I is the amount of shear. This is going to be the formula for the shear force. You can see as I plus Kt is going to be more than Kt, so shear force would be lesser in. And when the shear force will be reducing, obviously the life of punch will improve for sure. Clear for everyone? This was the methods to reduce the force in blanking and punching operation. Is it clear? Yes, Sujit, but major reason is the life, because life is improving. That's why economy is improving. Life is closely associated with the life. Sorry, economy. Is it clear? Yes, work cannot change. Work done is the energy required to go for fracture. So my dear, when we are going to have the fracture, the energy required for that we cannot change. That is the property of the material. Abhi here K is penetration to thickness ratio. Like you have seen, whenever your punch is starting cutting, first it is going to penetrate the sheet, like it is going inside the sheet first. After that only the cutting will be starting. Is it clear Abhi? Sachin is asking, sir, इसमें plate का bending हो जाता है? हाँ बिल्कुल होता है. And that is why whenever we are going to provide this punch, this shear on the punch, this we are going to provide in the punching operation. Why? Because in punching operation, whatever the blank is coming, that is of no use for us. Because if you are having a sheet and punch like this, obviously when your punch will be reaching to this location, at that time your sheet would be bended. Your sheet would be bended like this. Okay, I'm showing it on the next slide. So if I am having this as a sheet, and if we are going to have a punch like this, then you know that whenever the cutting is going to take place, this is the sheet which is about to cut. So you can see this is already bent like that. So my dear, that is why we are never providing this shear on the punch in blanking operation. Shear is provided on the punch in the punching operation. So shear is provided on the punch in punching operation. Because when shear is provided over the punch, the blank is of no use. If we are going for the opposite operation, when we are going for blanking operation, then shear will be provided on the dies. We will be providing the gap between the dies. Now punch is same, but dies are having the difference of height. So because of that, maybe the punch is same, but operation will happen in the same way. Because when it will be cutting, once again, cutting will happen point by point. Why we are providing the shear? The target for that is कि whatever cutting previously happening at the same time, now it will be happening point by point. Previously entire surface was cutting. Now point by point cutting is going to take place. Clear for everyone? Neeraj, Abhi, Surjit, Sachin, thick skin. Is it clear for everyone? Clear for everyone? Clear for everyone? नीरज नहीं, अब नहीं होता ऐसा. Okay, because this time you have tilted the sheet ना. This time you have tilted the sheet. Previously you have tilted the tool. That is the problem. Is it clear? अब क्यों होगी sheet? Sheet रखी ही ऐसे है ना. Clear for everyone? So guys, whenever we are talking about this, there is a very important point I would like to give you here, that whenever we are going to have blanking operation, on the dies we provide the shear, and whenever we have the punching operation, on the punch we are going to provide the shearing operation. Now my dear, we have seen the one way. Second way I will also tell you, but before that let us have a discussion. Let us have a discussion on what minimum size of diameter we can produce from blanking and punching operation. So my dear, whenever this punch is going on to the sheet, you already know the force applied for fracture is, you know, tau ultimate into pi dt. This was the force. This was the force. So whatever force punch will be applying on the sheet will be applying on the punch. So if you are going to consider the punch separately, on the punch sheet will be applying a compressive force like this. And that force will be magnitude wise equals to tau ultimate of the sheet into pi dt, because this is the reaction force coming because the same force have been applied by punch onto the sheet. So the same will be coming from the sheet onto the punch. Now my dear, to resist this force, because this force is trying to crush the punch, so punch will be showing some resistance like this, and that resistance of the punch will be nothing but sigma c into pi by 4 d square. This resistance should be equals to this force, otherwise this punch will get crushed. If you want the punch to remain same, no plastic deformation, no fracture, then my dear, this bursting force and resisting force should be equal. So you would be equating tau ultimate of the sheet into pi dt is equals to pi by 4 d square into sigma c for punch material. So you can see this is for sheet material, this is for punch material. So you know dd will get cancelled out, pi will get cancelled out. So you would be having the final expressions as the minimum diameter which can be produced is 4 times tau ultimate into T divided by sigma CR. This is the minimum diameter of hole which can be produced. Why minimum? Because this is the bursting force, this is resisting force. You would be going to say that resistance should be always more than or equals to. So diameter should be always more than or equals to. That's why we are saying this as minimum diameter. Any doubt if anybody is having, you can ask. So guys, we got the minimum diameter expressions as this is 4 times of tau ultimate into thickness by sigma CR. Clear for everyone? अरे उससे पहले करने की कोशिश करेंगे यार, अब तुमने ही कहा सर पढ़ना है ठीक है, ये तो हो गया ब्लैंकिंग एंड पंचिंग, तो अब बचा ही क्या है? मेरे ख्याल से तो 8 बजे तक ही हो जाएगा, 8 बजे तक ही हो जाना चाहिए। डीप ड्रॉइंग आ गया, देखो ब्लैंकिंग पंचिंग खत्म, बचा ही क्या है? डीप ड्रॉइंग और बेंडिंग। शीट मेटल कटिंग हो गया, शीट मेटल फॉर्मिंग पे आ गए, 8 बजे तक हो जाएगा, इतना बड़ा चैप्टर नहीं है ये। ओके मैं तैयार नहीं हूं भाई मैं थक गया हूं ओके डिजाइन सब्जेक्ट में चल जाता है 12 घंटे, प्रोडक्शन बड़ा बोरिंग लगता है 12 घंटे बच्चों को, बट मुझे बड़ा अच्छा लगा कि आप सुबह से पढ़ रहे हो एंड यू हैव गिवन ए वंडरफुल रिस्पॉन्स। आई एम हैप्पी विद दैट। ओके यस, सो गाइस नेक्स्ट इज द डीप ड्रॉइंग ऑपरेशन। Deep drawing operation is a sheet metal forming operation where induced stresses are going to be more than the SYT, but they are less than the SUT. And my dear, whenever we are talking about this, it can be deep drawing or shallow drawing. For that, I will be showing you some wonderful figures here. If we are talking about deep drawing, when we are talking about deep drawing, you can see that we are going to make that kind of thing. Initially you are having a blank which is getting converted into this type of glass. That is the process of deep drawing. And my dear, when we are going to say deep drawing operation, how it is going to be performed, this is the setup. Sujit, actually whenever we are talking about punch, it should not be brittle material, because brittle materials, if it would be fracture very soon, na? So why would we would be using the brittle materials? Okay, but as I said, ductile and brittle are relative properties. Yesterday I told you in the SOM, they are relative properties. So if you are talking with respect to workpiece, yes, maybe, absolutely there is nothing like that. Okay, so when we are talking about this, you know that this is the sheet kept and this is the punch coming, and this time the clearance is found to be more than 90% of the sheet thickness, because this time we don't want to cut the workpiece. This time we want the operation which would be happening like this. I am showing you this. This time we want the sheet to bend like this, and sheet to deflect like this. So my dear, if you are providing 90% of the thickness gap here, then sheet can adjust itself. Like if there is a seat of 3 persons, okay, then my dear, in that 3 person, a small children which is requiring very less space can be adjusted. If you are getting 90% of the space you require, you can adjust there. But with 10% you cannot. So that is why, because of that adjustment, this time this sheet will not get cut. This sheet will choose to go down with the punch and will be giving you this shape of product. I feel this diagram is self-explanatory. Am I correct? Am I correct? Am I correct? So guys, whenever we are talking about this deep drawing operation, here the major questions are coming. Here the major questions are coming from the sheet metal operations. So whenever we are talking about this, here I would like to tell you that deep drawing and shallow drawing can be the 2 types of drawing. You can see that we are making a product. We are having this as blank. Then we are going to convert it into this product. This is the height, this is the diameter. Initial diameter was D. You can also convert it into a product like this, where this is the height, this is the small d. So my dear, depending on whether you are going to go for more heights, we call it as deep drawing. If we are going for small heights, we are going to say it as shallow drawing. And here it is mentioned, when the ratio of depth of the product to its diameter or the smallest dimension of its opening is greater than 1, the process is said to be the deep drawing. Otherwise, we will be calling it as shallow drawing. So that is totally depending on what is the ratio of H by D. Okay, if H by D is more than, then we will be calling it as deep drawing. Is it clear? Clear for everyone? Clear for everyone, guys? Clear for everyone? So my dear, if you want to avoid the sharp corners produced in the deep drawing process, then we are going to provide some corner radius also, and we may make the punch like this. Then we are going to provide some corner radius to avoid the stress concentration effects. Okay, that also we can do. But the point is, what kind of questions will be coming, that we are going to discuss here now. Let me show you the type of question which will be coming. Okay, just wait. We have seen this. Okay guys, these are the applications what we can make from the deep drawing operations. This, you know, the kitchen utensils. Okay, you can see this. These bodies here also deep drawing would be done. Automation of the body. So all these are the applications of the deep drawing operation. So it is a very, very important process. My dears, whenever we are talking about the deep drawing operation, every time it is not going to be completed in one step. Sometimes it go in multiple steps also. But my dear, the very first type of questions which will be coming from this process, they are on the blank diameter calculation. They are on the blank diameter calculation. When we are talking about the blank diameter calculation, let us say we are going to have a blank like this. And I want to make a glass like this, which is having D as the diameter and H as the height. In other words, you can imagine, let us say a customer is coming to you and that customer is saying, ki, sir, I want 1000 glasses of this size. When that customer is coming, 1000 glasses are required like that. You will say, okay. So you are going for the operation, you would be having the dies. So for that, you need to decide how much diameter die I should use to make it. Then what you will be doing? You are just going to just equate the surface area. Pi by 4 d square is equals to pi by 4 small d ka square plus pi dh. My dear, pi will get cancelled out. And you would be getting d square as equals to d square plus 4 dh. And from here, d would be coming out to square root of d square plus 4 dh. This is the very first type of question coming in the GATE exam. Put the D and H, you will get the answer. This is the very first type of question which will be coming to find out the blank diameter requirement. Clear for everyone or not? Please tell me that. Clear for everyone or not? Please tell me that. Clear for everyone or not? Please tell me that. Okay, guys. Now, my dear, you can see whenever we are going for, yes, Divyansh, good evening. Whenever we are going for the deep drawing operation, it is not a single pass operation. It is a multi-pass operation. Generally, it is performed in multiple passes. Okay, so for that, we should also know how to calculate the number of passes. Okay, so let me show you some space and there we would be talking about. Okay, let me take some space. Yes, first of all, we are talking about the blank diameter requirement. You have seen, if I want to make a cup like this, if I want to make a hemisphere cup with radius R, then if I ask you what would be the blank diameter requirement, you need to have this as the diameter D. We want to find out the D. How you will find out? Yes, Danish, do you want to ask or you want me to do? You can try this. How you will be doing? Equate the surface area. Pi by 4 capital D ka square is, what is the surface area of hemisphere? 2 pi r square. Solve this and find out the relation between D and R. So guys, are you ready for the practice session now on Saturday? Tomorrow you have practice session for fluid mechanics. So on Saturday or Sunday, would you be ready for the practice session on production? Everybody, tell me the answer. What you would be getting as capital D. Customer is coming, I want a bowl of radius R. Very good. So be ready with the revision. Because we will be doing questions from casting, welding, sheet metal operations. 25 questions on 3 topics. Saturday, Sunday we will do. Sayak Nandi, very good. So my dear, from here, can we say D is equals to what? Can we say D will be equals to 2 root 2R? Can we say D is equals to 2 root 2R? Very good, very good, very good. Bahut badhiya, Sumit. So moving further, guys. Now we are talking about Krishna time will be announced. Generally, we are keeping it in the midnight 11:30 p.m. I generally prefer that time. Okay. Rest, you just be on my Telegram channel. There you will get the link of that. Okay. Yes. So when we are talking about the number of, or you subscribe the channel, then also you will get the notification. So number of draws calculation we are going for. As I already told you, initially you have a blank like that. In the first draw, you made this. In the first draw, you made this. In the second draw, you made this. Third draw, you made this. So likewise, how we would be finding out the number of draws required. So to find out the number of draws required, there are 2 methods. One is said to be LDR method. LDR is said to be limited draw ratio. It is telling us how much maximum reduction is possible, and this is taking an assumption that every draw will give you the equal reduction, which is a theoretical assumption. In practical, it is not possible to have the same reduction every time. But in the gate, if they give you LDR, you need to follow that. Let us say they are saying that I want to convert a 250 mm diameter blank, and we want to convert it into, let us say 50 mm. This is the D. This is the capital D. So if this is the diameter given for the blank and we want to make a cup of this much diameter, then my dear, how we would be finding out the number of draws? And let us say we are given that LDR is 2. Generally, LDR is given between 1.6 to 2.3. Let us say LDR is 2. So, my dear, when you will go for the first reduction, let us say D by D1. This is going to be LDR. So, from here, you know capital D is 250. D1 will be coming out to be 125. Then, when you will be going for the second reduction, D1 by D2, you will be putting it as, you would be writing D1 by D2 as equals to 2. This will give you D2 as 62.5. Now, my dear, if you would be having D2 by D3 is equals to 2. From here, you will get D3 is going to be 31.25. But we need to reach only up to 20, only up to 50 mm. So, first reduction will give you 250 to 125. Second reduction will give you to 62.5. Third reduction can give you up to this. Because LDR is the maximum reduction possible. Don't go for maximum. We will be holding it till 50 only. So how many reductions? First reduction, second reduction, third reduction. So the number of draws are 3. Please tell me everybody understood or not. आश्रय वो भी आ जाएगा यार. अब तुम्हारे सामने पूरा दिन तो पढ़ा रहा हूँ. कब अपलोड करूँ? एक्चुअली उसमें थोड़ा सा एडिटिंग का काम है. कल मैं फ्री रहूंगा तो मोस्ट प्रोबेबली कल करके संडे से पहले पहले आ जाएगा. ठीक है, बिफोर संडे इट विल कम. ओके, सो इज इट क्लियर फॉर एवरीवन? नंबर ऑफ ड्रॉ कैलकुलेशन इज क्लियर फॉर एवरीवन? प्लीज टेल मी दैट. नंबर ऑफ ड्रॉ कैलकुलेशन इज क्लियर फॉर एवरीवन? प्लीज टेल मी दैट. यस. सो माय डियर, इफ आई आस्क यू फॉर डक्टाइल मटेरियल और ब्रिटल मटेरियल, which material more number of draws are required? For ductile or brittle, which material will require more number of draws? Ductile or brittle, which will be requiring more number of draws? Ductile or brittle, which will be requiring more number of draws? Ductile or brittle, which will be requiring more number of ductile or brittle, which will be requiring more number of draws? My dear, just think it. Ductile materials are those which can easily deform. So they will give you maximum reduction in that single draw. So that is why brittle materials are giving small reductions. So if you want to convert 150 into 50, maybe in the 2 times only ductile material will go, and 20 times maybe you need to go with the brittle. So ductile would be requiring less number of draws and brittle would be requiring more number of draws. Here it is written also, ductile needs less number of draws, brittle needs more number of blows. Is it clear? That is written also. Is it clear, guys? So this is the one way. But every time LDR may not be given. Okay? Yes, yes. So my dear, whenever we are going to have this, sometimes we need to take care of one more thing. But before we go for that, there is a question in front of you. Just try to solve it. Find out the diameter of blank required to make a cup of 100 mm diameter and 100 mm height. This is the GATE previous year question. Solve it. Find out the blank diameter calculations. Find out the blank diameter calculations. Find out the blank diameter calculations. Yes, solve it, guys. And do like and share the session, guys. Darshan have given the answer actually. So you can write capital D. D square plus 4DH. 100 square. So 223.6 is correct. Parth, your doubt you ask on the Telegram separately. If required, we will discuss on that. I didn't get what is your doubt because we are in the deep drawing now. You are late. Okay. You share your doubt on the Telegram. I will take it separately. So number of draws calculation, I already told you the LDR method. The second method, my dear, is, okay, first solve this question also. Calculate the number of draws required to produce a cup of height 10 mm, diameter 5 mm. LDR is 1.6. I am fine, Kalpesh. How are you? So guys, we are having a previous student, Kalpesh. He have already performed very nicely in the exams. Yes, Kalpesh, कैसे आप? थोड़ा मोटिवेट करो अपने जूनियर्स को. Yes. What would be the answer, guys? I am also fine, Kalpesh. So when we are talking about, guys, first of all, you need to find out the blank diameter. They have not given the blank diameter. Okay. So first of all, we need to find out the blank diameter. And what will be the blank diameter? They have given diameter 5 mm, height 10 mm. So d square plus 4dh. Diameter is 5 ka square plus 4 into 10 into 5. 25 mm. And the final diameter you need is 5 mm. You need to go from 25 to 5. LDR given is 1.6. Okay, yes, this is 15 actually, no? 15, not 25, 15. So when it is 15, first of all, you will go for the first reduction. So D1 will be D by 1.6. 15 by 1.6. Can you tell me what you will get as 15 by 1.6? Yes, Shreyas, you are correct. Surjit, you are correct. Kunal, you are correct. Shovik, you are correct. Abhi, you are correct. Tell me. What you are getting here? 15 by 1.6. It is coming out to be 9.375. Second reduction. 9.375 divided by 1.6. What you are getting here? 5.85. So it is clear that two reductions are not enough. So we would be going for the third reduction to reach to the 5. So 5.85 divided by 1.6. Okay, we will not go for the complete 1.6, but we will reach to the 5. 3 reductions are required. Okay, guys. The second method is draw reduction ratio method. So when we are talking about the draw reduction ratio method, here, my dear, some ratios are defined. Here they are saying for the first reduction, 50% is the maximum. Second reduction, 30%. Third, 25. Fourth, 16. Fifth, 13. So here you can write D minus D1 by D1 into 100 is 50. Then D1 minus D2 by D2 into 100. Sorry, by D1 into 100. This is D. D1 minus D2. Okay. D1 into 100. That is 30. Then D2 minus D3 by D2 into 100. It is 25. And so on. Okay. So this ratio will be given in the GATE exam if the question will be coming from here. And if it is coming in engineering services, then you need to remember this. Everybody got it? Any doubt, please ask. So from here you can calculate D1. From here you can calculate D2. From here you can calculate D3 and so on. Clear for everyone, guys? Guys, in the below link, is given, like you can see in the comment section. If you want one-to-one counseling for any exam, GATE, ESC, HPCL, IOCL, ONGC, BARC, whatever exams are happening, then the link is there in the comment section. You can fill the Google form. Okay. Fine, guys. Okay, guys. Second method can come in GATE also. If it is coming in GATE, this will be given to you. Ha, Vinay, before Sunday you will get that video. It is already been recorded. Just some editing is required, so that we will be doing. Actually, it was a recorded video, na? So in between something is going to be cut. Actually, in between electricity gone and smart board switched off. So that part I need to remove from there. Okay, that's why just I am not getting the time for that. Video is recorded last Sunday. Okay, moving further. Before this Sunday you will get, maybe tomorrow it will be uploaded. Most probably tomorrow will be uploaded. Otherwise Sunday is the last deadline. Okay, so don't worry. So my dear, now we are going to talk about the force requirement in the deep drawing operation. So when we are talking about the force requirement in the deep drawing operation, it is sigma y into pi d1t into d by d1 minus c. This is the force requirement in the first drawing operation. As we know, deep drawing is a multi-pass operation. So in the very first time, this much will be the force required. Then the second drawing operation would be having sigma y into pi d2t into d1 by d2 minus c. In the third drawing operation, we will be having sigma y pi d3t into d2 by d3 minus c. Work done is force into the distance traveled. So when you are going to have the first deep drawing operation, this is h1, this is d1. Then work done is f1 into h1. Second, when you are going to convert it into d2 into h2, already h1 is traveled. Work done will be f2 into h2 minus h1. Work done third is f3 into h3 minus h2. So likewise, we can calculate the work done for various processes. Is it clear for everyone? Please tell me that. Clear for everyone? Please tell me that. Yes, dear. Question can come from this. Till date, record is very poor, frequency is very less, but still I am teaching now. Okay, so it can come, that's why I am teaching. Okay, guys. So I am not going for the defects. Defects you will do by yourself. Okay, that is the wastage of time. And even I have seen students are not interested in marathon for these things. They are saying that we can do the defects by our own. Okay, so guys, now we are reaching to the last operation, that is bending. Last operation is bending. And still if you find anything problematic, you say, sir, I want help in these defects, welding defects, forming defect. You can inform me on my Telegram. If you require for any particular defects or any topics, we can go on any other like material size marathon will be coming. So production 2 marathons are left. In that we will be coming out. So there is no problem. Okay, now we are talking about the next thing, but I am telling you deep drawing defects are important than welding and casting defects. Now we are talking about the next operation, that is bending. Bending. So my dear, bending, I feel everybody know, let us say this is the length L and I am going to bend it like this. I am going to bend it like this. Okay, so you try from the notes. If you still find any difficulty with the defects, tell me. In the next session, last 1 hour, I will give to all the defects together. Casting defect, welding defect, मेरे defect, तुम्हारे defect, इसके defect, उसके defect, सब ले लेंगे एक साथ. ठीक है? Yes. Now, my dear, we are talking about the bending. And when I am talking about the bending, let us say this is A. This is B. This is B. So total length L is A plus B plus B. And this capital B is said to be the bend allowance. Capital B is said to be the bend allowance. And when we are talking about the bend allowance, you know there would be some neutral fiber. And the radius of neutral fiber is Rn. Angle of bending is theta. So bend allowance can be written as Rn into theta. The inner radius is R. So Rn can be written as R plus Kt. K is said to be the stretch factor. From this, once question have been asked, what is the bend allowance? Is it clear? Okay. Fine, Ashray. Moving further. Any doubt, guys? Please ask. This is, we have already seen the bend allowance. And my dear, K will be 1 by 2 if R more than 2T. K will be 1 by 3 if R less than 2T. So this condition is also mentioned. Then my dear, we are going to have bending. It is a sheet metal forming operation. Stress will be more than yield, less than ultimate. Then there is a defect in bending. We are calling it as spring back effect. We are going for that. First solve this question. A 2 mm thick metallic sheet is to be bent at an angle of 1 radian with bend radius of 100 mm, stretch factor 0.5. Find out bending allowance. Bend allowance is R plus Kt into theta. Here theta will always be in radian because it is coming without sine and cos. Find out and get the answer. Solve and get the answer, guys. Solve and get the answer, guys. Yes. 101 will be coming. 100 mm. Very good, guys. Next is the type of bending. This is the U type of bending. It is used to make the spherical bowls like this. Here you can see more area is coming in contact with the workpiece. This is the width of die opening. We are having the second bending as V bending. Here we are going to fold the sheet like this. Here width of die opening is lesser than U bending. Less area is coming in contact. If you want to just bend the sheet from here, we call it as edge bending. Here width of die opening is even smaller. And whenever we are talking about the ratio of force in U bending to the force in V bending to the force in edge bending, it is always coming out to be in the ratio of 4:2:1 or 4:2:1. Okay. 2:1:0.5. Both can be the right answer. Shovik, actually till date there is no question from that, but I cannot say कि question will not come from that. Till date there is no question from the deep drawing force requirement. But I feel it can come. Because when they have mentioned analysis, forces you should remember. Okay, in production they are asking anything nowadays. So nowadays no one can take guarantee of theirs. Okay, they are asking anything. Okay. Fine, guys. So with this, we have done. There are some questions. If you want, we can do some questions. 3-4 questions to complete it. Okay. So 10 mm diameter hole are to be punched in a sheet. So 10 mm diameter hole. So they have given you hole size. Hole size means punch size is given. 3 mm thickness, shear strength is 400, penetration is 40%, shear provided on the punch is 2 mm. the blanking force required. Sujit, mechanics marathon would be in the next week. Okay, I have shown you, I feel, the schedule now. I will once again show you at the end. Don't worry. Ajay, I am coming on to the second one after this question. Na? After this question, I am coming on to the second one. Don't worry. First, solve this question. Give me the answer for this. You know that F into KT plus I, and they have given the shear I is 2 mm. Solve it and get the answer, guys. Solve it and get the answer. They have given, first of all, force is tau ultimate into pi dt. Okay, so tau ultimate is 400. Pi into 10 into 3. This will give you the F value. What you are getting from here, can you tell me? What you are getting from here, can you tell me? Yes, yes, yes. बस ये बता दो कि यहां पे क्या आ रहा है. Okay, now find out this also. Here you are getting 37.69. Or here you are getting this. Are you giving me the answer or... Okay, you are saying the answer to be 37.69. Okay. Fine, guys. So as some of you were saying, sir, you have discussed only the one case. So I am telling you the second case, how to reduce the force. Let us say if in a sheet you want to produce 2 holes. Let us say in a sheet, if you want to produce 2 holes. And if you want to produce 2 holes, and this hole is bigger and this hole is smaller. To produce this hole, obviously bigger punch will be required. To produce this hole, smaller punch will be required. Smaller means diameter is lesser. And let us say here 200 kilonewton would be required to punch the hole, and here 50 kilonewton is required to punch the hole. And I want to perform both the operations together. Then you know overall I need to provide 250 kilonewton of force. If I will be providing 250, sheet will also be providing 250 kilonewton. Darshan, don't worry, I am coming back, don't worry. So my dear, if that is the case, there was a suggestion given कि if we are going to keep this punch like this, like this. Now, when this punch will be making the hole, this will not be making. And when this will be making the hole, this have already made. So at this time, when this will be making hole, 200 kilonewton would be required. And when this will be making the hole, only 50 kilonewton would be required. So never the force coming onto the punch will be more than 200 kilonewton. It will always be less than 200. Wherever in this case, it is coming out to be 250 kilonewton. Are you getting it? And this is said to be the staggering of punch. I'm coming out to the question. I know the answer is 22.6 kilonewton. I was waiting for the answers. So I thought ki I will tell you this second thing which some student have asked. That's why I did not take any answer in the previous question. Okay, so I was also waiting for you. Is it clear for everyone? This is said to be the staggering of punch. Please tell me this, everybody understood or not. If you are going to have two punch together, 200 plus 50, 250 kilonewton is required. But if I am going to make the difference of height in the punch, first this hole will be produced, then this hole. At one time, not more than 200 kilonewton will be required. So the force coming onto the punch will also be lesser. That is the second way to reduce the force requirement during punching and blanking operation. In the previous question, 37.7 you will be getting here, and FB will be coming out to be 22.6 kilonewton. A is the right answer for this. Clear? That is what you want to say. Am I correct? Bolo bhai. Very good, Abhi. Very good, guys. Very good, guys. Very good, guys. अब मुझे लग रहा है कि थोड़ी देर और मैं खड़ा रहा तो खड़ा ही रह जाऊंगा. Okay, guys. So I feel everybody is okay. Now the last thing I am going to discuss is spring back effect. Now we are going to discuss the last thing, that is spring back effect. What is spring back effect? What is spring back effect? So my dear, whenever we are going to have something like today, I don't have the notebook with me. Otherwise, I would be showing you. But you know, I have done many times. Like whenever I am going to bend this, you know, whenever we are going to bend it up to elastic limit, it is coming back. Because we are loading up to elastic limit. And after loading beyond elastic limit, if you are going to bend it like that up to this point, it is not going to remain here. It is coming back by some amount. And that is said to be elastic recovery. If you remember, I taught you that in the strength of material. In the strength of material, you must have studied when we are going to have this stress strain diagram like this. If you are going to load up to this, then unloading will make you reach here. And this was said to be the spring back effect. Actually, this was elastic recovery. But my dear, this elastic recovery in the bending is known as spring back effect. In the bending, we call it as spring back effect. Clear or not? Please tell me that. Clear or not? Please tell me that. It is said to be spring back effect. It is said to be spring back effect. And this is a defect in bending. Because if we are going to bend something by some angle and it is coming back, we will not be getting the desired size, na? So that is why spring back effect is considered. Spring back effect is considered as a defect of bending. Is it clear for everyone? Okay, Sumit. Actually, there are many such things which are already copied. Okay, so now many people have just doing the same things, because in online it is very easy to copy the things. But it's fine if in that way students are getting better things. That's great. I'm happy with that. Okay, guys, so let us move further. Let me see. These all questions, guys, if you want, you can do. You will be getting this PDF. Okay. This is the formula for force required in the bending. In the bending, the force required is given as sigma y LT square C by W. Here sigma y is yield strength of the material, L is length of the sheet, T is the thickness of sheet, W is width of die opening, C is die opening factor. This have already been appeared once in exam. So don't take it lightly. Is it clear? So guys, this is the force required in the bending operation. And my dear, when we are talking about, you have seen that. You can see this. Okay. So this is the force required in the bending operation. Spring back effect I already taught to you. And spring back effect experimentally, when we see that it depends on which factor. So my dear, spring back effect is directly proportional to the radius of bending. If radius of bending is less, spring back effect will be less. If radius of bending is more, spring back effect will be more. Here spring back effect less, here spring back effect more. Spring back effect is directly proportional to yield strength. Yield strength is more, spring back effect will be more. It is directly inversely proportional to thickness, inversely proportional to Young's modulus. So I am saying spring back effect directly proportional to radius, yield strength, inversely proportional to thickness, Young's modulus. Remember this, you may get the question from that. So guys, with this we have completed these things. Now let us see the types of die, and with that we will complete the today's wonderful session. The last heading we are moving to, the types of dies. This miscellaneous operation I will teach you in the metal forming, so don't worry about that. Because miscellaneous operations are the combined operations. Some are there from sheet operation, some are there from the bulk metal forming. So that we will see together. Here we are going for the types of die. So guys, whenever we are talking about the very first type of die, that is said to be the simple die. So simple die is the same for which we are talking about from the starting, where we are going to have a punch, we are going to have a sheet, we are going to perform a operation which is either blanking or punching or deep drawing. So if one operation is going to be carried out at one time, at one instant, in one stroke, we call it as simple die. But my dear, if you see the second case, compound die, here you can see first of all this bigger punch is cutting a blank from this sheet, and because of this third punch, this sheet is going to get a hole inside. So first we have performed blanking on the bigger sheet, then we have done punching on the smaller disc. Two operations of the same type are performed at one location, on one machine, at one location, in one stroke. We call it as compound die working. Shovik, I will show you the schedule. I feel material science marathon would be there on the next Saturday. And then on Sunday we have the production last marathon. Okay. So rest two, I am going for 4 more marathon. 2 marathon will be on this Saturday, Sunday. Next 2 marathon will be on next Saturday, Sunday. So I will be there on weekends with you now. Okay. And rest days I will be coming up with the practice sessions. Someday engineering mechanics, someday strength of material, someday machine design, someday theory of machine, someday production. So for practice session, I will keep on meeting you. But now my all 4 marathons are on weekends. This weekend you have Tom MD. Next weekend we have production, which is material science and metal cutting, both. Okay, vibration is also going to be included there only. Don't worry. But it is on weekend now. Now after that, after 2 days, I will be meeting you on Saturday, Sunday. Then 1 more Saturday, Sunday. Moving further, guys. Next is the combinational die. So combinational die is when we are going to perform 2 different type of operation at one location at one time in one stroke. Like here, the bigger sheet is getting cut. That is the blanking operation. And now that cutted blank is going to convert into this glass, that is deep drawing operation. Deep drawing is sheet metal forming. Blanking is sheet metal cutting. 2 different types of operation at one location on one machine at one time in one stroke is combinational die. Clear, guys? Any doubt, please ask. We are about to complete. And if you remember just now, I already told you this staggering of punch. This is said to be progressive die working. What is progressive die working? Here 2 operations of same type are performed at different location on one machine in one stroke. So at 2 different locations, so we call it as progressive die working. We have studied 4 types of dies: simple die, compound die, combinational die, progressive die. With this, sheet metal operation is over, and miscellaneous sheet metal operations, powder metallurgy, that everything will be covered with the material science. Okay, so don't worry. Now I would be meeting you for 4 more marathons on Saturday, Sundays, and also for engineering mathematics from 21st to 30th. Every alternate day, one topic. Okay. One day matrix, one day differential equation, then complex number, then numerical method, everything would be covered. So guys, I feel overall around 10 hours are over from the morning we are together, and I feel you guys got a lot of things from today's session. And I have done in a very nice manner all the 3 topics. Okay, so promise is fulfilled. And thanks for your cooperation, guys. And I want the same cooperation from yours in the other marathon. Don't worry about the aptitude. I am telling you 2 things for the aptitude. First of all, this weekend, clash is been removed. Clash will not be there now. Second thing, aptitude marathons would be there on this channel separately for you. Okay, YouTube, we have different sessions, so don't worry. On YouTube, we are having a separate plan for maths and apti from 21st to 30th. So don't worry about that. Already on those 11 days, you have 11 classes, 6 of maths, 5 of aptitude. Richa ma'am would be taking the aptitude, maths I will be taking. Okay, so don't worry. Those sessions are there from 21st to 31st. Okay, from 21st to 31st, you have maths apti session. Schedule I will be sharing with you. Don't worry. Today night or tomorrow morning, you will get the correct schedule with the timings as well. But I have given you already the timeline. I feel you got it. कोई बात नहीं सुरजीत, अभी तक नहीं किया तो आप कर लो, ठीक है? Okay. So guys, goodbye for this particular session now. And once again, I would like to tell you, I will show you the schedule, don't worry. Okay. Let me make this PPT to go in the starting very fast, very fast, very fast. So whatever we have seen, I am showing you. Practice session would be there on Saturday for casting, so don't worry about that. Be ready for that. Each and everything would be there in a great detail. Okay guys, this is the schedule in front of you. You can see this is the schedule in front of you. Tomorrow, basic thermodynamics. 13th, 14th, mark in your calendar. These 2 days are booked. I will be taking Tom, I will be taking machine design. Don't miss them. I want all of you to present. Great Shovik. So my dear, Tom and machine design will be on 13th and 14th. Then 15th industrial, 16th engineering mechanics, 17th applied thermodynamics, 18th HMT, material science on 19th, and metal cutting, metrology and sim on 20th. Okay, if on Tom day vibration will not be over, then in any of the day when you will be having the smaller marathon, then 3-4 hours vibration will be managed. I will try to complete vibration in Tom only. But if not possible, we will be having any of that day. But by 20th, you would be free with all the sessions. After that, you have engineering mathematics and aptitude. So be ready for that. Great, Kunal. That's wonderful. So thanks, guys. We will be meeting tomorrow, and if you want one-to-one counseling, the Google form is available in the below section of this session. You can also share with your friend if anybody else is interested, if he is having any doubt about the gate. So goodbye guys for this particular session. Thanks guys. Formula series is also there, dear, but in formula series we will cover one subject in 1 hour. In formula series we will cover one subject in 1 hour. And those 10 hours, 10 subject, those PDFs, you will keep with you before exam day. Those 10 PDF will help you to revise entire syllabus. Here we are covering one subject in 12-15 hours. There we will cover in 1 hour only formula we will show. We will not tell you where in this formula what is sigma y. You have to understand that at that time. That's why marathons we are studying. Dear, 2 days PPT will not be available because I feel in this smart board there is some issue. Okay, but that's why I have already shared you the handwritten notes, and whatever I said now, everything is typed in this PPT. I will share the PPT, but whatever I have written, that will not be available, because whatever I have written, that is available on that. The same thing is written in the language. There is no problem. Okay, so for this you need not to worry. फॉर्मूला सीरीज टाइमिंग अभी टाइम है यार, 21 तारीख को बता देंगे जब शुरू होगी. थोड़ा सा वेट कर लो. थैंक्स राजा, थैंक्स कुंदन, थैंक्स. ओके, फाइनली गुड बाय गाइस. पीपीटी में अपलोड कर दूंगा, बट इस पे एनोटेशन नहीं आई होंगी. ठीक है, स्मार्ट बोर्ड में थोड़ा सा इशू है, बट डोंट वरी, अगले 2 सेशन में जो लूंगा, क्योंकि वो डिजाइन वाले हैं, देयर यू विल गेट द पीडीएफ. इन प्रोडक्शन एक्चुअली वट एवर इज रिटन इन द पीपीटी, द सेम आई हैव टोल्ड. सो हियर दैट एनोटेशन हैव नो मीनिंग एक्चुअली. Okay, so don't worry, and I have already provided you the notes, but in the tome and empty marathon, I will take on that board where annotations would be there. Okay, so don't worry about that. Goodbye.